Data generated by companies and individuals like us has grown massively over the past decade. As per Statista.com, the global data generated and consumed would reach 181 zettabytes by 2025. Organizations need to gather and analyze such large volumes of data and look at their past business performances as well as results and use that information to prepare for the future. That essentially is data analytics. So hey everyone, welcome to this interesting video tutorial of Data Analytics Full Course 2022 by Simplilearn. This video will help you gain all the necessary skills and knowledge within 12 hours to become a data analyst in 2022. Our experienced trainers will take you through the course. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update from us. So let's look at the topics we'll be learning in this video. We'll start by understanding the basics of data analytics and learn the top 10 data analyst skills for 2022. After that, we learn the top 10 data analysis tools, followed by looking at a use case in Python. Next, you'll get an idea of how to manipulate and visualize data using R packages, and then look at time series analysis in R. Then we'll shift our focus to understanding data analytics using Excel pivot tables and learn to create Excel dashboards. Moving further, you'll see some interesting data analytics projects related to coronavirus, Spotify, World Happiness Report, and Olympics. Finally, we will learn some of the important questions that are asked frequently in data analytics interviews. So, let's get started.
Hi guys. Welcome to another video tutorial by Simplilearn. In today's session, we will look at data analytics for beginners. But before we begin, make sure to subscribe to our channel and hit the bell icon to never miss an update. In this video, we will discuss what data analytics is and the need for data analytics. Then, we will look at the different ways in which data analytics can be used, followed by the various steps involved in the data analytics process. After that, we will get an idea about the different tools used in data analytics and the companies using data analytics. Moving forward, we will see a case study on how Walmart uses data analytics for better customer service. And finally, we will perform a regression analysis in R to predict sales based on the advertising expenditure from three mediums: TV ads, radio ads, and newspaper advertisements. So what is data analytics? Companies around the world are generating vast volumes of data every hour. This data could be in the form of log files, web server and transactional data, as well as various customer-related data. Also, data is being generated at a rapid rate from social media websites and applications such as Facebook, Instagram, Twitter, and WhatsApp. Companies want to use this data to derive value out of it and make business decisions. That's where data analytics comes into use. Data analytics is the process of exploring and analyzing large data sets to find hidden patterns, unseen trends, discover correlations, and valuable insights to make business predictions. Data analytics improves the speed and efficiency of your business. A few years ago, a business would have gathered information manually, performed statistical and complex analytics, and unearthed information that could be used for future decisions. But today, that business can identify insights on the fly for immediate decisions. Most organizations have big data, and many understand the need to harness that data and extract value out of it. So, they use a lot of modern tools and technologies to perform data analytics. Some of the tools I will discuss in detail later in this tutorial. Now that we have looked at what data analytics really is, let us understand the ways in which you can use data analytics. First is improved decision making. Data analytics eliminates a lot of guesswork and manual tasks from choosing the right content, planning marketing campaigns, and developing products. Organizations can use the insights they gain from data analytics to make informed decisions, leading to better outcomes and customer satisfaction. It gives you a 360-degree view of your customers, which helps you understand their behavior completely, enabling you to better meet their needs. Second is better customer service. Data analytics provides you with more accurate insights of your customers, allowing you to tailor customer service to their needs, provide more personalization, and build stronger relationships with them. Your data can reveal information about your customers' communication preferences, their interests, their concerns, and more. It helps you give better recommendations for products and services. Next is efficient operations. Data analytics can help you streamline your processes, save money, and boost production. When you have an improved understanding of what your audience wants, you waste less time in creating ads and content that don't match your audience interests. This helps you optimize your campaigns, create better content strategies, and hence improve results. And finally, we have effective marketing. When you understand your audience better, you can market to them more effectively. Data analytics also gives you useful insights into how your campaigns are performing so that you can fine-tune them for optimal outcomes. You also find out the probable customers who are the most likely to interact with a campaign and convert into leads. Now, let's discuss the various steps involved in the data analytics process. As you can see on the screen, there are 5 process steps. Now let me make you understand each of this one by one. So the first step is to understand the problem. Before starting with the analysis, you need to understand the business problem and define your goals. Asking questions at the outlet is vital because this would address issues such as how can we reduce production costs without sacrificing quality? What are some of the ways to increase sales opportunities with our current resources? Do customers view your brand in a favorable way? Answers to these questions will help you build a clear roadmap with lucrative solutions. Also, try to find out the key performance indicators and consider the matrix to track along the way. The second step in the process is data collection. After you have finalized your goals, it's time to start looking for your data. Data collection is the process of gathering information on targeted variables identified as data requirements. The emphasis is on ensuring accurate and right data is collected. Data collection starts with primary sources, which are also known as internal sources. This is typically structured data gathered from CRM software, ERP systems, marketing automation tools, and others. These sources contain information about customers, finances, gaps in sales, etc. Under external sources, you have both structured and unstructured data. So, if you are looking to perform a sentiment analysis towards your brand, you would gather data from various review websites or social media apps. The next step is to clean the data. The data which is collected from various sources is highly likely to contain incomplete, duplicate, and missing values. So, you need to clean these unwanted redundant data to make it ready for analysis. So to generate accurate results, analytics professionals must identify duplicate and anomalous data and other inconsistencies that could skew the analysis. According to a report, 60% of data scientists say most of their time is spent cleaning the data, while 57% of data scientists say it's their least enjoyable task. Now the fourth step in the process is data exploration and analysis. Once data is cleaned and ready, you can go ahead and explore the data using data visualization and business intelligence tools. You can also use various data mining and predictive modeling techniques to analyze the data and build models. You can use different supervised and unsupervised algorithms such as linear regression, logistic regression, decision tree, KNN, k-means clustering, and lots more to build prediction models for making business decisions. And the final step is to interpret the results. This part is important because it's how a business will gain actual value from the previous 4 steps. Interpreting the results will help you find unseen trends and patterns in the data and gain insights. You can have a validation check if the results are answering your questions. These results can be shown to your clients and stakeholders for better understanding and business collaboration. Now that we have looked at the various steps involved in data analytics, let's now see the different tools that can be used to perform the above steps. So as you can see, we have 7 tools including a few programming languages that will help you perform analytics better. Now let's discuss them one by one. First, we have Python. Python is an object-oriented open-source programming language that supports a range of libraries for data manipulation, data visualization, and data modeling. Python programmers have developed tons of free and open-source libraries that you can use. You can find many of them via the Python package index, which is pypi, the repository of Python software. Python provides the default package installer called pip or pip. Python has libraries such as NumPy for numerical computation of data, pandas to manipulate data on numerical tables and time series. Then you have SciPy for technical and scientific computations. It also provides scikit-learn, which is a machine learning library for creating classification, regression, and clustering algorithms. And finally, it also has PyTorch and TensorFlow for deep learning. Up next, we have R. R is an open source programming language majorly used for numerical and statistical analysis. It provides a range of libraries for data analysis and visualization. Some of these libraries are ggplot, tidyverse, plotly, dplyr, and caret. Then we have Tableau. Tableau is a popular data visualization and analytics tool that helps you create a range of visualizations to interactively present the data, build reports, and dashboards to showcase insights and trends. It can connect with multiple data sources and give hidden business insights and patterns. Then we have a competitor of Tableau, which is Power BI. Power BI is a business intelligence tool developed by Microsoft that has an easy drag and drop functionality and supports multiple data sources with features that make data visually appealing. Power BI supports features that help you ask questions to your data and get immediate insights. You can also forecast your data for predicting future trends. So the next tool is QlikView. QlikView provides interactive analytics with in-memory storage technology to analyze vast volumes of data and use data discoveries to support decision making. It provides social media discovery and interactive guided analytics. It can manipulate huge data sets instantly with accuracy. Up next, we have Apache Spark. Apache Spark is an open source data analytics engine to process data in real time and carry out complex analytics using SQL queries and machine learning algorithms. It supports Spark Streaming for real-time analytics and Spark SQL for writing SQL queries. It also has Spark MLlib, which is a library that has a repository of machine learning algorithms, and then it has GraphX for graphical computation. And finally, we have SAS. SAS is a statistical analysis software that can help you perform analytics, visualize your data, write SQL queries, perform statistical analysis, and build machine learning models to make future predictions. SAS empowers our customers to move the world forward by transforming data into intelligence. SAS is investing a lot to drive software innovation for analytics. Gartner has positioned SAS as a Magic Quadrant leader for data science and machine learning. Moving on to the applications of data analytics. Data analytics is being used in almost every sector of business these days. Let's discuss a few of them. First, we have retail. Customers expect retailers to understand exactly what they need and when they need it. Data analytics helps retailers meet those demands. Retailers not only have an in-depth understanding of their customers, but they can also predict trends, recommend new products, and boost profitability. Retailers create assortments based on customer preferences, invoke the most relevant engagement strategy for each customer, optimize supply chain and retail operations at every step of the customer journey. The second application is on healthcare. Healthcare industries analyze patient data to provide life-saving diagnosis and treatment options. They also deal with healthcare plans and insurance information to drive key insights. Using analytics, they can discover new drugs and come up with new drug development methods. Advanced analytics allows healthcare companies to improve patient outcomes and experience. Cancer cells and diabetic retinopathy can be discovered using medical imaging. At number 3, we have manufacturing. For manufacturers, solving problem is nothing new. They fight with difficult problems and situations on a daily basis. From complex supply chains to motion applications to labor constraints and equipment breakdowns, they deal with such problems on a regular basis. Using data analytics, manufacturing sectors can discover new cost-saving and revenue opportunities. The fourth application is related to the banking sector. Banking and financial institutions collect vast volumes of structured and unstructured data to derive analytical insights and make sound financial decisions. Using analytics, they can find out probable loan defaulters, customer churn-out rate, and detect fraudulent transactions immediately. The final application is based on logistics. Logistics companies use data analytics to develop new business models that can ease their business and improve productivity. They can optimize routes to ensure delivery reaches on time in a cost-efficient manner. They also focus on improving order processing capabilities as well as performance management. With that, now let's look at the companies using data analytics on a daily basis. So we have the e-commerce giant Amazon, then we have Accenture, followed by the American Healthcare Service Organization, Cigna. Then we have the American supplier of health information technology solutions, services, devices and hardware, Cerner, followed by Target and antivirus company McAfee. Next, we have Rapido, which is an Indian bike rental company based in Bangalore. After that, we have Flipkart and the world's largest retail company, Walmart.
So, sky's the limit on what you use it for. Let's take a look at types of data analytics. And this can be broken up in so many ways, but we're going to start with looking at the most basic questions that you're going to be asking in data analytics. And the first one is you want descriptive analytics. What has happened? Hindsight. How many sales per call ratio coming out of the call center? If we have 500 tourists in a forest and you have a certain temperature, how many fires were started? How many times did the police have to show up to certain houses? All that's descriptive. The next one is predictive. Predictive analytics is what will happen next. We want to predict. This is great if you have an ice cream store and you want to predict how many people to work at the ice cream store on a certain day based on the temperature coming up and the time of the year. And then one of the biggest growing and most important parts of the industry is now prescriptive analytics. And you can think of that as combining the first two. We have descriptive and we have predictive, and then you get prescriptive analytics. How can we make it happen? Foresight. What can we change to make this work better? In all the industries we looked at before, we can start asking questions, especially in city development. There's a good one. If we want to have our city generate more income, and we want that income to be commercial based, what kind of commercial buildings do we need to build in that area that are going to bring people over? Do we need huge warehouse cells, Costco sales buildings, or do we need little mom and pop joints that are going to bring in people from the country to come shop there? Or do you want an industrial setup? What do you need to bring that industry in there? Is there a car industry available in that area? If it's not a car industry, what other industries are in that area? All those things are prescriptive. We're guessing. We're guessing what can we do to fix it? What can we do to fix crime in an area with education? What kind of education are we going to use to help people understand what's going on so that we lower the rate of crime and we help our communities grow better? That's all prescriptive. It's all guessing. We want foresight into how can we make it happen? How can we make this better? And we really can't not go into enough detail on these three, because a lot of people stumble on this when they come in and are doing analytics. Whether you're the manager, shareholder, or the data scientist coming in, you really need to understand the descriptive analytics, where you're studying the total units of furniture sold and the profit that was made in the past. Here we go into predictive analytics, predicting the total units that would sell and the profit we can expect in the future, gear up for how many employees we need, how much money we're going to make, and prescriptive analytics, finding ways to improve the sales and the profit so we can sell maybe a different kind of furniture, We're going to guess at what the area is looking for and how that marketing is going to change.
Hello everyone, we welcome you all to this video by Simplilearn. In today's session, we will learn a really interesting topic, that is the top 10 skills to become a data analyst in 2022. In today's digital world, data is being generated by companies and individuals every second, so the role of a data analyst holds supreme importance. So if you're looking for a career in data analytics, this video will help you learn what a data analyst does and the various skills you need to possess to become a data analyst in 2022. Before we get started, make sure you subscribe to the Simplilearn channel and hit the bell icon to never miss an update from us. Let's look at the agenda for this video. First, we will understand who a data analyst is. Then we will understand the top 10 data analyst skills for 2022. Moving on, we will look at the salary of a data analyst. And finally, we will look at the companies hiring data analysts. So now let's understand who is a data analyst. A data analyst is a professional who collects business data from various sources, interprets it, and uses various statistical tools and techniques to extract insights and useful information from it. They acquire data from primary or secondary data sources and maintain databases. They also recognize and understand the organization's goal and collaborate with different team members such as programmers, business analysts, and data scientists to build an effective solution to a business problem. Now, with this basic understanding of who a data analyst is, let's learn the top 10 data analyst skills for 2022. At number 1, we have Structured Query Language or SQL. SQL is a top skill that every data analyst should have. Data analysts use SQL commands and functions to store, process, analyze, and manipulate structured data using relational and NoSQL databases. They also build data models and write complex SQL queries and scripts to gather and extract information from several databases and data warehouses. Some of the popular databases a data analyst should be familiar with are Microsoft SQL Server, MySQL, PostgreSQL, and IBM DB2. The second important skill for a data analyst is Microsoft Excel. Microsoft Excel is one of the most popular and oldest spreadsheet applications for creating reports, performing calculations, and analyzing data. Data analysts need to know how to handle tabular data in Excel. So, they should be aware of features like sorting, filtering, conditional formatting, pivot tables, what-if analysis, and functions such as SUMIFs and COUNTIFs. The third crucial data analyst skill for 2022 is data cleaning and wrangling. Usually, the data collected by analysts from various heterogeneous sources is often messy and contains a lot of missing values. So, it is always crucial to clean the data and remove noise, missing, or erroneous elements. It is also important to format data using tools and methods before using it for analysis. They are responsible for data mining as well. The data mined from various sources are organized in order to obtain new information from it. Some of the tools you need to know for data cleaning and wrangling are Excel Power Query and OpenRefine. The fourth skill on our list is mathematics and statistics. Data analysts often work on data for higher dimensions that are greater than 3. In order to interpret such data, they need to be good at linear algebra and calculus. They also build predictive models and statistical models such as linear regression, logistic regression, naive Bayes, and k-means clustering. In order to understand the working of these algorithms, they must have knowledge about statistics and probability. Coming to the fifth important skill for a data analyst in 2022, we have programming. Data analysts need to master at least one programming language, preferably Python or R. In order to work with complex business problems, analysts need to write scripts and user-defined functions to automate tedious tasks. Python and R language provide a collection of different libraries and packages such as NumPy, Pandas, dplyr, matplotlib, ggplot, which data analysts can use to discover trends and patterns from complex data sets. After this, we have data visualization as our sixth skill. Another data analyst job role is to visualize large volumes of data and prepare summary reports and dashboards for the leadership team and clients so that they can make timely business decisions. To do this, data analysts use various data visualization tools such as Power BI, Tableau, and ClickView. Using these tools, data analysts can integrate various data sets, apply joint conditions, sort and filter data, as well create different visualizations using charts and graphs. The seventh skill for a data analyst is industry knowledge. Data analysts should have good knowledge and understanding of the industry or domain they are working in. For example, if you're working in a healthcare domain, you need to know how healthcare analytics can be applied to improve patient care. You should have knowledge about the challenges faced in healthcare and how you can leverage data and analytics to solve the issues. Only if you have strong industry knowledge can you try to improve the business. The eighth skill that is important for a data analyst in 2022 is problem solving. A business deals with several problems on a daily basis. Data analysts should be ready to face those challenges. Data analysts are expected to use their problem-solving skills, work with the team, troubleshoot what went wrong, and provide an effective solution via data analysis. A data analyst with good problem-solving skills can help a business identify current and potential issues and determine a viable solution based on the data it collects. The ninth skill on our list is analytical thinking. Data analysts need analytical thinking ability to break down a complex problem into simple components and resolve these components one by one. It is a must-have skill for data analysts. Analytical thinking includes deciding the parameters that need to be considered for defining data sets, analyzing them from different perspectives, and determining variable dependencies. Coming to the 10th skill among the top 10 skills for a data analyst in 2022, we have communication. Data analysts don't just interact with computers and programs, they also interact with team members, stakeholders, and data suppliers. So, good communication skills are essential. Data analysts also present their findings in front of an audience who might not be familiar with the analytical methods and processes. So they need to clearly translate their findings and insights into non-technical terms. So those were the top 10 skills a data analyst needs to possess in 2022. Do you think we missed out on any skills? Then please put your answers in the comment section below. Now let's look at the salary of a data analyst. According to Glassdoor, the average annual salary for a data analyst in the United States is $69,517. While in India, you can earn nearly 7 lakh rupees per annum. Finally, let's look at the top companies that are hiring data analysts in 2022. Here we have the consultancy and Big Four giant Deloitte and the pharmaceutical company Cerner Corporation. Then we have the tech giant IBM, retail company Walmart, and the e-commerce leader Amazon. To achieve the goals of data analysis, we use a number of data analysis tools. Companies rely on these tools to gather and transform their data into meaningful insights. So which tool should you choose to analyze your data? Which tool should you learn if you want to make a career in this field? We will answer that in this session. After extensive research, we have come up with these top 10 data analysis tools. Here, we will look at the features of each of these tools and the companies using them. So let's start off. At number 10, we have Microsoft Excel. All of us would have used Microsoft Excel at some point, right? It is easy to use and one of the best tools for data analysis. Developed by Microsoft, Excel is basically a spreadsheet program. Using Excel, you can create grids of numbers, text, and formulae. It is one of the widely used tools, be it in a small or large setup. The interface of Microsoft Excel looks like this. Let's now move on to the features of Excel. Firstly, Excel works with the Windows version of Excel supports programming through Microsoft's Visual Basic for Applications (VBA). Programming with VBA allows spreadsheet manipulation that is difficult with standard spreadsheet techniques. In addition to this, the user can automate tasks such as formatting or data organization in VBA. One of the biggest benefits of Excel is its ability to organize large amounts of data into orderly, logical spreadsheets and charts. By doing so, it's a lot easier to analyze data, especially while creating graphs and other visual data representations. The visualization can be generated from a specified group of cells. Those were few of the features of Microsoft Excel. Let's now have a look at the companies using it. Most of the organizations today use Excel. Few of them that use it for analysis are the UK-based company Ernst & Young. Then we have Urban Pro, Wipro, and Amazon. Moving on to our next data analysis tool, at number 9, we have RapidMiner. A data science software platform, RapidMiner provides an integrated environment for data preparation, analysis, machine learning, and deep learning. It is used in almost every business and commercial sector. RapidMiner also supports all the steps of the machine learning process. Seen on your screens is the interface of RapidMiner. Moving on to the features of RapidMiner. Firstly, it offers the ability to drag and drop. It is very convenient to just drag drop some columns as you are exploring a data set and working on some analysis. RapidMiner allows the usage of any data, and it also gives an opportunity to create models which are used as a basis for decision making and formulation of strategies. It has data exploration features such as graphs, descriptive statistics, and visualization, which allows users to get valuable insights. It also has more than 1,500 operators for every data transformation and analysis task. Let's now have a look at the companies using RapidMiner. We have the Caribbean airline Leeward Islands Air Transport. Next, we have the United Health Group, the American online payment company PayPal, and the Austrian telecom company Mobilcom. So that was all about RapidMiner. Now let's see which tool we have at number 8. We have Talent at number 8. Talent is an open source software platform which offers data integration and management. It specializes in big data integration. Talent is available both in open source and premium versions. It is one of the best tools for cloud computing and big data integration. The interface of Talent is as seen on your screens. Moving on to the features of Talent. Firstly, automation is one of the great boons Talent offers. It even maintains the tasks for the users. This helps with quick deployment and development. It also offers open source tools. Talent lets you download these tools for free. The development costs reduce significantly as the processes gradually speed up. Talent provides a unified platform. It allows you to integrate with many databases, SaaS, and other technologies. With the help of the data integration platform, you can build flat files, relational databases, and cloud apps 10 times faster. Those were the features of Talent. The companies using Talent are Air France, L'Oreal, Capgemini, and the American multinational pizza restaurant chain Domino's. Next on the list at 7 we have KNIME. Constance Information Miner on KNIME is a free and open source data analytics, reporting and integration platform. It can integrate various components for machine learning and data mining through its modular data pipelining concept. KNIME has been used in pharmaceutical research and other areas like CRM customer data analysis, business intelligence, text mining, and financial data analysis. Here is how the interface of KNIME application looks like. Now coming to the KNIME features. KNIME provides an interactive graphical user interface to create visual workflows using the drag and drop feature. Use of JDBC allows assembly of nodes blending different data sources, including pre-processing such as ETL, that is extraction, transformation, loading, for modeling, data analysis, and visualization with minimal programming. It supports multi-threaded in-memory data processing. KNIME allows users to visually create data flows, selectively execute some or all analysis steps, and later inspect the results, models, and interactive views. KNIME Server automates workflow execution and supports team-based collaboration. KNIME integrates various other open source projects such as machine learning algorithms from Becker, H2O, Keras, Spark, and our project. NIME allows analysis of 300 million custom addresses, 20 million cell images, and 10 million molecular structures. Some of the companies hiring for NIME are United Health Group, ASML, Fractal Analytics, Atos, and Lego Group. Let's now move on to the next tool. We have SAS at number 6. SAS facilitates analysis, reporting, and predictive modeling with the help of powerful visualizations and dashboards. In SAS, data is extracted and categorized, which helps in identifying and analyzing data patterns. As you can see on your screens, this is how the interface looks like. Moving on to the features of SAS. Using SAS, better analysis of data is achieved by using automatic code generation and SAS SQL. SAS allows you to access through Microsoft Office by letting you create reports using it and by distributing them through it. SAS helps with an easy understanding of complex data and allows you to create interactive dashboards and reports. Let's now have a look at the companies using SAS. We have companies like Genpact, IQVIA, Accenture, and IBM to name a few. That was all about SAS. So for all those who joined in late, let me just quickly repeat our list. At number 10, we have Microsoft Excel. Then at number 9, we have RapidMiner. At number 8, we have Talent. At number 7, we have NIME. And at number 6, we have SAS. So far, do you all agree with this list? Let us know in the comment section below. Let's now move on to the next 5 tools in our list. So at number 5, we have both R and Python. Yes, we have 2 of them in the 5th position. R is a programming language which is used for analysis as well. It has traditionally been used in academics and research. Python is a high-level programming language which has a Python data analysis library. It is used for everything starting from importing data from Excel spreadsheets to processing them for analysis. This is the interface of R. Next up is the interface of the Python Jupyter Notebook. Let's now move on to the features of both R and Python. When it comes to the availability of R and Python, it is very easy. Both R and Python are completely free, hence it can be used without any license. R used to compute everything in memory and hence the computations were limited, but now it has changed. Both R and Python have options for parallel computations and good data handling capabilities. As mentioned earlier, as both R and Python are open in nature, all the latest features are available without any delay. Moving on to the companies using R, we have Uber, Google, Facebook, to name a few. Python is used by many companies. Again, to name a few, we have Amazon, Google, and the American photo and video sharing social networking service, Instagram. That was all about R and Python. At number 4, we have Apache Spark. Apache Spark is an open source engine developed specifically for handling large-scale data processing and analytics. Spark offers the ability to access data in a variety of sources including Hadoop Distributed File System HDFS, OpenStack Swift, Amazon S3, and Cassandra. It allows you to store and process data in real time across various clusters of computers using simple programming constructs. Apache Spark is designed to accelerate analytics on Hadoop while providing a complete suite of complementary tools that include a fully featured machine learning library, a graph processing engine, and stream processing. So this is how the interface of Apache Spark looks like. Now let's look at the important features of Apache Spark. Spark stores data in the RAM, hence it can access the data quickly and accelerate the speed of analytics. Spark helps to run an application in a Hadoop cluster up to 100 times faster in memory and 10 times faster when running on disk. It supports multiple languages and allows the developers to write applications in Java, Scala, R, or Python. Spark comes up with 80 high-level operators for interactive querying. Spark code for batch processing, join stream against historical data, or run ad hoc queries on stream state. Analytics can be performed better as Spark has a rich set of SQL queries, machine learning algorithms, complex analytics, etc. Apache Spark provides fault tolerance through Spark RDD. Spark resilient distributed data sets are designed to handle the failure of any worker node in the cluster. Thus, it ensures that the loss of data reduces to zero. Conviva, Netflix, IQVIA, Lockheed Martin, and eBay are some of the companies that use Apache Spark on a daily basis. At number 3, we have another important growing data analysis tool, that is QlikView. QlikView software is a product of Qlik for business intelligence and data visualization. QlikView is a business discovery platform that provides self-service BI for all business users and organizations. With QlikView, you can analyze data and use your data discoveries to support decision-making. QlikView is a leading business intelligence and analytics platform in Gartner Magic Quadrant. On the screen, you can see how the interface of QlikView looks like. Now talking about its features. QlikView provides interactive guided analytics with in-memory storage technology. During the process of data discovery and interpretation of collected data, the QlikView software helps the user by suggesting possible interpretations. QlikView uses a new patent in-memory architecture for data storage. All the data from the different sources is loaded in the RAM of the system and it is ready to be retrieved from there. It has the capability of efficient social and mobile data discovery. Social data discovery offers to share individual data insights within groups or out of it. A user can add annotations as an addition to someone else's insights on a particular data report. QlikView supports mobile data discovery within an HTML5-enabled touch feature which lets the user search the data and conduct data discovery interactively and explore other server-based applications. QlikView performs OLAP and ETL features to perform analytical operations, extract data from multiple sources, transform it for usage, and load it to a data warehouse. The companies that can help you start your career in QlikView are Mercedes-Benz, Capgemini, Citibank, Cognizant, and Accenture, to name a few. At number 2, we have Power BI. Power BI is a business analytics solution that lets you visualize your data and share insights across your organization or embed them in your app or website. It can connect to hundreds of data sources and bring your data to life with live dashboards and reports. Power BI is the collective name for a combination of cloud-based apps and services that help organizations collate, manage, and analyze data from a variety of sources through a user-friendly interface. Power BI is built on the foundation of Microsoft Excel and has several components such as Windows desktop application called Power BI Desktop, and online software as a service called Power BI Service, mobile Power BI apps available on Windows phones and tablets, as well as for iOS and Android devices. Here is how the Power BI interface looks like. As you can see, there is a visually interactive sales report with different charts and graphs. Moving on to the features of Power BI. It has an easy drag and drop functionality with features that make data visually appealing. You can create reports without having the knowledge of any programming language. Power BI helps users see not only what's happened in the past and what's happening in the present, but also what might happen in the future. It offers a wide range of detailed and attractive visualizations to create reports and dashboards. You can select several charts and graphs from the visualization pane. Power BI has machine learning capabilities with which it can spot patterns in data and use those patterns to make informed predictions and run what-if scenarios. Power BI supports multiple data sources such as Excel, Text CSV, Oracle, SQL Server PDF, and XML files. The platform integrates with other popular business management tools like SharePoint, Office 365, and Dynamics 365, as well as other non-Microsoft products like Spark, Hadoop, Google Analytics, SAP, Salesforce, and MailChimp. Some of the companies using Power BI are Adobe, AXA, Carlsberg, Capgemini, and Nestle. Moving on to the next tool. So any guesses as to what we have at number 1? You can comment in the chat section below. Finally, on the top of the pyramid, we have Tableau. Gartner's Magic Quadrant of 2020 classified Tableau as a leader in business intelligence and data analysis. Tableau Interactive Data Visualization Software Company was founded in Jan 2003 in Mountain View, California. Tableau is a data visualization software that is used for data science and business intelligence. It can create a wide range of different visualization to interactively present the data and showcase insights. The important products of Tableau are Tableau Desktop, Tableau Public, Tableau Server, Tableau Online, and Tableau Reader. This is how the interface of Tableau Desktop looks like. Now coming to the features of Tableau. Data analysis is very fast with Tableau, and the visualizations created are in the form of dashboards and worksheets. Tableau delivers interactive dashboards that support insights on the fly. It can translate queries to visualizations and import all ranges and sizes of data. Writing simple SQL queries can help join multiple data sets and then build reports out of it. You can create transparent filters, parameters, and highlighters. Tableau allows you to ask questions, spot trends, and identify opportunities. With the help of Tableau Online, you can connect with cloud databases, Amazon Redshift, and Google BigQuery. The companies using Tableau are Deloitte, Adobe, Cisco, LinkedIn, and the American e-commerce giant Amazon, to name a few. And there you go, those are the top 10 data analysis tools.
Since this is data analysis with Python, we got to ask the question, why Python for data analytics? I mean, there's C++, there's Java, there's .NET from Microsoft. Why do people go to Python for it? So the number of reasons. One, it's easy to learn with simple syntax. You don't have a very high typeset like you do in Java and other coding, so it allows you to kind of be a little lazy in your programming. That doesn't mean that it can't be set that way and that you don't have to be careful. It just means you can spin up a code much quicker in Python. The same amount of code to do something in Python a lot of times is 1, 2, or 3, or 4 lines, where when I did the same thing, say in Java, I found myself with 10, 12, 13, 20 lines, depending on what it was. It's very scalable and flexible. So there's our flexibility because you can do a lot with it, and you can easily scale it up. You can go from something on your machine to using PySpark under the Spark environment and spread that across hundreds, if not thousands of servers across terabytes of data or petabytes of data. So it's very scalable. There's a huge collection of libraries. This one's always interesting because Java has a huge collection of libraries. C has a huge collection of libraries. .NET does, and they're always in competition to get those libraries out. Scala for your Spark. All those have huge collections of libraries. This is always changing, but because Python's open source, you almost always have easy to access libraries that anybody can use. You don't have to go check your licensing and have special licensing like you do in some packages. Graphics and visualization, they have a really powerful package for that, so it makes it easy to create nice displays for people to read. And community support. Because Python is open source, it has a huge community that supports it. You can do a quick Google and probably find a solution for almost anything you're working on. Python libraries. Let's bring it together. We have data analytics and we have Python. So when we're talking data analytics, we're talking Python libraries for data analytics. And the big 5 players are NumPy, Pandas, Matplot library, SciPy, which is going to be in the background, so we're not going to talk too much about the scientific formulas in SciPy, and scikit. So NumPy supports n-dimensional arrays, provides numerical computing tools useful for linear algebra and Fourier transform. And you can think of this as just a grid of numbers. And you can even have a grid inside a grid, or data. It's not even numbers because you can also put words and characters and just about anything into that array. But you can think of a grid, and then you can have a grid inside a grid, and you end up with a nice three-dimensional array. If you want to talk three-dimensional array, you can think of images. You have your 3 channels of color, 4 if you have an alpha, and then you have your XY coordinates for the image we're looking at. So you can go X, Y, and then what are the 3 channels to generate that color. And NumPy isn't restricted to 3 dimensions. You could imagine watching a movie. Well, now you have your movie clips, and they each have their X number of frames, and each of those frames have X number of XY coordinates for the pictures in each frame, and then you have your 3 dimensions for the colors. So NumPy is just a great way to work with n-dimensional arrays. Now closely with NumPy is pandas. Useful for handling missing data, perform mathematical operations, provides functions to manipulate data. Pandas is becoming huge because it is basically a data frame. And if you're working with big data and you're working in Spark or any of the other major packages out there, you realize that the data frame is very central to a lot of that. And you can look at it as a Excel spreadsheet. You have your columns, you have your rows or indexes, and you can do all kinds of different manipulations of the data within, including filling in missing data, which is a big thing when you're dealing with large pools or lakes of data where they might be collected differently from different locations. And Matplot library. We did kick over the SciPy, which is a lot of mathematical computations, which usually runs in the background of NumPy and Pandas. Although you do use them, they're useful for a lot of other things in there. But the Matplot library, that's the final part. That's what you want to show people. And this is your plotting library in Python. Several toolkits extend Matplot library functionality. There's like 100 different toolkits to extend Matplot library, which range from how to properly display star constellations from astronomy. There's a very specific one built just for that, all the way to some very generic ones. We'll actually add Seaborn in when we do the labs in a minute. Several toolkits extend Matplot library functionality, and it creates interactive visualization. So there's all kinds of cool things you can do as far as just displaying graphs, and there's even some that you can create interactive graphs. We won't do the interactive graphs, but you'll see, you'll get a pretty good grasp of some of the different things you can do in Matplot library. Let's jump over to the demo, which is my favorite. Roll up our sleeves, get our hands in on what we're doing. Now, there's a lot of options when we're dealing with Python. You can use PyCharm as a really popular one. And you'll see this all over the place. So it's one of the main ones that's out there, and there's a lot of other ones. I used to use NetBeans, which has kind of lost favor. Don't even have it installed on my new computer. But the most popular one right now for data science. Now, PyCharm is really popular for Python general development. For data science, we usually go to Jupyter Notebook or Anaconda. And we're going to jump into Anaconda because that's my favorite one to go to because it has a lot of external tools for us. We're not going to dig into those, but we will pop in there so you can see what it looks like. So with Anaconda, we have our Jupyter Lab, we have our Notebook. These are identical. Jupyter Lab is an upgrade to the Notebooks with multiple tabs. That's all it is. And we'll be using the Notebook. And you can see that PyCharm is so popular with Python that we even have it highlighted here in Anaconda as part of the setup. Jupyter Notebook can also be a standalone. So we're actually going to be running Jupyter Notebook. And then you have your different environments. We're going to be under main Py36. There's a root one. And I usually label it Py36. The reason is currently as of writing this, TensorFlow only works in 3.6 and not in 3.7 or 3.8 for doing neural networks. But you can actually have multiple environments, which is nice. They separate the kernels, so it helps protect your computer when you're doing development. And this is just a great way to do a display or a demo, especially if you're looking for that job. Pull up your laptop, open it up. Or if you're doing a meeting, get it broadcast up to the big screen so that the CEO can see what you're looking at. And when we launch the Notebook, it actually opens up a file browser in whatever web browser you have. This happens to be Chrome. And then you can just go under New. There's a lot of different options depending on what you have installed. Python 3. And this just creates an untitled version of this. And you can see here I'm actually in a Simplilearn folder for other work I've done for Simplilearn. And that's where I save all my stuff and I can browse through other folders, making it real easy to jump from one project to another. And under here, we'll go ahead and change the name of this, and we'll go ahead and rename it Data Analytics. Data Analytics. Just so I can remember what I was doing. Which is probably about 50 of the folders in here, or files in here right now. So let's go ahead and jump in there and take a look at some of these different tools that we were looking at. And as we go through the demo, let's start with the NumPy, the least visually exciting. And I'm going to zoom in here so you can see what we're doing. And the first thing we want to do is import NumPy. And we'll import it as NP. That is the most common NumPy terminology. And let's go ahead and change the view so we also have the line numbers. I don't know why, we probably won't need them, but I like it for easy reference. And then we'll create a one-dimensional array. We'll just call this array1, and it equals np.array, and you put your array information in here. In this case, we'll spell it out. You can actually do like a range and other ways. There's lots of ways to generate these arrays. But we'll just do 1, 2, 3, so 3 integers. And if we print our array1, we can go ahead and run this. And you can see right here it prints 1, 2, 3. You can see why this is a really nice interface to show other people what you're doing with the Jupyter Notebook. So this is the basic. We've created an array. This is a one-dimensional array, and then the array is 1, 2, 3. One of the nice things about the Jupyter Notebook is whatever ran in this first setup is still running. It's still in the kernel. So it still has the NumPy imported as NP, and it still has our variable ARR1 for array1 equal to NP array of 1, 2, 3. So when we go to the next cell, we can check the type of the array. We're just going to print. We say, hey, what is this setup in here? And we want type, and then we want what is the type of array1. And let's go ahead and run that. And it says class NumPy ND array. So it's its own class. That's all we're doing is checking to see what that class is. And if you're going to look at the array class, probably the biggest thing you do, I don't know how many times I find myself doing this because I forget what I'm working on, and I forget I'm working with a 3-dimensional or 4-dimensional array. And I have to reformat somehow so it works with whatever other things I have. And so we do the array shape. The array shape is just 3 because it has 3 members and it's a one-dimensional array. That's all that is. And with the NumPy array, we can easily access, stick with the print statement. If you actually put a variable in Jupyter Notebook and it's the last one in the cell, it will be the same as a print statement. So if I do this, where array1 of 2, it's the same as doing print array of 2. Those are identical statements in our Jupyter Notebook. We'll go and stick with the print on this one. And it's 3. So there's our print space 2, and we have 0, 1, 2. 2 equals 3. We can easily change that. So we have array 1 of place 2 equals 5. And then if we print our array 1, you can see right down here when it comes out, it's 1, 2, and 5. And there I left the print statement off because it's the last variable in the list. It'll always print the variable if you just put it in like that. That's a Jupyter Notebook thing. Don't do that in PyCharm. I've forgotten before doing a demo. And we talked about multiple dimensions, so we'll do an array, 2-dimensional array. And this is again a NumPy array. And in the NumPy array, we need our first dimension. We'll do 1, 2, 3, and our second dimension 3, 4, 5. And you can see right here that when we hit the, we'll do this. We'll just do array 2. And we can run that, and there's our array 2, 1, 2, 3, 3, 4, 5. We can also do array 2 of 1. And then we can do, let's do 0. Doesn't really matter which one. Actually, let's do 2. There we go. And if I run this, it'll print out 5. Because here we are. This is 0. 0, 1, 2, 3 is on our 0 row. 3, 4, 5 is on our 1 row. I always start with 0. And then the 2, 0, 1, 2 goes to the 5. And then maybe we forgot what we were working with. So we'll go do array2.shape. And if we do array2 of shape, we'll go and run that. We'll see we have 2 rows, and each row has 3 elements. Two-dimensional array, 2, 3. If you looked up here when we did it before, it just had 3, nothing. When you have a single entity, it always saves it as a tuple with a blank space. But you can see right here we have 2, 3. And if you remember from up here, we just did this array2 of, let's go, what is it, 1, 2. We run that, we get the 5. You can also count backwards. This is kind of fun. And you'll see I just kind of switched something on you because you can also do 1, 2 to get to the same spot. Now 2 is the last one, 0, 1, 2. It's the last one in there. We can count backwards and do -1. And if we run this, we get the same answer. Whether we count it as, let's go back up here, whether we count this as 0, 1, 2, or we count backwards as -1, -2, -3. And you can see that if I change this -1 to a -2 and run that, I get 4, which is going backwards, -1, -2. So there's a lot of different ways to reference what we're working on inside the NumPy array. It's really a cool tool. It's got a lot of things you can do with it. And we talked about the fact that it can also hold things that are not values, and we'll call this array ask for strings equals np.array. Put our setup in there, our brackets, and let's go China, India, USA, Mexico. It doesn't matter, we can make whatever we want on here. And if we print that out, we run this, you can see that we get our NumPy array, China, India, USA, Mexico. It even gives us our D type of a U6. And a lot of times when you're messing with data, we'll call this array R for range, just to kind of keep it uniform. np.arange. So this is a command inside NumPy to create a range of numbers. And if you're testing data, maybe you want, maybe you have equal time increments that are spaced a certain point apart. But in this case, we're just going to do integers. And we're going to do a setup from 0, 20, skipping every other one. And we'll print it out and see what that looks like. And you can see here we have 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Like you expected, it skips every one. And just a quick note, there's no 20 on here. Why? Well, this starts at 0 and counts up to 20. So if you're used to another language where it explicitly says less than or less than equal to 20, like for x equals 0, x plus plus, x is less than 20. That's what this is. It just assumes x is less than 20 on here. And if we want to create a very uniform set, 0, 2, 4, 6, what happens if I want to create numbers from 0 to 10, but I need 20 increments in there? We can do that with line space. So we can create an R, we'll call this L, equals, I don't think we'll actually use any of this again, so I don't know why I'm creating unique identifiers for it. But we'll do NP, lin space, and we're going to do 0 to 10, or 0 to 9. Remember, it goes up to 10. And then we want to, let's say we have 20 different increments in there. So we're creating we have a data set, and we know it's over a certain time period, and we need to divide that time period by 20. And it happens to just have 10 pieces in it. And here we go. You can see right here, we have 20, or it has 20 pieces in it, but it's over 10 years. And we got to divide it in the middle. And you can see it goes 0.52. Remember, yeah, there's our 10 on the end, so it goes up to 10. And then we can also do random. There's np.random. If you're doing neural networks, usually you start it by seeding it with random numbers. And we'll just do np.random, and we'll just call this array. We'll stop giving it unique numbers. We'll print that one out and run it. And you can see we have random numbers. they are 0 to 1. So you'll see that all these numbers are under 1, and you can easily alter that by multiplying them out or something like that if you want to do like 0 to 100. You can also round them up if it's integer 0 to 100. There's all kinds of things you can do, but it generates a random float between 0 and 1. And you have a couple options. You could reshape that, or you can just generate them in whatever shape you want. And so we can see here, we did 3 and 4, and so you can see 3 rows by 4 variables. Same thing as doing a reshape of 12 variables to 3 and 4. And if you're going to do that, you might need an empty data set. I have had this come up many times where I need to start off with 0, and I don't know, because I'm going to be adding stuff in there, or it might be 0 and 1, where 1 is, if you're removing the background of an image, you might want the background is 0, and then you figure out where the image is, and you set all those boxes to 1, and you create a mask. So creating masks over images is really big, and doing that with a numpy array of 0. And we can also give it a space. And we'll just do this all in one shot this time. And we'll do the same thing like we did before, zeros. And in this case, we'll do 2, 3. And so when we run this, forgot the asterisks around it. I knew I was forgetting something. There we go. So when we run this, you can see here we have our 10 zeros in a row, and maybe this is a mask for an image, and so it has 2 rows of 3 digits in it. So it's a very small image, little tiny pixel. And maybe you're looking to do something the opposite way. Instead of creating a mask of zeros and filling in with ones, maybe you want to create a mask of ones and fill them in with zeros. And we'll just do, just like we did before, we'll do 3, 4. And when we run this, you'll see it's all ones. And we could even do this even, we'll do it this way. Let's do 10 by 10 icon, and then you have your 3 colors. And you can, so it creates quite a large array there for doing pictures and stuff like that when you add that 3rd dimension in. If we take that off, it's a little bit easier to see. We'll do 10 again. And you can easily see how we have 10 rows of 10 ones. And you can also do something like create an array. And we'll do 0, 1, 2. And then in this array, we actually, we'll print it right out. We want a repeat. And so you can actually do a repeat of the array, and maybe you need this array, let's repeat it 3 times. So there's our repeat of an array, repeat 3 times. And if we run this, you'll see we have 0, 0, 0, 1, 1, 1, 2, 2, 2. And whenever I think of a repeat, I don't really think of repeating being the first digit 3 times, the second digit. I really always think of it as 0, 1, 2, 0, 1, 2, 0, 1, 2. It catches me every time. But the actual code for that one is going to be tile. And again, if we do arrange 3 and we run this, you can see how you can generate 0, 1, 2, 0, 1, 2, 0, 1, 2. And if you're dealing with an identity matrix, we can do that also if you're big on doing your matrices. And we'll just identity. I guess we'll go ahead and spell it out today. Matrix. And the command we're looking for is EYE. And we'll do 3. And then we'll just go ahead and print this out. There we go. There's our identity matrix. And it comes out by a 3 by 3 array, because there's our matrix. And then it puts the ones down the middle and for doing your different matrix math. And we can manipulate that a little bit too. We talk about matrices. We might not want ones across the middle, in which case we now have the diagonal. So we can do an np.diagonal. And we do a diagonal. Let's put in the diagonal 1, 2, 3, 4, 5. And when we run this, Again, this generates a value, and by just putting that value in, there's the same as putting print around it, or putting array equals and then print array. And you can see it generates a diagonal 1, 2, 3, 4, 5, and there's your beginning of your matrix array for working with matrices. And we can actually go in reverse. Let's create an array equals, remember our random random, and we'll do a 5 by 5 array. Oops, there we go. 5 by 5. And just so you can see what that looks like. Helps if I don't mistype the numbers, which in this case I just need to take out the brackets. And there you go, you have your 5 by 5 array set up in there. And we can now, because we're working with matrices, we might want to do this in reverse and extract the diagonals, which would be the 0.79, the 0.678, and so on. And we simply type in np.diagonal. We put our array in there. And this will of course print it out because it returns it as a variable. And you can see here's our diagonal going across from our matrix. And we did talk about shape earlier. If you remember, you can do print the shape out. You can also do the dimensions. So in dimensions, very similar to shape, it comes out and just has 2 dimensions. We can also look at the size. So if we do size on here, we can run that, and you can see it has a size of 25, 2 dimensions, and of course 5 by 5. And that was from the shape from earlier that we looked at. There's our 5 by 5 shape. And if you remember earlier we did random, well, you can also do random. I talked a little bit about manipulating 0 to 1 and how you can get different answers. You can also do straight for the integer part, and we'll do minus 10 to 10, 4. And so we're going to generate random integers between minus 10 to 10. We're going to generate 4 of those. And so when we run that, we have 7, minus 3, minus 6, minus 3. They're all between minus 10 and 10, and there's 4 of them. And now we jump into some of the functionality of arrays, which is really great, because this is where they come in. Here's your array, and you can add 10 to it. And if I run this, there it takes my original array from up here with the integers and adds 10 to all of those values. So now we have, oh, this is the decimal, that's right. This is a random decimal I had stored in an array. But this takes a random decimal, the random numbers I had from 0 to 1 and adds 10 to them. And we can just as easily do minus 10. We could even do times 2. And we could do divide by 2. And it'll take that random number we generated and cut it in half. So now all these numbers are under 0.5. Another way you can change the numbers to what you need on there. And as you dig deeper into NumPy, we can also do exponential. So as an exponential function, which should generate some interesting numbers off of the random. So we're taking them to the power, I don't even remember what the original numbers in the array were, because we did the random numbers up there. Here's our original numbers, and if you build an exponential on there, this is where you get e to the x on this. And just like you can do e to the x, you can also do the log. So if you're doing logarithmic functions, that reinforced learning, you might be doing some kind of log setup on there, and you can see the logarithmic of these different array numbers. And if you're working with log base 2, you can just change it in there, np log 2. You have to look it up, because this is not log 1, 2, 3, 4, 5. It is log and log 2. So just a quick note, that's not a variable going in. That is an actual command. There's a number of them in there, and you'll have to go look and see what the documentation is. But you can also do log 10. So here's log value 10. Some other really cool functions you can do with this is your sine. So we can take a sine value of all of our different values in there. And if you have sine, you of course have cosine. We can run that. So here's the cosine of those. And if you're doing activations in your NumPy array and you're doing a tangent activation, there's your tangent for that. And the tangent activation is actually from neural networks. That's one of the ways you can activate it, because it forms a nice curve between from whether you're generating 1 to -1 with some discrepancy in the middle. Just jumping a little bit in there into neural networks. And then we get into, let me just put the array back out there so that we can see it while we're doing this. As we're getting into this, you can also sum the values. So we have np sum, and you can do a summation of all the values in this array. And you'll see that if you added all these together, they'd equal 12.519, and so on. I don't know what the whole setup is in there. But you can see right here the summation of this. One of the things you can also do is by axes. So we could do axes equals 0. And if we run the summation of the axes equals 0, and you can think of that in NumPy as the rows. So that would be, or you can think of that in NumPy as being the columns. We're summing these columns going across. And you can also change this to 1, and now we're summing the rows. And so that is the summation of this row, and so forth going down. And maybe you don't need to know the summation. Maybe what you're looking for is the minimum. So here's our minimal. You're looking for, and this comes up a lot because you have like your errors. We want to find the minimal error inside of this array. And just like the other one, we can do axes equals 0. And you can see here 0.0645 is the smallest number in this first column is 0.0645, and so on. And if you have a minimum, well, you might also want to know the max. Maybe we're looking for the maximum profit. And here we go. You can see maximum 0.79 is the maximum on this first column. And just like we did before, you can change this to a 1 on axes. You can take the axes out of here and just find the max value for the whole array. And the max value in here was 0.8344, so on and so on. And since we're talking data analytics, we want to go ahead and look at the mean. Pretty much the same as the average. This is the mean across the whole thing. And just like we did before, we could also do axes equals 0. And then you'll see this is the mean of this axis, and so on. And we have mean. We might want to know the median. And there's our median, our most common numbers. If we have median, we might want to know the standard deviation. Or if we have the average, a lot of times you do the means and the standard deviation. We can run that, and there's our standard deviations along the axes. We can also do it across the whole array. If we're going to do standard deviations, there's also variance, which is your VAR. And there's our variance across the different levels. And so if we looked at that, we looked at variance, we looked at standard deviation, the median, and the means. There's more, but those are the most common ones used with data analytics. And then going through your data and figuring out what you're going to present to the shareholders. And some other things we can do is we can actually take slices. You'll hear that terminology. And a slice might be, like we have a 5 by 5 array, but maybe we don't want the whole array. Maybe we want from 1 on, we don't want the 0 in there. So we got up to 4. And maybe on the second part, we just want 2 to row 3. And so this notation right here says 1 to the end. And if we run this, you can see how that generates a single row to the end, and then row 2 and 3. Now remember, it doesn't include 3. That's why we only get the 1 column. So if you wanted 2 and 3, you would need to go ahead and go 2 to 4. So it goes up to 4. We could also do this in reverse. Just like we learned earlier, we can go -1. Whoops. And when we go to -1, it's the same thing because we have 0, 1, 2, 3, 4. This is the same thing as 2 to 4. It goes 2 to the last one. Also very common with arrays is you're going to want to sort them. So we still have our array up here that we randomly generated, and we might want to sort it, and we'll go and throw an axis back in there. Axis equals 1. If we run this, you can see from the axes that it sorts it the 0.2 being the lowest value to the highest value by the row. We can also change this, of course, to axis 0. If you're sorting it by columns, so maybe your values are based on columns. And then, of course, you can do the whole array, and we can sort that. Don't usually do that, but I guess sometimes that might come up. And so you can see right here we have a nice sorted array. Something else, let's just go ahead and reprint our array so we can look at it again. Starting to get too many boxes up there. Something else you can do with an array is we can take and transpose it. This comes up more than you would think. When you transpose it, you'll see that the rows in the column are transposed. So where 0.79, 0.57, 0.064 is a column, now we've switched it and we have 0.79, 0.42 as the index. You can see this really more dramatic if we take a slice, and we'll just do a slice of the first couple, and then we'll just do all the other, the full rows, and if we run this, you can see how it comes up a little bit different. And we'll just do the same slice up here so you can see how those two look next to each other. There we go. There's our slice. Run. And so you can see the slice comes up and it has 1, 2, 3, 4, 5 columns. Now we have 1, 2, 3, 4, 5 rows and 3 columns versus 3 rows. And the original version, when they first started putting this together, was a function. So the original version was transpose, and this still works. You can still see it generates the same value as just a capital T. So many times we flip this data because we'll have an XY value or we'll have an image or something like that, and it's being read one way into the next process, and the next one needs it the opposite. So this actually happens a lot. You need to know how to transpose the data really quick. And we can go ahead, let's just take, here's our transpose. We'll just stick with the transpose on here. And instead of doing it this way, we might need to do something called flattening. Why would you flatten your data? If this is an array going into a neural network, you might want to send it in as one set of values instead of 2 rows. And you can see here is all the values as a single array. It just flattens it down into one array. So we covered our scientific means, transpose, median, some different variations on here. Some of the other things we want to do is what happens if we want to append to our array. So let's create a new array. I'm getting tired of looking at the same set of random numbers we generated earlier. So we'll go ahead and create a new array here, something a little simpler so it's easier to see what we're doing. And 4, 5, 6, 7, 8. That's good enough. We'll just do 4, 5, 6, 7, 8. And if we print this array, there it is, 4, 5, 6, 7, 8. And we might want to append something to the array. So we have our array, we need to extend it. You got to be very careful about appending things to your array, and there's a number of reasons for that. One is runtime. Because of the way the NumPy array is set up, a lot of times you build your data and then push it into the NumPy array instead of continually adding on to the array. And then it also it automatically generates a copy for protecting your data. So there's a lot of reasons to be careful about appending this way. But you can certainly do it. And we can just take our array, we're going to create a new array, array 1. And if we print array 1 and we append 8 to it, you'll see 4, 5, 6, 7, and then there's our 8 appended onto the end. And if you want to append something to an array, you'd probably also want to, whoops, array 1. Let's try that again. There we go. Now we have the 8 appended onto the end. So you can see 4, 5, 6, 7, 8, and then we appended another 8 on there. And if you're going to append something, you might want to go ahead and insert. Instead of appending, it might be you need to keep a certain order. And we can do the same thing. We can do our array, and we're going to append or insert at the beginning. And let's go ahead and insert 1, 2, 3. 1, 2, 3. And we go ahead and print our array 2. We run it, and you can see 1, 2, 3 is inserted at the beginning. Insert's a lot more powerful in that you can put it anywhere in the array. We can move it to the 1 spot, and there we go, 1, 2, 3. We can do a -1 just for fun, and you'll see it comes up 1, 2, 3, and we're counting backwards by 1. I imagine you can do a -0 and run this, and it turns out that -0 puts it back at the beginning, because that's why it registers as 0, it just takes a minus sign off. And just like we add numbers on, we might want to delete numbers. And so let's do an np.delete. Well, let's keep it a little bit, make it a little easy here to watch. We'll go ahead and create an array 3, and we'll do np delete. We were just working with array 2, and what we want to do is delete 0 space. So if you look at this, here's our array 2. Array 2 starts with 1, and when we delete the space on here and print that out, we deleted the 1 right out of there. And we can also do something like this, where we can do it as a slice, and we can do, let's do 1, 3. And if we run 1, 3, you'll see we've deleted the 1 space and the 3 space out, which deleted our 2 and 4. Now, keep in mind, when you're messing with adding lines and deleting lines, you have to be really careful, because there's a time element involved as far as where the data is coming from, and it's really easy to delete the wrong data and corrupt what you're working on, or to insert stuff where you don't want it. So there's always a warning when we talk about manipulating NumPy arrays. And just like anything else we're doing, we'll create an array C, which equals, we'll just do our NumPy array that we just created, our NumPy array 3, and we can do copy. So you can make a copy of it. Maybe you want to protect your original data, or maybe you're making a mask, and so you copy the array, and then the new array make all these alterations and change it from values to 0 to 1 to mask over the first one. And of course, if we do array C, since it equals a copy of array 3, it's the same thing, 1, 3, 5, 6, 7, 8. And now we're getting into combine and split arrays. I end up doing a lot of this, and I don't know how many times I end up fiddling with this and having a mess. But you do it a lot. You know, you combine your arrays, you split them. You might need one set of data for one thing, another set of data for the other. So let's go ahead and create 2 arrays, array 1, array 2. And I want you to note, and the terminology we're going to look for is concatenate. And what that means is we're going to take, we'll call this array cat. I like array cat. There we go. Our array cat, our concatenated array, we're taking array 1 and 2, and it's very important to really pay attention to your axes and your counts. I can't merge 2 arrays that have, like, if their axes are messed up and I'm merging on axis 0, it's going to give me an error and I'll have to reshape them. So you got to make sure that whatever you're concatenating together works. And what that means, as you can see here, we have 1, 2, 3, 4, 1, 2, 3, 4, and then 5, 6, 7, 8, 5, 6, 7, 8 along the 0 axis. These each are 4 values. So it's a 2 by 4 value. And if we go ahead and switch this to 1, you can see how that flips it a little bit. So now we have 1, 2, 3, 4, 5, 6, 7, 8. It's interesting that we chose that one. If I did something like this, where this is now, there we go, and we concatenate it, run this, and it gives me an answer okay, because I have 2 by 2, and I'm using axis 1. But if I switch this to axis 0, where now it's got 3 and 5, it gives me an error. So you got to be really careful on that to make sure that whatever axes you are putting together, that they match. So like I said, this one, oops, axis 1. Axis 1 has 2 entities, and since we're going on axis 1, or by row, you can see that it lets it merge it right onto the end there. And you could imagine this if this was a XY plot of value, or the X value going in and the predicted Y value coming out, and then you have another prediction and you want to combine them. This works really easy for that. And we'll go back and let's just put this back to where we had it. Oops, I forgot how many changes I made. There we go. We'll just put it, whoops, I messed up on my concatenation order here. There we go. Okay, so you can see that we went through the different concatenation. Axes is really important when you're doing your concatenation values on here. And we'll switch this back to 1 just because I like the looks of that better. There we go. 2 rows. Now, there are other commands in here. So we can do cat v equals np v stack. This is nothing more than your concatenation, but instead we don't have to put the axes in there because v stands for vertical. And so if we print out cat v and we run this, you can see we get the 1, 2, 3, 4, 1, 2, 3, 4, and that would be the same as making this axis 0 for vertical stack. And if you're going to have a vertical stack, you can also have an H stack. So if we change this from V stack to, oops, here we go, H stack, and we'll just change this from cat to cat, and I run this, it's the same as doing axis 0. The process is identical in the background. This is like a legacy setup, your V stack and your H stack. Most people just use concatenate and then put the axes in there because it's much has a lot more clarity and is more commonly used nowadays. The last section in NumPy we're going to cover is kind of data exploration, and that'll make a little bit more sense in just a moment. Sometimes they call them set operations. But let's say we have an array, 1, 2, 3, 4, 5, 6, 3, whatever it is. You can see we generate a nice little array here. And what I want to go ahead and do is find the unique values in that array. So maybe I'm generating what they call a one-hot encoder. And so these values then all become, I need to know how long my bit array is going to be. So each word, each word is represented by a number, and then I want to know just how many of those words are in there. If we're doing word count, very popular thing to do. And you can see here when we do unique, we have 1, 2, 3, 4, 5, 6. Those are our unique values. Some of the things we can do with the unique values is we can also, instead of doing just unique, we can do uniques, our unique values, and counts of each unique value. And this is very similar to what we just did up here, where we're doing np unique, but we're going to add a little bit more into there. And it's just part of the arguments in this. And we want to do return counts equals true. So instead of just returning the unique values, we want to know how many of those unique values are in each one. And we'll go ahead and print our uniques and print our counts. When we run that, you can see here we have our unique value 1, 2, 3, 4, 5, 6, just like we had before. And then there's two of the first of 2 1s, 2 2s, 2 3s, 2 4s, 1 5, 2 6s, and so on. And you can go through and actually look at that if you want to count them. But a quick way to find out your distribution of different values. So you might want to know how often the word the is used versus the word and, if each word is represented as a unique number. And along the set variables, we might want to know, let me just put a note up here. We're going to start looking at intersection, and we might want to also know differentiation, and neither. So when we're, whoops, neighbor, neither. So when we're looking at now is we want to know, hey, where do these two arrays intersect? And we have 1, 2, 3, 4, 5, 3, 4, 5, 6, 7. We might want to know what is common between the two arrays. And so when we do that, we have np intersect, and it's a 1D array, one-dimensional array. And then we need to go ahead and put array 1, array 2. And if we run this, we can see they intersect at 3, 4, 5. That's what they have common. And because we're going to go ahead and go through these and look at a couple different options, let's change this from intersect 1D. And we'll do the same thing. We'll go ahead and print this. So we might want to know the intersection where they have commonalities. Another unique word is union of 1D. So instead of intersect, we want to know all the values that are in both of them. So here's our union of 1D. When we run that, you can see we have 1, 2, 3, 4, 5, 6, 7. So it's all the different values in there. And the last, one of the last words, we have 2 more to go, is we want to know what the set difference is. And so that's where you'll see that, if you remember set, we talked about that being what they call these things. So the set difference of a 1D array, when we run that, you can see that 1 is only in one array and 2 is only in one array. And if we want to know what's in array 1 but not in array 2, we might want to know what is in array 1 but not 2 and what's in 2 but not 1. And this would be the set XOR 1D on here. So we have the 4 different options here where we can do an intersection. What do they both have in common? We can do a union. What are all the unique values in both arrays? We can see the difference, what's in array 1 but not array 2, so set diff 1D. And then set XOR, what is not in 1 but is in 2, and what is not in 2 but in 1. So we dug a lot in NumPy because we were talking, there's a lot of different little mathematical things going on in NumPy. A lot of this can also be done in pandas, although usually the heavy lifting is left for NumPy because that's what it's designed for. Let's go ahead and open up another Python 3 setup in here. And so we want to explore what happens when you want to display this. This is where it starts getting, in my opinion, a little fun because you're actually playing with it and you have something to show people. And we'll go ahead and rename this. We're going to call this pandas and pyplot. So pandas pyplot, just so I can remember for next time. And we want to go ahead and import the necessary libraries. We're going to import pandas as PD. Now remember, this is a data frame, so we're talking rows and columns, and you'll see how pandas work so nicely when you're actually showing data to people. And then we're going to have NumPy in the background. NumPy works with pandas, so a lot of times you just import them by default. Seaborn sits on top of the matplot library. So sometimes we use the Seaborn because it kind of extends. It's one of the 100 packages that extends the matplot library. Probably the most common used because it has a lot of built-in functionality. Almost by default, I usually just put Seaborn in there in case I need it. And of course we have matplot library as pyplot, as PLT. And note we have as PD, as NP, as SNS, as PLT. Those are pretty standard. So when you're doing your imports, I would probably keep those just so other people can read your code and it makes sense to them. That's pretty much a standard nowadays. And then we have the strange line here. It says ampersand matplot library inline. That is for Jupyter Notebook only. So if you're running this in a different package, it'll have a pop-up when it goes to display the matplot library. You can, with the most current version of Jupyter, usually leave that out and it will still display it right on the page as we go. And we'll see what that looks like. And then we're going to go ahead and just do the Seaborn, the sns.set, and we're going to set the color codes equals true. Let them just keep the default ones so we don't have to think about it too much. And we of course have to run this. The reason we run this is because these values are all set. If we don't run this and I access one of these afterward, it'll crash. The cool thing about Jupyter Notebooks is if you forgot to import one of these, you forgot to install it, because you do have to install this under your Anaconda setup or whatever setup you're in, you can flip over to Anaconda and run your install for these. And then just come back and run it. You don't have to close anything out. And we'll go ahead and paste this one in here real quick where we have car equals pd.read_csv. And then we have the actual path. This path, of course, will vary depending on what you are working with. So it's wherever you save the file at. And you can see here I have like my OneDrive documents, Simplilearn, Python, data analytic, using Python, / car CSV. It's quite a long file. When we open that up, what we get is we get a CSV file, and we have the make, the model, the year, the engine, fuel type, engine horsepower, cylinders, and so on. And this is just a comma separated file. So each row is like a row of data. Think of it as a spreadsheet. and then each one is a column of data on here. And as you can see right here, it has the make model, so it has columns for a header on here. Now, your Pandas just does an excellent job of automatically pulling a lot of this in. So when you start seeing the Pandas on here, you realize that you are already like halfway done with getting your data in. I just love Pandas for that reason. NumPy also has it. You can load a CSV directly into NumPy, but we're working with Pandas, and this is where it really gets cool, is I can come down here and I can print, you remember our print statement, we can actually get rid of it, and we're just going to do car head because it's going to print that out. The head is going to print the top values of that data file we just ran in. And so you can see right here, it does a nice printout. It's all nice and in line because we're in Jupyter Notebook. I can scroll back and forth and look at the different data. And just like we expected, we have our column, and it brought the header right in. One thing to note is the index. It automatically created an index 0, 1, 2, 3, 4, and so on. And we're just looking at the head. So we got 0, 1, 2, 3, 4. You can change this. You might want to just look at the top two. We can run that. There's our top two BMWs. Another thing we can do is instead of head, we can do tail. And look at the last three values that are in that data file. And you can see right here, it numbered them all the way up to 11,913. Oh my goodness, they put a lot of data in this file. I didn't even look to see how big the file was. So you can really easily get through and view the different data in here. When you're talking about big data, you almost never just print out car. In fact, let's see what happens when we do. If we run this and we just run the car, it's huge. In fact, it's so big that the Pandas automatically truncates it and just does head plus tail, so you can see the two. So we really don't want to look at the whole thing. We'll go and go back to, let's stick with the head, displaying our data. There we go. So there's the head of our data. It gives us a quick look to see what's actually in there. I can zoom out if we want so you can actually get a better view. Although we'll keep it zoomed in so you can see the code I'm working on. And then from the data standpoint, we of course want to look at data types. What's going on with our data? What does it look like? Now this, you show when you're talking to your shareholders, they like to see these nice, easy to read charts. They look like a spreadsheet. So it's a nice way of displaying pieces of the chart. When we talk about the data types, now we're getting into the data science side of it. What are we working with? Well, we have make model, we have an integer 64 for the year. Engine fuel type is an object. If we go up here, you can see that most of them are it's a set manual, rear wheel drive. So they might be very limited number of types in there. And so forth. And it's either going to be a float 64, an integer, or an object is the way it's going to read it on here. And the next thing you're going to know is like your columns. And since it loaded the columns automatically, we have here the make, the model, the year, the engine, the size, all the way up to the MSRP. And just out of something you'll see come up a lot is whenever you're in Pandas and you type in .values, it converts it from a Pandas list to a NumPy array. And that's true of any of these. So then you end up in a NumPy array. So you'll see a little switch in there in the way that the data is actually stored. And that's true of any of these. In this case, we want car.columns. You have a total list of your car columns. And like any good data scientist, we want to start looking at analytical summary of the data set. What's going on with our data? So we can start trying to piecemeal it together. So we can do car, describe, and then what we'll do include equals all. So a nice Panda command is to describe your data. If you're working with R, this should start looking familiar. And we come down here and you can see count. There's the make, the model, the year, how many of each one, how many unique values of each one, the top value of each one, what's most common, the frequency, the mean. Clearly on some of these it's an object, so it really can't tell you what the average is. You know, it'd just be the top one's the average, I guess. The year, what's the average year on there? All this stuff comes down here. Your standard deviation, your minimum value, your maximum value, what's in the lower quarter, 50% mark, where's that line at, and what's in the upper 75%, the top 25% going into the max. Now, this next part is just cool. This is what we always wanted computers to be back like in the 90s, instead of 5,000 lines of code to do this. Maybe not 5,000. All right, I built my own plot library back in 95, and the amount of code for doing a simple plot was, I don't know, probably about 100 lines of code. This is being done in one line of code. We have our car, which is our pandas. We generated that. It's our data frame. And we have .hist for histogram. That is the power of Seaborn. Now, it's still going to generate a NumPy graph, but Seaborn sits on top, and then we can do the figure size. This is just so it fits nicely on the paper on here. And we do something simple like this, and you can see here where it comes up, and it does say matplot library and does subplots and everything. But we're looking at a histogram of all the different pieces in our database. And we have our engine cylinders. That's always a good one, because you can see like they have some that had a null on there, so they came out as 0. Maybe one of them had a 2-cylinder engine way back when. 4 is a common, 6 a little less common, and then you see the 8-cylinder, 12-cylinder engines. Boy, that's got to be a speedster or something. But you can see right here, it just breaks it down. So now you have how many cars with how many, whatever it is, cylinders, horsepower, and so on. And it does a nice job displaying it. You can see if you're working with your, you're going into your demo, it's really nice just to be able to type that in and boom, there it is. It can see it all the way across. And we might want to zero in and use like a box plot. And this time we'll go ahead and call the Seaborn, SNS, box plot. And we're going to go ahead and do vehicle size versus engine horsepower XY plot. And the data comes from the car. So if we run this, we end up with a nice box plot. You see our mid-size, compact, and large. You can see the variation. There's our outlier showing up there on the compact. That must be a high-end sports car. Large car might have a couple engines, and again we have all these outliers and then your deviation on them. Very powerful and quick way to zero in on one small piece of data and display it for people who need to have it reduced to something they can see and look at and understand. And that's our Seaborn box plot, or sns.boxplot. And then if we're going to back out and we want a quick look at what they call pair plotting, we can run that, and you can see with the Seaborn it just does all the work for you. It takes it just a moment for it to pull the data in and compile it. And once it does, it creates a nice grid. And this grid, if you look at this one space here, which is, you might not be able to see the small number, it says engine horsepower. This is engine horsepower to the year it was built, and it's just flipped. So everything to the right of the middle diagonal is just the rotation of what's on the left. And as you expect, the engine horsepower gets bigger and bigger and bigger as time goes on. So the year it was built, the further up in the year, the more likely you are to have a heavy horsepower engine. And you can quickly look at trends with our pair plot coming up. And look how fast that was. It took it a moment to process. But right away I get a nice view of all these different information, which I can look at visually and kind of see how things group and look. Now, if I was doing a meeting, I probably wouldn't show all the data. One of the things I've learned over the years is people, myself included, love to show all our work. You know, we were taught in school, show all your work, prove what you know. The CEO doesn't want to see a huge grid of graphs, I guarantee it. So what we want to do is we want to go ahead and drop the stuff that might not be interested in. And I'm not really a car person. Our guy in the back is, obviously. So you have your engine fuel type. We're going to drop that. We're going to drop market category, vehicle style, popularity, number of doors, vehicle size. And we have the axes in here. If you remember from NumPy, We have to include that axis to make it clear what we're working on. That's also true with pandas. And then we'll look at just what it looks like from the head. And you can see that we dropped out those categories, and now we have the make, model, year, and so forth. And we took out the engine, fuel type, market category, etc. And this should look familiar to you now. When you start working with pandas, I just love pandas for this reason. Look how easy it is. It just displays it as a nice spreadsheet for you. You can just look at it and view it very easily. It's also the same kind of view you're going to get if you're working in Spark or PySpark, which is Python for Spark across big data. This is the kind of thing that they come up with, and this is why pandas is so powerful. And we may look at this and decide we don't like these columns. And so you can go in here and we can actually rename the columns. Simple command, car equals car, rename. Columns equals engine horsepower equals horsepower. This is just your standard Python dictionary. So it just maps them out. And instead of having like the lengthy, if here we had engine horsepower, we just want horsepower. We don't need to know it's the engine horsepower. Engine cylinders, we don't need to know that it's for the engine, because there's only one thing we're describing if we're talking about cars, and that's cylinders. And we'll go ahead and just run this. And again, here's our car head, and you can see how that changed. We have model year and horsepower versus model year, engine horsepower, engine cylinders, and just cylinders. Again, we want to keep reducing this so it's more and more readable. The more readable you get it, the better. And of course, we can also adjust the size a little bit, so that when it prints out, instead of splitting it on 2 lines, we get like a single line. We can do that also. That's just your control mouse up or plus sign you use in Chrome. That's a Chrome command. And if you remember from NumPy, we had shape. Well, pandas works the same way. We can look at the shape of the data. So we now have 11,914 rows and 10 columns. So you see some similarities because pandas is built on NumPy. And questions that come up just like you did in NumPy, we might want to know duplicate rows. And so we can do car. And look at this switch here. We're doing a selection. This is a pandas selection with the brackets. But we want to select it based on car.duplicated. So how many duplicates on there? So it's starting to look a little bit different as far as how we access some of the data on here. This can be a logical statement. And we get the number of duplicate rows. We have 989 rows by 10 columns again. And this is one of those troubleshooting things that we end up doing a lot, more than we really feel like we should. We might go ahead and do like a car count just to see how many rows we're dealing with. And then right after that, we might want to go ahead and say, hey, let's drop duplicates. So remember we did all the duplicates on there. So car equals car.drop duplicates. And then we can print the head again. We'll just do car head here. And you can see the data on there looks the same as before. And just note that we did car equals car.drop duplicates. There are commands in here where you can do, where it changes the actual value. And it works on some of them and not on others depending on what you're doing. But by default, it always returns a copy. So when we do this, we're reassigning it to car. And you can see it's the same header, but we want to go ahead and do count and see how the count changes. Let's go ahead and run this. And you can see here, instead of 11,914, we have 10,925. So we removed about 100 cars that were duplicated, just slightly under 100 there. And then as we're prepping our data, we might want to know car is null. So it's going to count the values of null, and then we want to sum that up. And when we do that, we do the car is null function.sum. We end up with HP, the horsepower is 69 have null values, and 30 have cylinders have null values. Now, if you don't put the sum at the end, it's just going to return a mask with the true false of is it null or is it not, by 0 and 1. So you're summing up the ones underneath each column. And this, of course, then you have to decide what you're going to do with the null values. There's a lot of different options. It might be that you need to put in the average or means. Maybe you want to put in the median value. There's a lot of different ways to fill it. Usually when you first start out with the data, a lot of them you just drop your null values. And you can see here car.drop_NA, which is equal to all, and then we're going to go ahead and count it, and you can see that we've dropped almost another 100 values. So from 10,925 to 10,827. Maybe 75 or so values. So we've cleaned it. This is really a big part of cleaning data. You need to know how to get rid of your null values, or at least count them, and what to do with them. And of course, if we go back to counting our null values, we should now have null values. There we go. And you'll see there's 0 null values. I don't know how many times I've been running a model that doesn't take null values and it crashes, and I just sit there and look at it trying to get, why did that crash? It should have worked. It's because I forgot to remove the null values. So we've been jumping around a lot. We're going to go back to finding outliers. And let's go ahead and bring that back into our Seaborn. And if you remember, we did a box plot earlier. This time we're going to do a box plot just on the price. And you can see here our price value, and we have the deviation with the 2 thinner bars on each side of the main value. And then as we get up here, we have all these outliers. In fact, we have one way out here that's probably a really expensive high-end car is what we're looking at. If you were doing fraud analysis, you would be jumping on all over these outliers. Why are these deviation from the standard? What are these people doing? Again, this is probably, like I said, a really high-end expensive car out here. That's what we're looking at. And we can also look at the box plot for the horsepower. And we'll put that in down here and run that. And you can see again, here's our horsepower, and it just jumps, and there's these really odd, huge muscle cars out here that are outliers. And we're going to jump into making this a little bit more, as you start displaying your data or your information to your shareholders. We're going to look at plotting a histogram for the number of cars per brand. And the first thing we want to go ahead and do is we have with our car, go back over here, here we go. We have our make value counts, largest plot, and we want to do a kind equals bar, figure size 10.5. And right off the bat, we jump up here and we see Chevrolet. It's going against, what was it? It's figure ratio, the value counts, and we want the largest value. So here's our value counts and compared to what the different cars are. Chevrolet puts out a lot of different kinds of cars. I didn't realize that they made that many cars or different types. And then for readability, let's go ahead and add a title, number of cars by make, number of cars, and make. If you had looked at this the first time, you would have been like, well, what the heck am I looking at? Well, we're looking at the number of cars by make. And then you can see here, now we're talking about the type of cars and the different ones are put out. Lotus, I guess, only had a few different kinds of cars over there. Very high-end cars. And then as doing data analytics and as a data scientist, one of the things I am most interested in is the relationship between the variables. So this is always a place to start. We want to know what's going on with our variables and how they connect with each other. So the first thing we're going to do is we're going to go ahead and set a figure size because we want to make sure it fits our graph. We'll just go ahead and set this one plot figure set to figure size 2010. If you never used the matplot library, which is sitting behind Seaborn, whatever is in the PLT, this is what's loaded. It's like a canvas you're painting on. So the second you load that PyPlot as PLT, anything you do to that is affecting everything on it. And then we want to go ahead, since we're using Seaborn, we'll go ahead and create a variable C for relationships or correspondence, and car.corr. That's a correlation in Seaborn on top of pandas. Again, one line and you get the whole correlation on there. And because we're working with Seaborn, let's put it into a nice heat map. If you're not familiar with heat maps, that means we're just using color as part of our setup. So we have a nice visual. And we can see here that the Seaborn connected to the pandas prints out a nice chart. We'll talk a little bit about the color here in a second. It prints out a nice chart. This is a chart I look at. As a data scientist, these are the numbers I want to look at. And we'll just highlight one of them. Here's cylinders versus horsepower. The closer to 1, the higher the correlation. So 0.788 pretty high correlation between the number of cylinders and how heavy the horsepower is. I'm betting if you looked at the year versus horsepower, we can just look at that one. Here's year and horsepower. 0.314, not as so much, but if you combine them, you don't actually add them. But if you combine them, you'll start to see an increase in horsepower per year and cylinders. You could probably get a correlation there. And just like 0.78 is a positive correlation, you might notice if we look at cylinders, or let's look at horsepower and mileage. So if we go here to horsepower to mileage, you get a nice negative. We'll do cylinders, that's a bigger number. With cylinders to the miles per gallon, it's a minus 0.6. So it's a negative correlation. The closer to -1, the more the negative correlation is. And then the chart you would actually show people is a nice heat map. This is all our colors, and it's just those numbers put into a heat map. The darker the color, the higher the correlation. You can see straight down the middle, obviously the year correlates directly with the year, horsepower with horsepower, and so on. That's why it's a 1. The closer to the 1, the higher the correlation between the two pieces of data. Now, this is a good introduction. Pandas goes way beyond this. Most of the functionality in NumPy, since Pandas sits on it, is also in Pandas, and then it even has additional features in it. And we use Seaborn pretty extensively sitting on top over our PyPlot. So keep in mind that our PyPlot has a ton of other features in it that we didn't even touch on in here. We couldn't, even if you had a sole course in it, there's just so many things hidden in there depending on what your domain you're working on. But you can see here, here's our Seaborn and here's our Matplot library. That's all our graphics that we did. And then the Seaborn works really nicely with the pandas. We really like that. So that wraps up our demo part for today.
Let's learn about data manipulation in R. And here we will learn about dplyr package. And when we talk about this dplyr package, it is much faster and much easier to read than base R. So dplyr package is used to transform and summarize tabular data with rows and columns. You might be working on a data frame, or you might be getting in a inbuilt R data set, which can then be converted into a data frame. So we can get this package dplyr by just calling in library function. And this can be used for grouping by data, summarizing the data, adding new variables, selecting different set of columns, filtering our data sets, sorting it, selecting it, arranging it, or even mutating. That is basically creating new columns using functions on existing variables. So let's see how we work with dplyr. Now here I can basically get the package here. So I can just say install.packages dplyr. Now we already see the package here, which is showing up. So I will just select this one. I can do a control enter, and that will basically set up the package dplyr successfully unpacked. So that is done. Now you can start using this package by just doing a library dplyr, and this was built. It shows me my version of R. So let's also use a inbuilt data set, that is New York flights 13. So we can do install.packages, and that will search and get that relevant data set. I can again call it by using library function. Now once that is done, we can look at some sample data here by just doing view flights, and that shows me the data in a neat and a tabular format, which shows me year, month, day, departure time, scheduled departure time, and so on. Now we can also do a head to look at some initial data, which can help us in understanding the data better. So what is this data about? How many columns we have? What are the data types or object types here? It shows me how many variables we have. So this is fine. Now we can start using dplyr, and in that we can use, say, filter function if we would want to look in for specific value. Now here we have the column as month, so I will do a filter. Now I'm creating a variable f1. I'm using the filter function on flights, which we already have. And then what we can do is we can basically look at the month, where the month value is 07. So let's look at that. And this one, you can do a view on F1, which shows me the data wherein you have filtered out all the data based on month being 7. So this is a simple usage of filter. We can take some other example. We may want to include multiple columns. So we can say F2 filter flights, and here we will say month is equal to 7, day is 3, and then look at the value of F2 if you are interested in seeing this. And that tells you the month is 7 and day is 3. You could also look into a more readable format by using view on F2, and that gives me my selected result. So we are just extracting in some specific value. We can keep extending this. So here we can say flights is what we would want to work on. I'm using the filter function, so I can straight away, instead of creating a variable and then doing a view, I can also do a view in this way. I can just pass in my filter within the view, and within this I'm saying filter. I would want to look at the flights, month being 09, day being 2, and origin being LGA, and then that shows me the value here. And obviously you can scroll and look at all the columns, and if you see the origin column, it shows the selected value. So now we have filtered our data based on values in 3 different columns. Now what we can also do is we can use AND, or we can use OR operators. So I could have done this in a little different way. So I could have said head, which shows me initial result. I will do a flights. So within my head function, I'm passing in this. And what does that contain? So you are saying flights, and in this flights data set, you would want to pick up the month being the column. So we use the dollar symbol here. We give in a value, and I'll say and I'll again say flights, wherein I will select the day being 2 and remember, when you talk about and, it is going to check if all the values are met true. So then you say flights origin LGA, and you look at the value. So in this way I can filter out specifically multiple values by specifying columns. Now we could have done it in this way. We could have created a view, or we could have assigned this to a variable and then done a view on that, where we could have selected month being day and origin. Or you can be more specific in specifying all the columns. It makes the code more readable. So let's look at the values, and here you are looking at head, which shows me based on month, day, and then you can look for further columns for other variables, that is origin being LGA. Now what we can also do is we can do some slicing here to select rows by particular position. So I can say slice, and I would want to look at rows 1 to 5, and I can do this. So you can always assign or look at the view of this. I can just do here. So when I did a slice 1:5, it shows me my entries for 1 to 5. Now similarly, we can do a slice 5 to 10, and now you're looking at 5 to 10 values. So you can always look at the complete data, and then you can slice out particular data. Now mutate is usually a function which is used when you would want to apply some variable on a particular data set, and then you would want to add it to your existing data frame, or you would want to add a new column. So this is where you use mutate, which is mainly used to add new variables. So let's see how you work on mutate. So it's pretty simple. So you create a variable over delay. Now I would want to do a mutate so that it adds a new column. So I'm selecting my data, which is flights. I will call the new column as overall delay, and then basically I can look at overall delay being arrival delay minus departure delay. So let's create this, and let's look at view of this, which shows me, or which should show me, my new column, which is overall delay, which was not in my original data set. So you can anytime do a head on this one to compare the value. So this one shows me arrival delay, and then there are many other variables. What you can also do is you can do a view, and you could have just look at flights if you would want to compare. So you can look at the flights, and this one would not have any overall delay column. So it basically shows me 19 columns only, what we see here. And if you do a view on overall delay, then that basically shows me 20 columns. So we know that the new column has been added to this overall delay. So if you would want to work with 20 columns, you will use overall delay. If you would want to work with your original data set, you will use flights. Now you can also use a transmute function, which is used to show only the new column. So we can do an overall delay, and at this time we will say transmute, we will say flights, overall delay. The computation remains same, but at this time, if I look at view on overall delay, it only shows me the new column. So sometimes we may want to compute result based on two variables or two columns and just look at the new value, and then we can decide if we would want to add it to our existing structure. Now you can also use summarize, and summarize basically helps us in getting a summary based on certain criteria. So we can always do a summarize, and what we can do is we can look at our data and we can say on what basis we would want to summarize this particular data. So we can do a summarize function. Now summarize on flights, I will say average air time, and I would want to calculate an average. So for that I'm using an inbuilt function called mean. I will do that on airtime column. So let's look at flights once again, and here we can see there is arrival time, not airtime, sorry, arrival time, and we would want to do some average on this particular data. We would want to summarize this. So what I'll do is I will use the summarize function. I will say average airtime, and this one I will look at mean of airtime. So let's see if there is a airtime column. Let's look at this one, arrival delay, and yes, we have an airtime. So we were actually looking at summarizing based on airtime, not the arrival time. So airtime is how much time it takes in air for this particular flight, and we will want to use the summarize function, not the transmute. So summarize flights, average airtime, and this one we will calculate the mean of average airtime, and I will also do a NA removal, which is I'm saying true. So let's do this, and that basically shows me the average airtime is 151. I can also do a total airtime where I'm doing a summation of values, or I can get the standard deviation, or I can basically get multiple values such as mean. I can say total airtime where I'm doing a summation, and then I can look at other values, which is if you would want to put in standard deviation here, you could do that. So let's look at the result of this summarize, and this basically allows me to get some useful information which is summarized based on a particular function such as mean, sum, standard deviation, or all three of them. Now let's look at grouping by. So sometimes we may be interested in summarizing the data by groups, and that's where we use the group by function. So we can always use the group by clause. Now here we are taking a different data set. So we will say, for example, let's look at head of empty cars, and that is basically my data set on empty cars. Now that shows me the model of the car, it shows me mileage, cylinder power, and your horsepower and various other characteristics or variables in this particular data set. So here we can say let's do a grouping by gear. So there is a column called gear, so I will call it by gear. I will look at my data set, and then what I'm using here, which you see with these percentage and greater symbol, is called piping. So that basically feeds your previous data frame into next one. So this is sometimes useful, and you can get this by just saying Control Shift and M, and you can then use this. So we are going to have piping. So I'm saying empty cars. Now this is my original data set where I did a head, or I could have done a view on this one if you would want to see it in a more readable format, and that basically shows me the data. So we are using a different data set, so I want to group it by the gear column. So I'm going to call it by gear, and this one takes my data that is empty cars. I'm using the piping, and then I'm saying group the data based on gear column. That's done. Now let's look at the value of by gear, or you can always do a view. So remember, whenever you're doing a group by, it is giving you a internal object where your data is grouped based on a particular column. So we can look at the values here. You can do a view that shows you your data grouped based on a particular column. Now I can again use the summarize function where I would want to now work on the new one where it was grouped based on gear. So I'm doing a summarize, and here I'm going to say gear 1, which will be having the value of summation on the gear column. And then I'm saying gear 2, which is mean. Well, you could give some meaningful names to this. And let's look at the value of this one, where we are basically now looking at the values, which is sum and mean values based on the gear. Similarly, we can look at different example. So we can say by gear, and I'm again using piping. But earlier we had taken gear, we had grouped the data, and we called it by gear. So we took our original data set empty cars, but now within this particular data, which was grouped by gear, I will take this data set, I will use the piping, and I will summarize it where I am saying within this particular data set, I would want to get the sum, or I would want to get the mean, and then you can look at the values. So what you're doing is you are either looking at your original data set, or you're looking at the data which was already grouped, and then you can look at the values. Now here what we can do is we can group by cylinder. Say might be you are interested in looking at data which is summarized based on the cylinder column. You can do that. And then for this by cylinder, I'm doing a piping where I'm using the summarize function, and summarizing will then be done based on the mean values of the gear column or the horsepower. So let's do this, and then you can basically look at the value. At any point you may want to look at the data set again, so just do a head, and you can look at what does the value contain, and by cylinder or by gear, and do a head, and it gives you the value. So you can always do some summarizing or grouping in these ways. Now here we are going to use sample underscore n function and sample underscore fraction for creating samples. So for this, let's take the flights data set again, and we would want to get 15 random values. Now that is done, and it shows me 15 rows with some random values from the data. What you can also do is you can do a portion of data by using sample underscore fraction, and here I'll say flights, I'll say 0.4, which will return 40% of the total data. So this can be useful when you are building your machine learning, where you would want to split your data into training and test. Might be you are interested in some portion of the data, so you can do this, which is very useful function, and then you can look at the value of that. Now what we can also do is we can use a range function. So like we were doing a grouping by, or we were trying to pull out a particular column. So in the same way, we can use a range, which is a convenient way of sorting than your base R sorting. So for a range function, let's do a view based on a range. So we will work on the flights data set which we have, and here what we would want to do is we would want to arrange the flights data set which is based on year and departure time, and we are doing a view out of it. So that basically gives me the data which is arranged based on your year and departure time. Now I can do a head to give me some highlighting of that data. Now the piping operator, what we are using, can be used in these ways also. So here I will say df. I will just assign the data set empty cars to it. Let's look at the df, which has basically your different models. You can obviously look at the head or view of it to look at useful information. We can also go for nesting options, which can be useful. So we are creating a variable called result here. Now that has the arrange function. So what does this arrange function do? So when we would want to use arrange to sort the data, so I would want to sort the data, but what data would I sort? So I will use sample n, which will give me some portion of the data or some sample data. Now what is that sample data? So here we are using nesting. That is, earlier when we did a sample, we just said data and how many random samples we want. But instead of giving that, what we are going to do is we are going to use filter here. Now this filter will work on df. So filtering will happen based on the mileage, which is greater than 20. I will say size is 5, and I would want to basically arrange this in a descending order. So I'm using the des on this particular mileage column. By default, it is always ascending. So let's get the result out of this, which will basically show me the mileage details in a descending order. So this is my data frame, and now we can look at the result, what we have created. So just do a view or do a head and look at the view. So here you see mileage, where the highest value is on the top, and we were only interested in 5 values in a random sample. So that's why when you did a view, it shows your 5 values and it shows in a descending order based on mileage. So we have not only used an inbuilt function, we have not only arranged the data, that is, we have sorted the data, but we have sorted the data based on a descending order on a particular column. We have said the value should be greater than 20, and we have also said we just need 5 random samples. Now let's look at some other examples. So you can always do a multi-assignment. So I can say filter, wherein I'm going to use df, which was assigned empty cars. I'm going to say mileage should be greater than 20. Then I say b, which is going to get a sample out of a, and I just want 5 random values. So let's look at that. So we have b, which is going to get a set of 5 values from a. Now I will create a result variable which will arrange b, which is sample data, in a descending order. Now let's look at the result of this, and that basically shows me what we were seeing earlier. So you can do a multi-assignment where you can create a variable, get a sample out of it, and then basically whatever is that result, you can arrange that or sort that in a descending or by default descending order. So same thing, we can do it using pipe operator. So piping, so here I will say result. I'm passing in my df, that's the data set. I'm using piping, and which basically tells what you need to do on this particular data set. So I'm going to filter out the data based on mileage 20. Then I'm going to push that or forward it to get the random sample, and whatever is this random sample is going to be pushed. So you are arranging this in a descending order. So this is one more way of doing it, and then basically you can look at the result. So these are some simple examples where you can use your dplyr with multiple assignments, or using your nesting to filter out the data. You can also do a arrange, which is to sort the data. You can get some random samples out of it. You can summarize the data. You can also summarize the data based on 1 or 2 or multiple columns, and you can use some inbuilt functions to summarize the data based on some functions which are applied on the variables or on the columns. You can transmute it, where you would be interested in only looking at one column. You can mutate it, where you want to add a new column. You can slice it, and you can give the conditions where you can say and or to filter out the data. So what we can also do is on this particular data set which we have, say for example DF, where I have my data. Let's look at this one, and if I just do a DF at this point, it shows me my data set. And if you would be interested only in particular column, then your dplyr also allows you to either we can do a filter or we can simply do a select. Now for selecting, we can choose our data. So for example, I'll say df underscore, I'm interested in mileage, I'm interested in horsepower, might be I'm interested in your cylinders in this. And for this one, what I can do is when I would want to do a select, I can basically say selected df, let's call it some name. I can say Control Shift M, which is for piping. And then basically what you can do is you can do a select and you can choose your columns. So I was interested in mileage, I was interested in horsepower, I was interested in cylinder. And here what I'm doing is I'm using a select where I can look at the new data frame. So let's do this. And I'm sorry, here we will have to give it df. This is where you are passing in your data. Yeah, now this one is done, and we can look at the value of this one by just doing a df or head on df underscore mileage horsepower cylinder and look at the selected result. So you can be looking at selective columns. I could have done this filter, but filter will always look for a condition. Say your mileage is greater than 20, or might be your cylinders are more than 4 or something else. But when you do a select, you are selecting specific columns. So view always gives you all the columns, head gives you highlight, but then select can be useful when we are interested in looking at only specific data. So this is how you can use dplyr for manipulation, for your data transformation, for basically filtering out the data by selecting particular data and then working on it. So similarly, there is one more package called tidyr, and we'll see how we can use data manipulation done using your tidyr package.
Let's learn about the tidyr package, which makes it easy to tidy your data. And this basically helps you creating a more cleaner data, so which is easy to visualize and model. Now this comes with mainly 4 functions. So you have gather, which makes your data wide, or it makes wide data longer. So that is basically used to stack up multiple columns. You have spread function, which makes long data wider, that is stacking the data together, or stack if you would want to unstack the data to data, and you are talking about data which has same attributes. And then your spread can spread the data across multiple columns. You have separate, which is function which splits single column into multiple columns. And to complement that, you have one more function which is unite, and that combines multiple columns into single columns. So these are 4 main functions which are used in your tidyr package. So let's look how we work with this. So let me bring up my R Studio here. Now for this, first is, let me just clean up my screen here, doing a Control L. So I will install the package. It is already installed, but we can just do a Control Enter, and then I can say, do you want to restart R prior to reinstall? So install, I'll say okay, and it is basically going to get the package. Now it says package tidyr, that is tidyr, has been successfully unpacked. Let's use that package using our library function, and that was built under R version 3.6. Now I can basically start using these functions. So for example, here we are creating a data frame. So let's say n is 10, and then we basically would say we will call it wide, Now that's the variable name. I'm using the data.frame function. I'm saying ID, which will be 1 to n. So that will take the values from 1 to 10. And then these are the values which have 10 entries. So this is a vector, phase 1, phase 2, phase 3. Let's create a data frame out of it. Now that's done. We can have a look at our data frame by just doing a view wide, and that shows me the ID column, and it has phase.1, phase.2, and phase.3. Now we can use our function. So for example, we can work with gather, that is reshaping the data from wide format to long format. And basically you can say stacking up multiple columns. So let's see how we do that. Here I'll call it long. I'm working on wide. I'm using the piping functionality, and then I'm using gather. So this one, I will say what will be the data which I will use. So we are using wide as a data frame. Then I'm saying response time. So that will be basically one more column. And then you have your columns which you would want to basically stack. So I'm saying from phase 1 to phase 3. So let's do this. And once this is done, let's have a look at our variable long. So this one shows me that I have an ID column, I have the response time column, and I have the phase column, which we mentioned. And that basically has all the values stacked in. So you have phase.1, phase.2, and phase.3. So all the columns are being stacked here. So all my data, so now I have totally 30 entries in this one. So this is basically using your gather function. Now sometimes we may want to use a separate function. Now separate function is basically splitting a single column into multiple columns, so which we would want to use when multiple variables are captured in a single variable column. Okay, so let's look at an example of this one. So let's say long separate, that's what we will call. We will work on this long, which has all the data stacked in as the columns we selected. Then I'm saying separate, I want the phase column, and then I would say when I separate the columns, what are my column names. Now I could also give a separator by giving a comma and then mentioning the separator if that is required. So let's do this. Now once this is done, let's have a look at our long separate. So what we see here is the column which we used. So we were doing a phase column, and that was to be split, and we wanted to split it into target and number. So that's what we see here. So you have phase being split into target and number, and then you have the response time. So this is how you use the separate function. Now there is also something called as unite function, which is basically a complementing of separate function. So it takes multiple columns and combines the elements to a single column. So for example, here we will call it long unite, and we will take long separate, which was separating the data. We want to unite, so we will take phase, target, number, and we want to have a separator between them. So let's basically do this. And now let's look at the result of this unite. So you see, you have the phase and target merged together. So you have phase.1, the separator is dot as we have mentioned, and we have united multiple columns. So this is one more function of your tidyr, which helps you basically tidy up your data or put it in a particular way. Now then you have your spread function, and this is basically for unstacking. So that is, if you would want to convert a stack to data, or if you would want to unstack the data which is of same attributes, spread can be used so that you can spread the data across multiple columns. So it will take two columns, say key and value, and spread it into multiple columns. So it makes long data wider. So we can look at this one. We will say long unite. I'm using the piping. I will use the spread function. I'll work on the phase column and response time. And let's do this. And then let's do a view on this. So it tells me our data is back in the shape as it was in the beginning. So these are 4 functions which are very helpful when we work with tidyr package.
So let's learn about visualization. And here we will learn about R which can be used for your visualization. Now, one thing which we need to understand is because of our ability to see patterns, which is highly developed, we can understand the data better if we can visualize it. So the efficient way or effective way to understand what is in our data or what we have understood in our data, we should or we can use graphical displays, that is your data visualization. So there are actually two types of data visualizations. So you have exploratory data visualization, which helps us to understand the data. And then you have explanatory visualization, which helps us to share our understanding with others. So when you talk about R provides various tools and packages to create data visualizations, and which can be used for both kind of data analysis or both kind of visualizations. So when you talk about exploratory data visualization, the key is to keep all the potentially relevant details together. Now, the objective when we talk about exploratory data analysis is to help you see what is in your data. And the main question is how much details can we interpret? Now, when you talk about different functions which we see here, such as plot, which is more for a generic plotting. You have bar plot, which is used to plot data using rectangular bars, or you can say creating bar charts. You have histogram or hist function to create histograms, where you look at the frequency of the data, or basically used to look at the central tendency of the data. You have box plot, which is used to represent data in the form of quartiles. You have ggplot, which is a package which enables the user to create sophisticated visualizations with the little code using the grammar of graphics. And then you have plotly or plotly. It creates interactive web-based graphs via the open source JavaScript graphing library. Now, before we see some examples here, let's also talk about, when you talk about plotting, let's also try to understand what kind of plots you can have and what kind of techniques you have. So let me open up my RStudio here. Now, for example, I can pull out a particular data set, and let's look at this one. So here I can look at all the panes, and that shows me the information. Now what I can do is I can install and get the inbuilt data sets, and then I can simply do a plot wherein I am doing a plot on chick-weight data set. So let's see what does that show. It summarizes the relationship between 4 variables in chick-weight data frame, which is in R's built-in dataset package. Now from these plots, we can see, for example, weight varies systematically over time. You can also see that chicks were assigned to 4 different diets. Now, when we talk about explanatory data analysis or visualization, that shows others what we found in the data. This means we need to make some editorial decisions, what features we would want to highlight for emphasis, what features are distracting or confusing and you want them to be eliminated, right? So there are different ways of doing it. Now, when you talk about your graphics or visualizations, you have, I would say, 3 different types, or you can say 4. So you have the base graphics, which is easiest to learn. Now here we are having an example of base graphics, where I can use the base graphics. I can get a data set using library. Then I can simply create using plot function to generate a simple scatter plot of calories with sugar from US serial data frame in the mass package, and then I can give it a title. So this is basically a simple example of base graphics. Now you also have what we call as grid graphics, which is powerful set of modules for building other tools. Now you also have lattice graphics, which is general purpose system based on grid graphics. And then you have your ggplot2, which implements grammar of graphics and is based on grid graphics. So you have different ways. Now here, since I already have used library and I have the data set, I can just do a X So I can assign the sugar related values to X and calories related value to Y. Then I can use one more, which is library function and calling in grid. Now I can basically use functions such as push viewport if I would want to create a plot using your grid graphics to create the similar kind of plot which we created using base graphics, but this will give you much more power than base graphics. It will have a steep learning curve, but it is usually useful. So I can do this where I'm saying push viewport. Then I can basically say I would want to have a data viewport. I would say different functions of your grid package. So I'm saying rectangle, you have x-axis, y-axis, given some points here. And then basically you can add details to the graph by giving the names to the columns, and you can basically create a simple grid graphics based plot here. Now there are different other options which we can use to create plots. Now before we go into understanding how you create plots, let me just give you a brief on what are the different kind of plots and how they can be used. So here we will look at these different plots. Now for example, we have a bar chart, which is a graph which shows comparisons across discrete categories. So you have x-axis which will show the categories being compared, and y-axis which represents a measured value, and height of the bars are proportional to measured values. Now to create different kind of charts, you can use ggplot, which is a package for creating graphs in R. It is basically a method of thinking about and decomposing complex graphs into logical subunits, and that is a part of tidyverse ecosystem. So it takes each component of graph axes, you can give scales, you can give colors, you can give the objects, and you can build graphs on particular data. You can modify each of those components in a way that's more flexible and user friendly. You can, if you are not providing details for the components, then ggplot will use sensible defaults, and this basically makes it a powerful and a flexible tool. Now here are different options when you use your ggplot, such as you can use geom, or what we call as geometry objects, to form the basis of different type of graphs. For bar charts, you have for line graphs, you have scatter plots, that is underscore point, you have underscore box plot for box plots, you have quartile for continuous x, violin for richer display of distribution, and jitter for small data. So here is some simple example where I would not go into too many details here, but you can just have a look at this one where we are using library function to get the ggplot2 package. Then basically we would want to look into the mileage data. We would want to look at the structure of it. And then we can basically get the tidyverse package. Finally, we can create a bar chart using geom underscore bar. And we can basically also mention what would be in x-axis. Now you can also give different colors to basically add more meaning to your data. You could also go for stacked bar charts. So here we are actually telling ggplot to map the data in the drive column to fill the aesthetic. So here I am giving aesthetic access class, and I'm saying what is the data we need to have, and then we are using geom underscore bar. So you can also have dodged bar in your ggplot, that is not bar charts which are stacked but next to each other, and you can create that by using your position as position underscore dodge. Okay, now you can obviously use your different packages which are inbuilt, and you can create your bar charts. And you have other kind of graphs such as line graph, which is basically a type of graph that displays information as a series of data points connected by straight line segments such as this one. And for this one we are using, if you see, geom underscore line. Now you can also create a scatter plot, which is a two-dimensional data visualization that uses points to graph the values of two different variables, one on an x-axis, one on y-axis, like what we saw in base graphics example. and they are mainly used if you would want to assess the relationship or lack of relationship between two variables. And you also have histogram, which I mentioned is mainly to look at the distribution of a data, to look at the central tendency of the data, basically looking at your large amount of data or for a single variable. You would be interested in saying where is more data found in terms of frequency, where is lesser data found in the graph, how close the data is towards its midpoint, or what we call as mean, median, mode. So you can use histogram where you can categorize the data in what we call as bins. So these are some basics on different kind of graphs. Now we can look at some examples and see how that works. So what we were seeing is some quick examples of base graphics or grid graphics. Now here, let's do an example of pie chart for different products and units sold. So you want to create a graph for this. First, let's create a vector and pass in the value here. Now I can also create labels which I would want to assign to these values. And then basically I can plot the chart by saying pie. So that's the kind of chart which I would want to create. And I would say the data would be X and labels. So let's do this, and that shows me a simple pie chart. Now I can also give main details here. So instead of just doing a pie X comma labels, I can say what is the main and then what kind of coloring it should follow. So this is the way you can create a simple plot. Now I can also find out what is the percentage, and then basically I would be interested in plotting the pie chart which takes X, which takes the labels, which will be the percentage which we are calculating here by doing a round function. And then you can basically give details to your graph. You can say what color it follows. You can basically look at the legend where it needs to be in your chart. What are the values? And then basically fill up the colors. So let's run this one. And that shows me the percentage which was calculated, and it gives me the details, and we can always have a look at our plot. Now if you would want to go for a 3D pie chart, then you can get the package which is Plotrix. Let's use that by calling in the library function. Let's pass in some data to X, and let's give some values or labels which will make more meaning to the data. And then let's plot the 3D graph. So I'm saying pie 3D here, where I'm using X and labels. Then I'm basically doing an explode, which will basically control how your graph looks like and basically give the values. So it also takes the title when you say main and pie chart of countries. Now let's create data for graph. So again, we are having a variable here. We are using the C function, creating a vector. And then let's create a histogram for this one, where I would say X lab, what would be your data around x-axis, what is the color, what is the border, and here I'm creating a simple histogram, which, as I discussed earlier, will always show your values on the x-axis, and y-axis is more of frequency. And then you can look at the set of values and what is their frequency. And we can basically use this histogram for exploratory data analysis, look at the data, try to understand what is the central tendency of your data values. Now we can also give some limits by using the xlim and ylim, and then I can also specify what is the limit. So we have given some values here, wherein we have said your x limit is 0 to 40 and y limit is 0 to 5. Now if you compare this with the previous one which we had created, this one based on the frequency had taken the limits, but we can assign limits explicitly by giving this and then create a histogram which makes more meaning. Now let's take another data set, that is air quality. Let's view this to see what does that data contain. So you have ozone, solar, wind, temperature, month, and the day. So this is the kind of information we have in the air quality. Now let's use the plot function to draw a scatter plot, where, as I mentioned, you would be interested in analyzing variables and see what is the relationship between them. So to plot a graph between ozone and wind values, so we will say plot, we will say the data which is air quality. From that I would be interested in the ozone column or ozone field and the wind field. I can create a plot based on this. Now I can also be saying what should be the color, what is the type of the data which you would want to create, and you can look at the information. So you can create a histogram, you can create a scatter plot to basically understand the data better and then infer some information from that data. So let's take the air quality data set itself without specifying any particular column, and you can create a plot which shows me all the different values which you have in the data, and it basically shows you the difference. This is more of an example like what we did for chick weight, where we did a base graphics. Now you can assign labels to the plot. So that is when you are creating a plot, you can say air quality, you will say ozone, and then that's your ozone concentration. You have your YLab, which is the number of instances. You have what is the title, ozone levels in New York City, what is the color. So these are the details what we have given with our plot function. And let's look at the data. So it just tells me that this is the ozone concentration, the number of instances what you have, and you are looking at the data. Now we could also create a histogram by picking up a particular column, that is such as solar, from your air quality, and that basically shows me the frequency of solar values, and we can then try to find out what is the mid, what is the mean, what is the standard deviation, and so on. You can also look at your histogram and try to understand if it is left skewed and right skewed. So we can do that. Now here, let's get the temperature out from this particular data set. Let's create a histogram on temperature, and that basically shows me the frequency of the temperature values and what values have the most frequency or most occurrence. Now you can create a histogram with labels. So let's do that with the limit, and then let's also use text to basically give in the values, which also takes the values, and for each set of frequency or each set of values it gives me the labels. Now you can have a histogram with non-uniform width, so you could do that by doing a hist function and then passing in your temperature. You can say what will be the main, what is the title, what will be your X lab. It will tell you a limit around x-axis, what is the color, what is the border, what are the breaks you would want to have for your bars, and you can simply create a histogram using this. So this basically takes the breaks which we have given, such as 55 to 60, 60 to 70, 70 to 75, and so on. So this is basically creating a histogram with non-uniform width, and it purely depends on the kind of values what you have. Now you can also create a box plot, which sometimes helps us in understanding the data quartiles, also understanding our outliers. So you can create multiple box plots based on the data from air quality. So we'll select all the data and then we'll do some slicing on the data. So let's create a box plot which tells me the values, and if you look at these points here, like single dots, these are basically your outliers. We can learn about that more in later sections. So you can use your ggplot2 library to analyze a particular data set. So for that, we will first use the install.packages and get ggplot2. So it says, do you want to restart R? And I can say yes. So let it get the package. I think the package was already there. And now let's look at using ggplot2. So for that, I have the library function, and let's do a attach where I'm getting a data set which is empty cars. Now then I will create a variable p1. I will use ggplot. I will pass in my data. I'll give the aesthetics, what is the columns which you would be interested in, and then you are using geom_boxplot to basically create a plot which gives me the box plot for the values here, and this is based on the cylinders which is there in your data. So we can always look at what does our data contain and what kind of values or features are available in the data. Now let's create a box plot. We will also use the coordinate function, and that basically gives me based on the data. So I've changed the coordinates. Now if you look at the previous one where we created a plot, we had mileage on the y-axis and cylinders on the x-axis. Now I did a coordinate flip, and that's like your transpose function. So you have created the box plot, but you have just flipped the coordinates. You can create a box plot and then say fill, which is the factor of cylinder. So that can be used to fill up the values in your box plot. Now what we can also do is we can create factors. So we have learned about factors earlier, which is usually used to work on categorical variables. So here let's create a factor which is empty cars gear. You have AM, you have cylinder, and if you look at the factors which we have created, we have passed our data, what is the field or the column we are interested in, what is the level of values there, and what are the labels for those values, right? So we have learned about factors. You can always look into the previous section and learn more about factors. Now let's create a scatter plot by using the ggplot function. Again, we will use the data as empty cars. I will go for mapping option, and then I will give my aesthetics. That is what would be X, what would be your Y, and you also would want to use what kind of function you are using. So let's go for geom point, and that basically helps me in creating a scatter plot. Now you can create a scatter plot by factors. So here we will say ggplot. So notice in all of these cases, depending on the kind of data you have, depending on the kind of plot you are interested in, you will use the ggplot and then basically a function with that or the inbuilt package. So here I'm saying data is empty cars. I'm going for mapping, which basically will take the values for your X and Y. What is the color? And the coloring will be done based on the factor values. Now, if you remember, factors will obviously have some levels, and those levels will basically help you in differentiating between your categorical variables. So I'm saying as.factor on cylinder, and then I'm using geom point to basically create this scatter plot. So let's do this, and I can look at the values of this one. So it says must be, there is an error which says must at least one color from the hue palette. So let's look at that one. So the error which we were facing when we gave color as the factor values was because when you look at these factors which were created with some labels, if we look at the values of these, it tells me there are NA values in that particular column. Similarly, your gear, or similarly, you can completely look at the complete data set. It tells me cylinder, you have AM, you have gear. Now these have some, we have created some labels, but these have NA values. So what we can do is we can create a scatter plot as we did earlier by giving the aesthetics, and that's a simple scatter plot wherein I'm also using geom point so that I can have these points by defaults or with defaults. You can also give a color specific, basically if you would want to have different kind of data in the same plot, or I can create scatter plots by different sizes by giving a size, or I can give a color and size, and that's again one way in which you can create your scatter plots. Now let's also see how you can visualize one more data set, which is MPG. So I can also do it in this way where I set ggplot2 and then pass in, look at the data set what we have here. You can just do a view on this to see what my data contains, if the fields have any NA values, if that's going to affect your plotting. So now what we can do is we can create a bar plot or a bar chart. So I'm saying ggplot, the data would be as we have given in previous lines, that is ggplot2 mpg. Then I will say what should be in my aesthetics and what kind of chart are you going to create? So I'm saying geom underscore bar. So that's my bar chart, and that has basically your class and count. Now you can create a stacked bar chart where your information is stacked in the same bars, and we are still using the same data. We are going for aesthetics, which is class, and then when you say geom bar, which creates your stacked bar, we will use fill, which is drive. And we can always go back and look at our data. For example, you can always look into this. So you have the drive column here, and you are also working on this complete data set. So let's go ahead and create a stacked bar chart. And that basically gives me the information where you have the drive information, which is stacked here. Now you can do a dodge by giving the position as dodge. So we are still going to go for a stack chart, but this time the bars will be next to each other, and that can also be done, which is very useful. You can use this by using geom point, where you are mapping and you are specifying what are your aesthetics. So we were creating a scatter plot. Now you can also use or give more details where you can say color can be based on the class, and we have different classes, and based on that my points have been colored. Now you can also use a plot ly or plotly library. So let's install this one. I will say yes, for example. Let it basically restart so that all my packages are updated. Then I can access that package using library function, and then create a variable to which you are assigning your plot underscore ly plot. So data is empty cars. What will be your x-axis? What will be your y-axis? And details on your marker, which we have given, wherein I will give a list, which is size, color, which is a combination, and then you have your line, what kind of color it will have, and what will be the width. So this is where I'm going to use plot ly, and let's look at this plot. So it basically gives me some information. Now we see some warnings which are getting generated, but you don't need to worry about that. So you can look at the packages, what you have, and what options you are using. So similarly, we can create one more plot using plot ly and look at the values of those. So that's a plot with a trend which explains me about my data. So this is a simple small tutorial on understanding or how you can have your graphics or visualization used to understand your data. Obviously, there are much more examples, much more ways in which you can pass into your plot functions or your ggplot and the inbuilt packages which are available in R for your visualization. Now that could be for exploratory data analysis or explanatory data analysis. So try these graphs and see if you can change these options and try or create new visualizations. Good morning and good evening, everyone. So welcome to this session where we will learn on time series analysis using R programming language. So this is basically a mini project where we will look at time series data and how we can analyze it, visualize it to basically find some important information or gather insights from the data. Now, when you talk about time series analysis, time series is basically any data set where your values are measured at different points in time. So when you talk about time series data, data is usually uniformly spaced at a specific frequency. For example, hourly weather measurements, you have daily counts of website visits, monthly sales total, and so on. So when you talk about time series, that can also be irregularly spaced and sporadic. For example, timestamp data in computer systems, event log, or history of 9/11 emergency calls. Now, when we work with time series data, for example, here I'm taking an energy data set, we can see how techniques such as time-based indexing, resampling, rolling windows can help us explore variations in electricity demand and renewable energy supply over time. Now here we will look at some aspects of this data set which I am considering. So this is open power systems data set, and here is the data set I have. We can look at the data set. Now this is in a simple format. It has time. It basically has values for consumption, and then you have data for wind and solar and wind plus solar. So in certain cases you have only the date and the consumption, but then if we scroll down we will also find data for wind, solar, wind plus solar, and so on. So this is a time series data set which we would want to work on. Sometimes you may also have the data collected which just does not have the time, but it may also have timestamp. That is, it would have, say, hour, minutes, and seconds, and that can also be worked upon. So let's consider this data set and let's work on this project where we will analyze this time series data set. Now here we can work on this time series data. We can basically create some data structures out of it, such as data frames. We can do some time-based indexing. We can visualize the data. We can look at the seasonality in the data, look at some frequencies, and also do some trend detection. Now, when you talk about this data set, it has electricity production and consumption, which is reported as daily totals in gigawatt hours. And here are the columns of the data, which I was just showing you. So you have data, you have consumption, you have wind, you have solar, and wind plus solar. So this is the data we have, and we will basically explore, say, electricity consumption and production in Germany, which has varied over time. So some of the questions which we can answer here is, when is electricity consumption typically highest and lowest? How do wind and solar power production vary with seasons of the year? What are the long-term trends in electricity consumption, solar power, and wind power? How do wind and solar power production compare with electricity consumption, and how has this ratio changed over time? We can also do wrangling or cleaning of this data or pre-processing of data and create a data frame, and then we can visualize this. Now let's see how do we do that. So I will open up my RStudio and let's look at the data set. So here is the data set. Now I'm picking it up from my machine. You can also pick it up from GitHub. So all the data sets or similar data sets can be found in my GitHub repository. And here I can look in the data sets. You will find a lot of different data sets here. There are some time series data sets such as power. I can search for power, or you have basically coal, or you have this OPSD Germany daily data set, and there are many other data sets which you can work on. Now, to get the documentation on this project, you can also look in my GitHub repository and you can search for repositories, and then basically you can look in data science and R, and here there is a project folder where I've given the documentation, sample data set, and also your time series analysis related document. This is also the code which you can directly import in your RStudio, and you can practice or work on this project. So let's see how does that work. So first thing is, we will create a data frame from this data set. Now here, if you see, I am using header as true so that it understands the heading of each column. I'm also giving row.names and I'm specifying date. So there is this date column in the data set as I showed you earlier. Let's look at it again. So you have date, consumption, wind, solar, wind plus solar. So you can suggest that date should become the index column, which can be useful. So you can do this. Now let's just create this. Let's look at what does this data frame contain. And here, if you see, it shows me some data which has been now as a part of this data frame structure. It starts with consumption, wind, solar, wind plus solar. And if you see, this one is becoming my index column. So I can always do a head and look at part of the data frame using head or tail. So look at the first records. So let's see this. Now that shows me the head data. I can also do a tail and look at the ending values. So if you closely see here, we have wind, solar, wind, dot solar, and that basically has NA values, so there are missing values. But let's look at the tail, and that tells me that there is some data available for wind and solar and wind solar. Now we can always look in a tabular format using view, and we can look at the data. So this shows me that there are values in these columns. We see NA values, but if I really scroll down, I can see some values which would be available for wind and solar and wind solar. So I can just use view. Now I can look at the dimensions of this particular object, and that tells me there are 4,384 rows and 4 columns. You can always look at the structure, that is check the data type of each column, which can be very useful. So if I see here, I don't see the date column because date column was considered as an index, which can be useful. But I also look at my other columns, so they are of the num types. So that's the data type for each attribute or each column here. Now we would be interested in looking at this date column. So let's look at the data type of this date column. Now if I try to do this, this will show me that this is null because date as a column does not exist because we created it as an index. So if I look at row names and then I search for my data, show me the index column or row dot names, it tells me these are the values, that's the date column, which we are seeing here. Now we can access a specific row by just doing a my data and give the index value or row name value. So let's look at that, and that shows me based on this index you're looking at the value. You can obviously search for a different date, something like this. You can also pass in a vector and you can give range of values, so that is 0, 1, 2006 to 4 of January, and we can look at this one. So it shows me these are the values. So here actually I'm not giving a range, but I'm just selecting multiple values from row dot names. Now we already know that in R you have a summary function, so you can always do a summary, and that gives you for each column, it gives you minimum, first quartile, median, mean, third quartile, and maximum values. So we are looking at consumption, we are looking at wind, solar, and wind dot solar. Now this is good, but then if I would want to really visualize the data, access the data, do some analysis, then it would be good to take all the columns, and then we can later decide to change the data type of, say, date column if we want to use it. So earlier I was using date as row dot names or the name of the rows or index, what you call in any other programming language. So here I will just use my data set and I'll say header as true. I'm calling it my data 2. Let's look at the data, and this one shows me 5 columns, wherein my first column is the date, consumption, wind, solar, and so on. Now looking at the structure, so let's look at the data type. So it tells me that if now I'm interested in looking at the date column from my data to data frame, it tells me it is a factor with 4384 levels, and these are the values. So it is not in a date time format, it's a factor. Now what we can do is we can convert this into a date format. How do we do that? So let's have a variable x, and I'm going to use as.date function, and I'm going to pass in my date column. So that's assigned to x. Now let's look at the head of x, and it shows me the values. We will also see what kind of class it is, and we will look at the structure of x. So class already says it is date type, and look at the structure, so it shows me the format. Now we have converted this column or column related value into x. Now how do I basically extract values out of it or make it a part of data frame? So first I will use, so all once it has been converted in date format, I will go for as.numeric, and here I will create a variable called year, and I will just do a format on x, which is basically of date type, and then I'm saying %y, so that will get me the year component out of this. Let's look at the values. That shows me year component. Now, similarly, we can get the month out of this and then basically look at the month values. We can get the day out of it and we can get the day component. Now, if I look at my data 2, which we had created earlier, this basically had date, consumption, wind, solar, wind, solar. So what I can do is I can add these extracted columns such as year, month, day to my data frame using a cbind, that is column bind, and I will assign it to my data 2 again. So let's do this. And now if you look at head, it shows me date. So that should be date format, consumption. Now this one might not be date format, but we'll see. You have consumption, wind, solar, and we have extracted the year, month, and day, which can help us for group by. We can do some aggregations, we can do a plotting, and we can do various things by these additional columns. Now let's look at first 3 rows here. So I'll say 1:3 for my data 2, and that shows me some data here. You can always do a head and look at the sample of data. So that basically shows me month, day, your columns, and then you have your date. Now, what we can do is we would want to visualize this data. We would want to basically understand the consumption. Now, as I said, if we want to visualize the data, say for example, I want this, which is consumption of data over years. And this one is in terms of gigawatts per hour, as we were mentioning here, gigawatt hours. So if I would want to create this visual to basically understand the pattern of the data, how do we do it? So we can create a line plot of full time series of Germany's electricity consumption using the plot method. Now, how do we do that? So here, one of the option is I can straight away use the plot method. I can then say what would be in my x-axis, what would be on my y-axis, what would be the type of graph I would want to plot, what is my name on x-axis, y-axis, and this is the simplest way. So I'm saying my data 2, I'm extracting the year column, and here I'm taking the consumption. So let's create a plot. And here, if you see, we are looking at a plot. We do see some tick times, and we see that the data has been divided with every 2 years. So from 2006 onwards to 2016. But then really this data does not give me a very useful way of looking at the data or understanding it. Might be what I can do is I can use the same way, but I can give, apart from x-axis and y-axis, I can say the limits, that is x limit is 2006 to 2018 and y limit is from 800 to 1700. So we can do this, and let's look at this again. This is a plot, but it really does not help me in visualizing and understanding the data. So what are the better options? I can go for multiple plots in a window. As of now, we are just sticking to one plot in window. So if you would want to have multiple plots, you can always change the value here and make it 2 or 3. That will say how many rows and how many columns. So as of now, we will just keep it as it is, par mf row. Now, if I would want to plot, I can straight away give the column name. So I'm interested in getting the consumption. Now I can just do a plot. I'll say my data 2, and I will choose the second column, which is consumption, which we saw here from our data. So consumption was the second column. So I can just do a plot in a straightaway way without mentioning your x-axis, y-axis, limits, and so on. And if you look at this, this one is giving me a pattern. Now here I am looking at x-axis, y-axis, which is not really named. We do not have a name to this graph, and we are looking at the data. It does show me some kind of pattern, but might be we can make it more meaningful. So I can do it this way, where I say my data second column, let's give axis as year, x-axis, y-axis is consumption. Now that has changed the x-axis and y-axis. Now I can also give some more details. I can say type should be line. I have the line width. I'm saying color is blue. And let's do this. So this looks more meaningful, might be shows a wavering pattern of consumption over years. I can also give a limit of X, that is 0 to 2018, and that basically shows me the range. Now we can change that and we can be more specific and saying X limit should be 2006 to 2018. And let's look at this. Now this one, once you have given a proper limit, it shows the line graph and it shows what was the consumption in 2006 and over a period till 2018. I can then use any of these options are fine, but it depends on what and whom you are presenting the data or what kind of analysis you're doing. So I can do a plot. I can choose column second, X lab, which is X-axis, Y-axis, type is line, width, giving a X limit, Y limit, and then I'm giving a title to this, which is consumption graph. And then basically you are looking at the line graph. Now, those are the options which you can do. Either you could be very specific, or you could just give your column which you want to plot, or obviously make it more meaningful by giving all the details. Now, what we can do is, if we would want to look at this data and understand it better, rather than just looking at a simple line, I can take the log values. So here I'm saying log of my data to second column. So I'm taking log values of consumption and I'm taking the difference of logs. So I can say difference, and then you can basically increase or decrease this by multiplying it by some number. So rest remains the same. I'm changing the color, and let's look at this plot. And you see, this basically is giving me a better pattern, which makes meaning. Here we see the log values. So this is, you are using a simple plot function. In R, you can also use ggplot. Now for that, we can install the ggplot package. It's already there in my machine, so I'll say no. I will access this by using the library ggplot2. And now I can use ggplot to plot. So the way you specify here, you can say my data 2, that's the data frame. I'm saying type as O, and when I'm saying line, I am basically going to use x-axis, which is year, y is consumption. And let's look at this plot. So again, we are back to the one which we were doing earlier. Really does not make any sense. It gives us some data, but then really does not give me enough information. I can, in my aesthetics, I can say X as year, Y as consumption. I can do a grouping, and then I can give line and plot. So again, we have some information, but really does not help me, right? Now let's look at other example. So I'm just doing the same thing here, and I'm looking at line type being dashed. I'm using the ggplots other methods such as geom_line and geom_point to give me more information. And if I look at the plot, it does give me data. It tells me what are the different values. It gives me some kind of pattern, but I would still prefer the way we were doing with plot. Now we can change the color and obviously add details to it. So what we see is when you use the plot method, which I did earlier, it was choosing pretty good tick locations, that is every 2 years, and labels the years for the x-axis, which was helpful, right? But with these data points which we were seeing here, or say for example this one, or say this one, or say this one, we are looking at some data, but then that really is quite crowded and it is hard to read. You can look at the values, but then it really does not give you enough information. So we can go for plot method, but then we will see how we can consider different data. Now, if I would want to plot the solar and wind time series, so let's see how do we do that. So wind column is what I'm interested in. So first thing is, it was always good to find out the minimum and the maximum values in every column. So I'm saying minimum, I'm saying let's put in here my data 2, and then let's look at the values. So we are looking at the columns. We know consumption is the second column, wind is the third column, and you have solar as the fourth, and this one is the fifth. So let's say let's find out the minimum of each of these columns which we would want to plot. So let's say minimum of data third column. And here I'm also saying remove the NA values because we do not want to consider the NA values. So let's look at the minimum. That shows me 5.7757. What is the maximum value? It is 826. So that also helps me in giving a limit. If I want to plot wind on y-axis, I can give a y limit from 5 to 850. Consumption wise, let's find out the minimum from second column and maximum. And similarly for solar, find the minimum and maximum, and wind plus solar, minimum and maximum. So this will be helpful when you would want to plot multiple graphs or give some limits. So that's fine. Now for multiple plots, as I said, instead of having one plot, let's plot consumption and wind and solar and try to see a pattern. So I can say par function, and I will say 3 rows and 1 column. So now when I start plotting, you will see you will have multiple plots in one single window. So let's see how we do it. So here, let's look at plot 1. So this one is consumption as we did earlier. And let's look at the data. So that gives me some data. You can always do a zoom and you can look at the data. You can basically expand this graph or you can reduce this graph to see what kind of pattern we have in consumption. Similarly, we can basically choose date being x-axis, my consumption being y-axis, right? So this is being more specific because here we have a range, but it really does not give me enough information. So I will basically give x-axis, y-axis. I will give the name, that is daily totals, and then I will basically give consumption, color, and y limit based on my minimum and maximum limits. So let's do this. And now we can look at the data here. So let's see, this data makes a little more meaning because we are looking at the dates. And let me do a zoom. So it shows me all the dates. It shows me the data points. It shows me how the data pattern is changing for consumption. Now, this is for consumption. So what we can do is we can also extract specific data. So if you see here, I have done some testing where I'm saying, okay, I would want to get a date specifically. I would want to extract some value. So we are looking at the date column, but if you remember, we did not change the data type. We just changed the data type of date column. We extracted year, month out of it. It would be good if we can convert a column into date time format and put that in our data frame. Now, let's look at the plot 2. This is mainly for your column, which should be consumption and wind and solar. So here I see it is solar data, and I can plot this one to see how it looks like. And that tells me from 2006 onwards, we have some pattern. I can be more specific where I say I would be giving date and then the column for solar, x-axis, y-axis, what is the type, what is the y limit, and what is the color. It is always good to specify your x and y axis, give a name rather than let it automatically pick up. Now this makes more meaning because it shows me some dates. Similarly, we can do for wind. So either you do it just by giving the column or you give your x and y axis. So let's look at this one. And this shows me the data. So we can choose plot 3. This one, we can choose plot 2. We can choose plot 1, and we can put all that data in one graph. So that's when you are putting in multi plots in one particular graph. You can always do a zoom. You can always look at the data, right? And this is usually useful to look at the pattern, what kind of pattern we see, what data we have, and so on. Now, moving forward, so we have seen how you are creating these plots all in one window. Let me reset this back to one plot per window. And let's basically plot time series in a single year. So what we have seen is that when you look at the plot method, it was quite crowded. Then we looked at solar and wind. And if you compare that, you will see your consumption pattern, your solar pattern, your wind pattern, and basically we can see from this particular data some kind of pattern. So electricity consumption is highest in the winter, where we will see what is the consumption. Is it highest in winter or is it in summer? We can see that by breaking a year further into months. We can see that, but we see a pattern which goes for every year or every 2 years being highest at a particular point of time, and then it drops down. So electricity consumption is highest in winter, and that might be due to electrical heating and increased lighting usage, and lowest in summer. Now, when you look at electricity consumption, appears to split into two clusters. We can always look at the consumption, one with oscillation centered roundly around 1400 gigawatts. So you can always look at 1400 gigawatts and you see all the values here which are in that particular consumption. Another with fewer and more scattered data points, centrally roughed around 1150. So if you really expand this, you can see you will have a lot of data points at this point. Now, we might guess that these clusters correspond with weekdays and weekends, which we can see if you break that data into yearly, monthly, weekly, and so on. Now, if you look at solar production, that is highest in summer when sunlight is most abundant, and lowest in winter. So obviously when you're making or gathering some insights, when you're looking at the data, you are also using your domain knowledge, your business knowledge, your knowledge of business to understand how this goes. If you look at wind power production, that's again highest in winters and drops down in summer. So due to stronger winds and more frequent storms, and lowest in summer. So there is some kind of increasing trend in wind power production over years, which we can see here over the years. And all the time series data what we are looking at is referring or showing us some kind of seasonality. That is, we are looking at seasonality in which a pattern is repeating again and again at regular times, at regular intervals. So if you look at consumption, solar, and wind time series, that oscillates between high and low values on a yearly time scale, which we can break down and see. I'll show you that. It corresponds with the seasonal changes in weather over the year. So seasonality does not have to correspond with meteorological reasons. For example, if you look at retail sales data, that will show you yearly seasonality with increased sales in particular months. So seasonality, when we say, can occur on other time scales. So the plots what we are seeing here, they are fine, but if you look at those plots, they might show some kind of weekly seasonality also. So in your consumption corresponding to weekdays and weekends. So let's plot for one single year. Now, how do I do that? So first is I will look at my data 2. That shows me the structure. It shows me date, which is factor, other columns, which are all numerics. Now, like we did earlier, I'll repeat this step where I'm going to convert the date column into date type. Look at head of it, look at class of it, look at the structure of it, right? And then what I want to do is I want to add this to my data frame. So I will create a variable called mod data, and this one will have as data, and I'm formatting the value of X, which is date time, into month, day, and year. So let's do that. And now you look at the mod data, which I created, like modified data. So this is the format I have. It is in date type, if you carefully see here. And then I can look at the head of it. So it says me mod data. Now what we did here is when I said my data 3. So my data 3, we did a cbind and I did a mod data, which is going to add this column to my other columns of my data 2. So my new data frame is my data 3. Let's look at the structure of it. And you see there is this date column. I can delete it, I can remove it, I can let it be, right? So that depends on our choice. Might be we want to, once our analysis is done, we want to remove the mod data, right? So we can keep both of them. Now let's basically extract data for a particular year. Now how do you do that? So this is some wrangling. So I will say my data 4, let's call it my data 4, and I will use subset function. So subset will work on my data 3, that's the data. And what I'll do is I will do a subset. How is the subset found? So I'll say take the mod data column, the value should be greater than or equal to 2017 and should be less than 2017 December 31st. So I'm getting data for 1 year and I'm storing it as my data 4. Let's get the head of it, and you see we are specifically looking at 2017 related data. Now let's do a plotting of this where I will only create a plot for 1 year. So I'm saying my data 4, that's my new data what we got. So here I am going to take the first column, which is mod data. I'm going to take the third column, which is consumption. So I'm looking at the date format for 1 year, consumption values for it, and then rest of the things as we have done earlier. Let's look at the plot, and this makes more meaning, right? So when you look at this plot, it tells me Jan to Jan. It shows me some kind of pattern where I have divided the year into months, right? And it is broken down into say 2 months, so Jan and March and May and July and so on, but we still see a pattern, and that gives me good understanding of pattern where I've broken it down into months. So this is where you have taken time series in a single year to investigate further, and this is what we see, right? Now we can clearly see there are some weekly oscillations. What one more interesting feature is that at this level of granularity, that is when you're looking at yearly data, there is a drastic decrease in electricity consumption in early January and late December during the holidays, or probably we can assume that this is holidays. Now I can zoom in further and look at just Jan and Feb data. Let's see how we do that, and let's see how we work by zooming in the data further. So to zoom in the data further, let's see how we do it. Now here we have this my data 4, which is basically having a subset, right? So let's work on this one. So I will say my data 4, which earlier I was taking data 3, I was doing a subset and I was giving the date, but this time I will make it more narrower. So I'll say my data 4, I will say subset from my data 3, and I will choose mod data column, which we have modified with the date format. I will choose the starting date as 1701, that is Jan, and then let's go till Feb and let's create this. Now let's look at the head of this. So it shows me we have the data which is Jan, and then you can basically look at more on this. Now again, as I said earlier, let's find out the minimum of this from the first column. So that is basically your mod data. So let's look into this one, and that basically will give me minimum and maximum. Let's look at the values. So this one tells me Jan 17, January 1, and maximum is your Feb 28th, second month 2017. So we are actually looking at 2 months data here. Let's look at the Y minimum. So this is, I will look at column 3. Now what is column 3? Consumption. So let's look at the minimum value for consumption, maximum value of consumption. Let's look at the values which can be given as our limits. Now this is the minimum and maximum. Now let's do a plotting for this data which has been narrowed down for consumption based on my data. So I'm saying my first column, which is mod data, and then third column, which is consumption. I'm giving some naming convention for, namings for your x-axis, y-axis. What is my consumption? or what is my title here, what is the color, and then you see I'm using X limit to give the minimum and maximum limit and Y limit. So let's look at this data. And if you look at this data, it is specifically for 2 months. And again, I can look at the pattern here. What I can also do is I can add some grid here. So I can basically look at this data and make more meaning out of it. So it is bi-weekly data, you can see. Now I can add a line here using ab line, and then I can basically choose what lines I would want to add horizontally. So that basically allows me to dissect the data and look at data in a more meaningful way. I can also add vertical lines. So vertical lines is I'm saying sequence will be minimum, maximum, and I'm saying an interval of 7. So let's do this. And this basically has added some lines every week. And you can see at the end of week, it is dropping and then it is starting again. It peaks somewhere in the mid of the week and again it drops down. So this is, you're looking at your consumption data, right? Now what we can also do is we can create some box plots. So when we looked at zooming in data for Jan and Feb, you can add some data points like this. So consumption is highest on the weekdays, as I showed you here, and lowest on the weekends. So this is what we are seeing when we are breaking the data or zooming it further for a couple of months. So we have vertical grid lines, and we have nicely formatted tick labels, that is Jan 1st, Jan 15th, Feb 1st, and so on. So we can easily tell which days are weekdays and weekends with use of these grid lines and basically breaking it down. So there are many other ways to actually visualize your time series data depending on what patterns you're trying to explore. You can use scatter plots, you can use heat maps, you can use histograms, and so on. Now, moving further, we would want to explore the seasonality, right? So when you further explore the seasonality of our data, we can use box plots basically to group the data by different time periods and display the distribution for each group. Now, how do we do that? Let's come here and let's see how box plot works. So I can just do a simple box plot and I can choose my consumption column, and that gives me just the consumption data, but this really does not give me any meaning. I can look at solar data, I can look at the wind data, and we can also see some outliers here. So we can create box plots, but if we would want to do a box plot, what is box plot? It is basically a visual display of your 5-number summary. That is, you want to look at your mean, median, you want to look at your 25th percentile, 50 percentile, or 75th percentile. So we can use a quantile function, use the consumption column, and then you basically give a vector which shows you 5-number summary. So that's your quantile. And then let's do a box plot. So if you are looking at quantile, it tells me what is the minimum, what is 25th percentile, 50, 75th, and 100. That's from my consumption column. So let's create a box plot for consumption. Let's give it a name as consumption. Let's give y-axis as consumption and a limit for y-axis. Now that's my consumption graph. So I can look at yearly data. Now that will make more meaning rather than just looking at the complete consumption data. So how do we do it yearly? So we will say consumption, and then I will say the year column. So it is consumption, but grouped based on year. So here I can give x-axis, y-axis, and I can give y limit. So let's create this, and this makes more meaning. We can give some coloring scheme here, but now I'm looking at 2006, 2007, 8, 9, and so on. And we can look at the data, what is the range, right? It gives me 5 percentile, or sorry, 5-number summary of the data per year, and it basically allows me to look at the seasonality of this. Similarly, we can create box plot by just giving consumption, yearly grouped, and here I'm giving the title as consumption, y-axis, x-axis, and y limit, wherein I can also use las. So this is one more feature which you can do, and that basically will give me the tick points. If you compare this one to the previous graph, So when I created this previous graph, I had 2006, 2008, and I had from 600 to 1800. And if I go for the next one, I am basically seeing more useful information. Now let's look at monthly data. So I would want to group it based on months, and let's create that. So this gives me the monthly data where I'm looking at months, and I could select a particular year, or I can just do a grouping based on months. So I can have multiple plots to see a difference here. So let's do this. Now let's create a box plot for consumption, which is monthly data, and let's give it a color. Let's look at the wind data, which is again grouped monthly, and let's look at the solar data, which is grouped monthly. Now, if I zoom in, it basically gives me the seasonality of the data for your wind, for your consumption, for your solar. So what we are doing is we are creating these box plots which are giving us values. Now what I can also do is I could look at the day wise also. But before we look into this, how do I infer some information from these box plots which are being created? So this is what we have done, where we are looking at the data for month, and these box plots give me year seasonality, which we were seeing in earlier plots, but give some additional insights. So if I look at the data here, it tells me the electricity consumption is generally higher in winter. Now this is based on months, so we can see consumption is higher in winters and lower in summer. So we can obviously look at our plot, we can see where it is lower, where it is higher, and then we can look at the median and lower two quartiles are lower in December and January compared to November and February. So that is, you look at the quartiles and you will see that the median and lower two quartiles are lower in December and January. Here Jan and December, so you can look at from my plot. Now this is giving you some idea on seasonality. Now that might be due to business being closed over holidays. Now this one we were also seeing when we looked at time series for 2017 only, and box plot basically confirms that there is this consistent pattern throughout the years. Now when you look at your solar and wind power production, both will give you a year seasonality, what we are seeing here. And if basically I look at the data, so it depends on what parameters you are choosing, but if you look at solar, it will reflect the effect of occasional extreme wind speeds associated with storms and other transient. And since we are grouping it based on months, we can see this pattern is quite evident every year. Now, what we can do is we can group the data day wise. So here, let me again reset this to one plot per graph. Now I'll say box plot. I'll say consumption, which is grouped based on day. Now we know that there is a day column, and let's give a while limit and let's look at the data. So this is where I'm grouping the data day wise. So you look at 31 days and you look at the box plot. So this is where you are plotting it on a daily basis. So you can look at the data, you can break it down to a particular week. So here I have given day and I have chosen all the 31 days, but I can break it down to a week and I can look at the data. So if we look at the data per week or per day, we can basically infer that electricity consumption, where I'm doing a consumption group by day, is higher on weekdays than on weekends. So time series with strong seasonality can often be represented with models that can decompose signal into seasonality and long trend. Now this is an easy way. Now how do we look at the frequency of the data? That could be interesting to see. So let me look at, say, the yearly data, which we were seeing here. Now let's go further, and here we have looked at data. So what we will do is we look at the frequency. Now, when you look at the frequency, when you talk about frequency in your data, so we have the modified date column, which gives me a frequency. And if we really look into the data, that will tell me that the data is on a daily basis. So for that, let's look at my data 3 again, which gives me data, and you can just see all the data or dates are in sequence. So your 22, 23, 24, 25, 26, and so on. I can access a dplyr package that is basically allowing me to work in a better way. Now I can look at the summary of this, and for all my columns, I'm seeing what is the minimum 5-number summary, date, and consumption. So date does not show me anything because this is not in a date format, it is just a factor, but other things have the 5-number summary. So we are looking at wind plus solar, we are looking at year and month and day and all these columns. Now what we will do is we will want to find out the sum of each column, how many entries does it have, and we will say the value should, NA value should not be considered. So let's look at this one. So it tells me for my particular columns. So let me run this again, and that shows me for each column how many values you have, and these counts do not include the NA values. Now similarly, I can find out specifically for consumption, I can find out is there any NA value. So I'm saying is.NA, and let's find out if there is any NA value or missing value in consumption. It says 0. Okay, that's good. If you look in wind, it tells me there are 1463 entries which are NA. Similarly solar, similarly wind dot solar or wind plus solar. So it gives me a count of NA values, that is missing values, and also values which are not missing. So to understand frequency, what we can do is we can find out the minimum on the date, that is the first column, and I'm saying RM na.rm is true, that is get rid of NA values and find out the minimum. And let's look at the minimum value. This is the minimum from my modified date. Now if I would want to get the frequency, I can basically use sequence function. So I can say from X minimum, that is the minimum value, I want to look at the frequency, that is day wise, and let's just look at 5 entries and see if there is a day by day frequency. So let's look at the value of this, and obviously it tells me there is day wise frequency. So that allows me to look at the frequency, look at the type of it. It is an integer, class is a date. So similarly, we can say from X minimum, we can basically look at the frequency month wise, and I can again look at 5 records. So that shows me monthly data, right? So I can extract the data for frequency, similarly yearly data, and that's also very useful. Now we can select data which has NA values for wind. So how do I do it? I would want to find out the wind column, and I want to find out where the values are NA. So I will create a variable, and here I will say my data 3, and then I give a conditional where I say is NA in the column. So let's do this. Now once I've done this, I have said that my selected wind data from my data 3 where we said NA values, and I will give the names to this. So names should be in my data 3. I'm interested in mod data, consumption, wind, and solar. So these are the 4 columns I'm interested in. Let's look at first 10 records here, or first 10 rows. So that tells me these are the values where wind has NA or missing values. I can always do a view, and that gives me the complete data. So it basically shows me 1463 entries, and here it shows me all NA values. So you can look at all the way to the end, and it shows me wind has NA. Solar does have some value here in the last row, but then also if you see the numbers have a difference. So you have 1461 and then you have 2174. So there is a difference. So there is some data in between where wind has some values. So we have found out NA values. Now what we will do is we will select data which does not have NA values. So I will call it cell selected wind 2. I'll again use my data 3. I will say which, but now I'm saying not NA from this column, and I will select the data for the columns. So I'm interested in looking at 10 records, and this shows me not NA values, so no more missing values. So if I really look at this data as I saw earlier, which has NA, and if I look at these values which are not NA for the wind column, so looking at these two results, we will know that in year 2011 wind column has some missing values. So let's focus on year 2011. So how do I do that? Let's call it a different variable. I'll say my data 3. I will say here, when I say which, where we were saying NA, here I will say the year should have a value of 2011, and I want all these columns. Let's look at the data here, and this is showing me 2011, but we are not seeing all the values. So there are some values, but then there are some missing values also for 2011 based on whatever analysis we have done. So let's look at the class of this. It is basically a data frame, do a view, and this one will help me in finding out where are the NA values. So if you just scroll down, looking at all the data, let's search if wind column has a NA or a missing value, and I will see if there is any missing value, in which column or which row it is for the wind column. So we have all the values which are existing. I could select and search for one specific value, and I'll show you how we can do that. So here, let's scroll all the way down. So it's like you're exploring your data and seeing, is wind column having NA or missing value for a particular row. And let's scroll here, and here you see there is a missing value for one particular row. So 13th December 2011 has wind value, 15th December has wind value, but your 14th December does not have, right? Similarly, we can search. So there was only one entry which was missing. Now that could be for some reason, might be it was not calculated, might be it was not tabulated. So we have a missing value, and that can affect my plotting, that can affect my analysis. So let's look at the number of rows in this, which will tell me how many rows we have for 2011. So it tells me 365. So that is basically the number of days in a year. Now we will find out if there were NA values. So we earlier checked total number of NA values per column. That is in your row number 265 to 269. We can see here 265 to 269. So this is where we were seeing, are there any NA values, right? So let's go back here, and we want to find out the number of NA values for a particular year. How do I do it? So I can just do a sum. I will say is NA. Now I'm interested in my data 3 wind column, and I'm saying my year has to be 2011, but I'm finding out the NA values. So let's do this, and it tells me 1, and that's right. That's what we saw when we did a view. Let's see how many non-NA values you have, and that is 364. So that basically satisfies my logic. So it's 364 plus 1 missing, so there are 365. Let's look at the structure of this. It tells me you have modified date and date format, you have consumption, wind, and solar. Now let's create a variable selected wind 4. I will say wind 3, that is which was having all my NA and non-NA values for 2011. I will say let's find out the NA value, because I'm interested in finding out that particular row. So I'm saying find out where the value is NA, and I want all the columns. Let's look at this one, and this is my specific row which has a NA value. Now we know that data follows a day-wise frequency. which we have clearly seen. Now let's select data which has NA and non-NA values. So let's call it test 1. I will use Wind 3, which has NA and non-NA values. But now I will say I want the modified date, which should be greater than 12/12/2001. Now remember, we had, when we were doing a view, we saw that one particular day, or what we see here, 14th of December, there is no date. So I will select a subset of data which includes this NA and non-NA. That is, might be I can take 13th of December and 15th of December. So let's start from 12/12. So the date should be greater than 12/12. That means 13th, and it should be less than 16. So that is 15th, and the columns, right? So now we have some data. Let's look at this. So I've selected a subset of data. I could have done this using subset also. So I have NA and non-NA values. Now, why are we doing this? So sometimes you might have some data for a particular column and you may want to find out if there are any missing values. Might be you want to fill them up or replace them with something. So that is usually useful when you are doing a trend detection. So say, for example, you have data for every month, and might be in one of the months you have missed, or might be you have data for every year collected monthly, and then in one of the years for a couple of months you don't have the data. Like I can say 2016, I have data for all 12 months, 2017, all 12 months, 2018, might be I don't have data for March and June, 2019, I don't have data for same months. So I can forward fill or backward fill them using the previous year's same month data. So we can do that. So here I have test data where I've extracted a subset of data. I can look at the class of this. It is a data frame. Structure of this, it has the columns. Now let's use the library and function and use the tidyr package. And what we will do is we will fill it up. So I will use test 1. I will fill the wind column, which has a missing value. Now, once you do this, if you notice, it has done a forward fill. So it has taken the previous value and it has just filled up that. So you can fill up the data using different directions, such as up and down, left and right, and so on. So we can take care of missing values in our frequency data, which allows us to basically analyze the data in a better way. Now, here we will want to also look at some more data. So this is to deal with frequencies of fill column, wherein you can take care of missing values forward filled. So filling values can be done in different directions, as I said, and you may want to first convert your time series to specified frequency if your data does not have a frequency, but we had. Now, if you do not have a frequency, might be you can convert it into a frequency such as weekly, daily, monthly, as I showed you, and then basically you can do a forward fill for the values. So for example, if I have my data, I can break it down into weekly and then look at the values, and if there are any values missing for weekly data, I can use a forward fill. So that can take care of my frequency data. Then let's look at the trends of the data, which is the last part of this project. So basically, let's look at the trend. So when you say trend, what does that mean? So in time series data, you always have some kind of trend. So that will exhibit some slow, gradual variability in addition to higher frequency variability, such as seasonality and noise. Now, to visualize these trends, what we do is we use what we call as rolling means. So we know how our data is spread over year or month or day. But how about looking at a rolling average and see what is the difference? So a rolling mean will tend to smooth a time series by averaging out the variations and frequencies. So this can be higher than the window size. So there is something called as windowing, where you can choose a set of time frame. You can also average out any seasonality on a time scale equal to window size. So this will allow you to look at lower frequency variation in the data. So when we are looking at electricity consumption time series, we already saw there is a weekly pattern, there is a yearly seasonality, which we saw using box plots. So we can also look at the rolling means of the time scales. How do we do that? So for this, you can use some package like Zoo, and then you can basically use a rolling mean using the Zoo package, and you can say what is the frequency with which you want to calculate the rolling mean. Now, how do we do this? Let's look at this data. So here I'm going to look at my data 3, which we have been using so far. Now let's call it a 3-day test. You can give it any name. I'm going to use my data 3. I'm using the Phyton function. Now I will use dplyr and I will arrange the data descending in year. Now you can always break it down step by step and you can see the result of this. So I'm going to arrange this data in descending order of year. So obviously my last one, 2017 or 2018, will be on the top. You want to group the data by year. So it depends on how many years we have, we'll see. So you can group the data by year. Now this data is then used to basically mutate. So mutate function is going to allow me to use this rolling mean. So I'll call it as says 03 day. So I'm going to calculate a rolling mean every 3 days for my consumption column. And basically let's ungroup this. So let's see how this works. Sorry. Yeah, let's look at this. And here, when I'm doing a 3-day test, let's look at the result of this and then I'll explain this. So if you see here, we have the test 3-day column. Now this has the rolling average. Now what does that mean? So first value here, what we see is 1367 is the average consumption in 2017 from the first date with a data point on either side of it. That is, you can look at this date, so 1130, then you look at, you're looking at the value 1367 here, so you look at 1130, 1441, 1530. If I take a mean of these, so for example, if I would just do this part, and that is giving me mean, okay, because I have a comment, so let's basically add anything as comment, and then let's do this. So it says me 1367. That's what we are seeing here, right? So you're getting a rolling average every 3 days. Similarly, if you want every 5 days, it takes the 5 values and it gets the mid value, right? So you can always find out the mean, rolling mean for a particular frequency. Now let's do that for 7 days, that is weekly data, and yearly data, that is 365 days. So how do I do it? Same logic, my data test. Now I'm using my data 3, I'm arranging it in a descending order, I'm grouping by year. So when you do a group by year, so earlier when we did a grouping by, and when we looked at the data, it was telling me how many rows we had, right? So let's do a grouping by year, and let's say test 07. So that's a rolling average every 7 days, and I'm also saying take care of the NA values. Similarly, I'm getting rolling average every 365 days. Might be you can do quarterly, might be you can do half yearly. And let's do this. So let's create this, my data test, and let's look at the result of this. So I will use my data test. I will say arrange based on modified date. Now we know there is a column called modified date. I want to just look at 2017 data. So I'm doing a filter, right? And then I will choose what are the columns I'm interested in. So I will look at the 7 and 365 day, and let's look at say first 7 records. So let's do this, and that basically gives me the consumption value, modified date, year, and my rolling 7-day average or the 7-day mean, which is for first 7 days. And then 365, you will not see the data here, but if I do a view on this, I can basically see the values. So you can always select a particular column to see the values. These are the values for every 7-day rolling average. This is for 365 days, every 365 days. So you see all the values are missing, but every 365 entry, you will have basically some data. Now, let's do a plotting of this and basically visualize this data which we are seeing rolling average. So let me first do a plotting, one plot per graph, and let's do a plotting. I will take consumption data, x-axis, y-axis, color, and give a title to this. So let's create this, and that's my consumption data, which is spread over a period of time, and that's fair enough. But now let's add some more plot to this. So I will add the 7-day rolling average to this. So for second plot to be added in the same one, in R you can use points. So I will say points. I will choose 7 data column. Type is line, width, X limit, Y limit, and color. So let's do this. And that's my pattern 7-day rolling average, which basically gives me some kind of trend. Similarly, I can add one more here, and this time I will choose the 365-day and look at the pattern lines. So now you see some dots here. Well, you could do it in a different way. So I can just add legend to this, and I can say legend will be where in x-axis and y-axis. So I'm saying it will be 2500 and y is 1800. So my legend will come in somewhere here. I'm saying my legend will have consumption, test, and this one I can give some names. I can give what is the color. I can say what kind of legend it explains, what is for each color, and then basically a vector. So let's add a legend to this, and I've added a legend. Now you can do a zoom and look at the data, and here I see that my x-axis is fine, but y-axis is going a little out of my plotting area. So I can actually change that. So here I have 1800. How about making it 1600? And let's look at this one. So we can basically go for this one and start again here, plot and points and line, and then add a legend, right? And you can basically place your legend anywhere in the plot. So this basically is giving me the trend, what I'm looking at, my rolling average. So similarly, you can look at the trend for wind and solar data. So what we are seeing here is when you look at trend, this is one more way of looking at it. You can always create plots in different ways. So 7-day rolling mean has smoothed out all weekly seasonality, which we were seeing here in my graph, where you look at every 7-day, preserving the yearly seasonality. So 7-day will tell that electricity consumption is typically higher in winter and lower in summer. So better is you break it down yearly. So here, if you look at every year, you can see when is winter, when is summer, what is the seasonality, what your trend, what you're seeing here, and if there is a decrease or increase for a few weeks every winter. So similarly, if you look at 365, now as I said, rolling average basically reduces the variation. So if I look at 365 rolling mean, we can see long-term trend in electricity consumption is pretty flat. Now that's what we are seeing. It's kind of pretty flat. There is not much variation over years if you really join these dots. So we can basically see some highs and lows, and that gives me a trend. Now this is how you can do a trend detection, and similarly we can do plotting for wind and solar. So this is a small project which I demonstrated using R. Now all this code which you have here in the form of a project.r file, you can find here in my GitHub page. This is the document which explains some things. Feel free to download this and you can add details to it. This is the sample data set, which you can also find in my repository in the datasets folder. So continue learning and continue practicing R.
Excel is a really powerful tool for data analytics and reporting, and pivot tables are one of the features that Excel offers for creating tabular reports to summarize our data. Let's begin by understanding what is a pivot table. A pivot table is a tool that summarizes and reorganizes selected columns and rows of data in a spreadsheet to obtain a desired report. It does not actually change the spreadsheet data. it simply pivots or turns the data to view it in different perspectives. Pivot tables are especially useful with large amounts of data that would be time consuming to calculate manually. Now, let's understand the different components of a pivot table. So there are 4 main components. First we have rows. When a field is chosen for the row area, it populates as the first column in the pivot table. Similar to the columns, all row labels are unique values and duplicates are removed. Columns is the second component. When a field is chosen for the column area, only the unique values of the field are listed across the top. Then we have values. Each value is kept in a pivot table cell and displays the summarized information. The most common values are sum, average, minimum, and maximum. Finally, we have filters. Filters apply a calculation or restriction to the entire table. So let's jump over to Microsoft Excel and let me show you the dataset that we will use in this demo. So with India being ready for its 16th census in 2021, that is next year, it is a good time for us to analyze India's last census data from 2011 and see where different states and cities across India stood in terms of population, literacy, and other socio-economic factors. We will analyze this data by creating different pivot tables in Excel and explore some of its features. So let's begin. First, I'll show you one of the features that Excel offers us. So suppose I click on any cell and hit Ctrl plus Q, you can see our entire table is selected, and at the right bottom there's an option of quick analysis. Now you can see by default Excel has prompted certain features such as formatting, we have charts, totals, and there's one more called tables. Now Excel by default has created some pivot tables for us. Now the first one you see is sum of district code by state names. Next we have sum of sex ratio by state name. Then we have sum of child sex ratio, sum of male graduates, and sum of female graduates by state name, and there are others. Before creating our pivot table, so let's have a final look at our data set. So first column you see is the city column. So there are different cities from different parts of India. Then we have the state code, we have the state name, district code, we have the total population followed by male and female population. Next you can see we have the total literates from each city. Then we have the male and female literates. Next we have the sex ratio. Then we have the child sex ratio. Next we have total number of graduates. And finally you can see we have male and female graduates. So using this table we'll create several pivot tables. Now first of all, let's create a pivot table to find the total population for each state and sort it in descending order. So you can see here we have the problem statement. So our first pivot table will have the total population for each of the states in descending order. So to create a pivot table, you can click any cell in your data, go to the Insert tab, and here left you can see we have the option to create a pivot table. So let me select pivot table. Now my range is already selected, the entire table, and here I'll choose existing worksheet because I want to place my pivot table in the same worksheet, and I'll give my location, I'll point to cell Q5. Now let me click OK. You can see the pivot table fields appears here on the right. Now since we want to find the total population for each state, so what I'll do is I'll drag my state name onto rows. So here in our pivot table you can see we have the different state names listed. Now we want the total population for each of these states. So in the field list I'll search for total population, which is this one, and drag it under values. You can see we have our sum of total population for each of these states. By default Excel will sum any numeric column. You can always change it to average, minimum, maximum, anything you want. Now we want to sort this column in descending order. So I right click, go to sort option and choose Z to A, that is largest to smallest. You can see here in 2011 Maharashtra had the highest number of population, or the total population in Maharashtra was the highest. Then it was Uttar Pradesh, we had Andhra Pradesh, and if I come down we have Nagaland and Andaman and Nicobar Islands towards the end. So this is a simple pivot table that we created. Now the next problem we have is we want to find the total sum of literates in each city belonging to a certain state. So let's see how to do it. I'll click on any cell, go to insert, and here I can click on pivot table. My range is selected. I'll choose existing worksheet and give my location, which is Q5. I click on OK. Now here we want to find the total sum of literates. So what I'll do is, first let me drag total literates column to values. You have the total sum of literates from all the states. Next, I want to see the sum of total literates based on states and cities. So let me first drag state name onto rows, and then we'll drag city onto rows. You can see here we have our pivot table ready. To the left of the pivot table, you can see we have the state names and the cities per state, and on the right you can see the total number of literates from each city. If I scroll down, we have Assam, then you can see we have Bihar, and if I keep scrolling, we have all the states, Haryana, Himachal Pradesh, there's Jammu and Kashmir, which has now become a union territory. We have Jharkhand, Karnataka, and other states as well. Moving on. Okay, so the next thing we want to see is what is the average sex ratio and the child sex ratio for each state. With that, we also want to find the states that had the highest and lowest sex ratio in 2011. So let's create a pivot table for this. I'll click on any cell, go to insert, choose pivot table, click on existing worksheet. I'll select cell Q5 and click on OK. Now, since we want the average sex ratio and the child sex ratio, so first I'll drag those columns. Either you can manually scroll and drag it, or here you have the option to search for it. So if I look for child, you can see we have the same column listed. You can just drag it from there. Let me delete this. And I also want the sex ratio, so I'll place it on top of child sex ratio. Next, we want to see it based on different states. So what I'll do is I'll take state name and put it under rows. So here you can see we have our pivot table ready. On the left you can see we have the different state names listed, and on the right we have the values. Now we want to find the average. Now by default Excel will sum the numeric columns. You can see it tells you sum of sex ratio and child sex ratio. So what you can do, you can click on this drop down and go to value field settings, and here summarize values by, you can choose average. You can see the custom name, it says average of sex ratio. Click on OK. Our entire column is now giving us the average sex ratio. Similarly for this column, let me convert it into average. I'll again click on the drop down, go to value field settings, click on average and click OK. And you can see here we have the average of child sex ratio for each of the states. Now the next question says which states had the highest and lowest sex ratio. So we'll consider this column. So we'll sort it in any order you want. You can do it either ascending or descending. Let me sort it in descending order. You can see we have our column sorted now. So in 2011 Kerala had the highest sex ratio, and if I scroll down to the bottom you can see Himachal Pradesh had the lowest, which is around 818. Up next, let's explore one more feature of pivot table. So suppose you want to see the top or bottom few rows of a pivot table, you can do that as well. So here we have a question at hand. We want to find the top 3 cities with the highest number of female graduates. So let's see from the entire pivot table how we can filter the top 3 cities. So I'll go to insert, click on the pivot table option, go to existing worksheet, click on Q5, and hit OK. Now since we want to find the top 3 cities, I'll drag city column onto rows, and then we want the female graduates, so in the search bar I'll look for female and I'll choose this column, that is female graduates, and drag it here onto values. So I have the sum of female graduates for each of the cities. Now since we want to find the highest number of female graduates in the top 3 cities, so let me first sort this column. I'll sort it in descending order. Now we have it sorted. Now from this you can say that Delhi, Greater Mumbai and Bangalore are the top 3 cities, but it's displaying all the cities for us. So let's filter only the top 3. So what you can do is right click and go to filter. Under filter you have the option of top 10. I'll select this. Here I only want the top 3. So either you can go down like this, or you can directly type 3. Your column is already selected. Let me just click on OK. There you go. We have the required pivot table ready, and it only displays us the top 3 cities with the highest number of female graduates. Now the next thing we want to see is how to use a slicer in a pivot table. So we have a question here. What's the total population for all the cities in Rajasthan and Karnataka? So let's create a pivot table for this and see how you can use a slicer to filter the table. Click on existing. I'll click on a location, this time Q6. Click OK. Now since I want the total population, so I'll drag total population onto values, and then I'll select the city onto rows and then the state name also. I'll place it on top of city. So you have in the pivot table all the states and their cities, and on the right you can see the total population for each of these cities. But our question is, we want to find only for Rajasthan and Karnataka. Now for that, what you can do is go to insert and create a slicer. Either you can create from this option, or you can go to pivot table analyze option, and here you have the option to create or insert a slicer. I'll click on this, and since we want to slice the table based on state, that is Rajasthan and Karnataka, I'll choose state name as my slicer field. You can see this is my slicer here. Now you only want the data for Rajasthan and Karnataka, so I'll search for these two. So here we have Karnataka, so let me select Karnataka first, and I also want for Rajasthan, so let me select Rajasthan also. You can see in our pivot table we only have data for Rajasthan and Karnataka. So this pivot table shows you different cities from Karnataka and the total sum of population from each of the cities, and similarly we also have for Rajasthan. Moving ahead, now we will see another very interesting feature of pivot, that is how you can create percentage contribution of a table. For example, we have a question here. What's the percentage contribution of male and female literates from each state? Now we want to see in terms of percentage and not as sum or average. Let's do that. I'll create my pivot table, click on existing, and I'll select an empty cell. Okay. Now here, since we want to find the percentage contribution of male and female literates, so first I'll drag male literates onto values, followed by female literates onto values. By default it has summed up the male literates and female literates value. And also I want to drag state column to rows. So here you can see the sum of male literates and female literates per state. I want to convert this as percentage contribution. So what we can do is, I'll select any cell and I'll right click and I'll go to show value as, and here I have the option to select percentage of grand total. So I'll select this. You can see we have the percentage contribution of male literates to the total. Now if I sort this, you will get to know which state contributed or has the highest percentage contribution. So we have Maharashtra for male literates, then we had Uttar Pradesh in 2011. If I come down, we had Meghalaya, Nagaland and Andaman and Nicobar Islands as those states which had little or minimal contribution to male literates. Similarly, let's do it for female literates. I'll go to show value as and select percentage of grand total. So you can see here also Maharashtra, Uttar Pradesh, then Gujarat and all had the highest percentage contribution to female literates. So this is another good feature to convert your data and see it in terms of percentage. Now moving ahead, let's say we want to find the bottom 3 cities from each state that had the lowest female graduates. We can do that as well. I'll go to insert, click on pivot, go to existing worksheet, select an empty worksheet and click on OK. Now since I want to see based on states as well as cities, so let me drag the state name first onto rows and let's drag the city column onto rows. Next, we want female graduates, so let me look for female graduates in the field list. I'll drag it onto values. Now we have the list of states and their respective cities, and to the right of the pivot table you can see the sum of female graduates from each city. Now first I'll sort this column. I'll right click, go to sort and click on shortest to largest. Now we have sorted our female graduates from shortest or smallest to largest. Now since I want to find the bottom 3 cities from each state, I'll come to this cell, right click, go to filter and select top 10. Now I'll replace top 10 with bottom and I want the bottom 3 cities from each state. I have my column selected, that is sum of female graduates. If I click on OK, you can see here some of the states don't have 3 cities. So you can see Andaman and Nicobar Islands has only 1 city, that is Port Blair, while the remaining you can find the bottom 3 cities with the lowest number of female graduates. So Andhra Pradesh had these 3, in Assam we had Nagaon, then there was Dibrugarh and Silchar. Similarly, if I come down in Haryana, we have Palwal, Kathal and Zind. If I come further, here you can see for Karnataka there's Gangavati, there's Rani Benur and there's Kolar. Similarly, you can see for Kerala as well. Now moving ahead, now in the next example, I'll tell you how you can create a calculated field or a calculated column in Excel with the help of a pivot table. So in a pivot table, you can create or use custom formulas to create calculated fields or items. Calculated fields are formulas that can refer to other fields in the pivot table. Calculated fields appear with other value fields in the pivot table. Like other value fields, a calculated field's name may precede with sum of followed by the field name. So here we have a sales table that has columns like the items, which has different fruits and vegetables, and those have been categorized as fruits and vegetables. We have the price per kg, and this is in terms of rupees, and we have the quantity that was sold. Now let's see, if you want to find the sales for each item in the table, you can create a calculated field. So your sales column is going to be the product of price per kg and quantity. So let me show you how you can do that with the help of a pivot table. I'll create a pivot table first. Click on an empty cell, hit OK. Now if you see on the top, under pivot table analyze and under calculations, we have the option fields, items and sets. If I click on this drop down, I get the option to create a calculated field or insert a calculated field. I click on this. I'll give my field name as sales and I'll select my formula. I'll first click on price per kg and hit insert field. I'll give a space, hit shift 8 to give the product symbol, and then I'll double click on quantity. Now this is my formula for sales, that is price per kg multiplied by quantity. I'll click on add and I click on OK. If you see here, there's a calculated field that is present in the pivot table fields, which is sales, but it did not add it to our original table. Our original table is the same, but here we have added a calculated field which is present only in the pivot table list. Now we can use this. It has already taken it under values. Now let's say I want to find the sum of sales for each item under each category. You can see it here. We have our category fruit and we have our category vegetable, and under that we have different items like apple, apricot, banana. Similarly, in vegetables we have broccoli, the carrots, corn, eggplant, and others. So this is how you can create a calculated field in a pivot table. Now there's one more good feature that Excel offers us in pivot table is to create a pivot chart. So you can use your pivot table and create different charts. So I'll show you how to do that. If I go to insert, here I have the option of recommended charts. If I click on this, Excel gives me some default charts which you can use. Let's say I'll select this. Let me drag it a bit to the right. Here you can see I'll close this pivot field list. This is a nice bar chart that Excel has created. This is called a pivot chart. Now here you can see the category fruits and vegetables and the different fruits and vegetables or the items. In the y-axis you can see the total sales. If you see from the graph, guava made the highest amount of sales. Now if I sort this, let's sort this first. You can see it here, fruit guava made the highest amount of sales. Now since I sorted and changed my pivot table, the pivot chart also automatically gets updated. Similarly, there are other charts also that you can create. Let's go to the insert tab and let's click on recommended charts again. Let's look for a pie chart. So this is a pie chart that you can create. Let me click on OK. So here is our pie chart, and each pie represents a certain item, and the pie that has the highest area represents it had the highest amount of sales. In this case you can see it is guava, and similarly we have other items as well. This is fruit banana, that's corn, and we have spinach and others. Let's explore a few other charts. So first I'll click on my pivot table, go to insert, and under recommended charts let's now select a line chart. If I hit OK, move it to the right. So this is a line chart. You can see it starts from guava, which had the highest amount of sales, then it drops, and in the x-axis you can see the different items. Similarly, when it starts with the vegetables, broccoli made the highest amount of sales with 2,800 rupees, and our lowest was eggplant at 900 rupees. For fruits, papaya sold the least at 700 rupees. Let's take another chart. I'll go to insert. Under recommended charts, let's see, this time we'll see a bar chart. Now this is a horizontal bar chart and not a vertical one. We just saw a vertical column chart like this. This is an horizontal bar chart. Now you can always increase and decrease the size of these charts. Let's explore a last chart. Let's take the area chart for now. So this is an area chart. Again, it looks similar to the line chart. It starts with guava, which had the highest amount of sales. Similarly, papaya under fruits had the lowest amount of sales. Under vegetables it was broccoli, And finally, eggplant made the lowest amount of sales under vegetable. Now let's go to our first sheet and summarize what we have done in this demo for pivot tables in Excel. So we had our data. This is 2011 census data from India. We had the different cities, the state names, and we had the total population, total literates, female literates, male literates. We had the sex ratio, total graduates, and other information. So we began by understanding how to create a simple pivot table where we calculated the total population for each state and sorted it in descending order. We found that Maharashtra, Uttar Pradesh had the total population in 2011. Then we saw another pivot table where we calculated the total sum of literates in each city belonging to a certain state. So you can see we had the different state names and the cities under each state. Then we saw another feature where you could calculate the average of a certain numerical column. So here we calculated the average sex ratio and the child sex ratio for each state and found out which one had the highest and lowest sex ratio. After that, we saw how you could find or filter tables. We saw how to find the top 3 cities with the highest number of female graduates. We found out that Delhi, Greater Mumbai and Bangalore were the top cities with highest number of female graduates. Next, we saw how to use slicer in a pivot table. So we sliced our table based on Rajasthan and Karnataka state and saw the total population for all the cities in Rajasthan and Karnataka. In the next sheet, we explored another feature that was to find the percentage contribution of male and female literates from each state. Then here we saw how to find out the bottom 3 cities for each state having lowest female graduates. Now one thing marked that some of the states did not have 3 cities. For example, Andaman had only 1 city, that was Port Blair, but the others we found out the bottom 3 cities that had the lowest female graduates. Finally, we looked at how to create a calculated field in a pivot table. So we saw how to create a calculated field called sales, and then we explored how to create different charts and graphs. So this was an area chart that we saw. There's a column chart. We also saw or looked at a bar chart, that was a horizontal bar chart. Similarly, we saw how to create a pie chart as well.
In this video, we'll be creating 2 dashboards using a sample sales dataset. So if you want to get the data and the dashboard file that we'll be creating in this demo, then please put your email IDs in the comment section of the video. Our team will share the files via email. Now, let's begin by understanding what is a dashboard in Excel. A dashboard is a visual interface that provides an overview of key measures relevant to a particular objective with the help of charts and graphs. Dashboard reports allow managers to get a high-level overview of the business and help them make quick decisions. There are different types of dashboards such as strategic dashboards, analytical dashboards, and operational dashboards. An advantage of dashboards is the quick detection of outliers and correlations. With comprehensive data visualization, it is time-saving as compared to running multiple reports. With this understanding, let's jump into our demo. For creating our dashboards, we'll be using a sample sales dataset. Let me show you the dataset first. So here is the sales dataset that we'll be using for our demo. So this dataset was actually generated using a simulator and is completely random. It was not validated, though we have applied certain transformations to the data using Power Query features. So this data, as you can see, has 1000 rows. So using the simulator, we had generated 1000 rows of data. Similarly, if I go on top, you can see this dataset has 17 columns. Now let me give you a brief about each of the columns. So first we have the region column. So we have Middle East and North Africa, there's North America, Asia, Sub-Saharan Africa, and others. Similarly, we have the country names from which the item was ordered. The third column is the item type. So we have different items: cosmetics, vegetables, there's baby food, cereal, fruits, etc. Then we have the representative's name, or you can say this as the customer name who ordered the product. Then we have a sales channel column. So there are basically two channels, whether the item was sold offline or online. Next we have the order priority column. Now here C stands for critical. Then we have H, which is for high priority orders. Then we have M for medium priority orders, and finally we have L, which is for low priority orders. You can see the order date column. Then we have the order ID, the ship date. Next we have units sold, which is basically the total number of units sold for each item. Then we have the unit price column. This is the price at which each product was sold. Then we have the unit cost column, which is basically the production cost for each of the items. Next we have the total revenue. The total revenue is actually the product of units sold and unit price. Then we have the total cost column. Now the total cost column is actually the product of units sold and the unit cost. Similarly, we have the total profit column. So total profit is the difference between total revenue and the total cost. And finally, we have created two more columns, that is order year and then we have order month. Now these two columns were actually generated using the Power Query features. So we used the order date column, which is this column, and extracted order year and order month. So first, we are going to create a revenue dashboard where we'll focus on generating reports for revenue by order year, revenue by year and region, revenue by order priority, and much more. We'll create separate pivot tables and pivot charts and format them to make them look more interesting and presentable. We'll add slices and timeline to our dashboards in order to filter it based on specific fields. Now let's create our first report to see the total revenue generated each year. So we need to create a pivot table for this. I'll click on a cell in my dataset and then I'll go to the Insert tab. Here we have the option to select the pivot table. I click on this. You can see my table range is selected. Next, I want to place my pivot table in a new worksheet, and let's just click on OK. There you go. So we have a new sheet where I can place my pivot table. So first, I need to find the total revenue generated by each year. So what I'll do is, I'll drag my order year column under rows, and then I'll select the total revenue column under values. You can see I have my pivot chart ready. Now if you want, you can sort this. So from the data, you can see we have order year from 2010 to 2017. Now based on this data, let's create our pivot chart. So I'll click on any cell, go to Insert, and here you have the option to select recommended charts. I click on this. Now actually I want a line chart, so I'll click on line here and select OK. There you go. So we have successfully created our first pivot chart. Now let me show you how you can format this chart to make it more readable. So first, let me delete these. So I'll right click and select hide all field buttons on the chart. So this will delete the buttons present on the chart. Now let me go ahead and edit the chart title. So the title I want is total revenue. I'll type it down by year. Alright. Next, let's do a few more transformations. So if I click on this plus sign, which is actually for chart elements, we have some options like to add axis, axis titles, chart title, data labels, this grid lines, legend, and others. Okay, so let's remove the legend now. You can see the total legend is gone. Now let me add axis titles. So we'll label our x-axis and y-axis. So here under x-axis I can write it as year. Similarly on the y-axis I'll put revenue. Okay, now you can move a bit. Alright, now let me select this chart style option and go to colors first. here I'll select yellow color. Okay, and then let me go back to style. Let's select a new style from this list. I want this style. Okay, now you can also add data labels. So I'll just click on data labels. You can see we have the revenue for each of the years. Now this is not readable at all, so we'll format this a bit. If I click on this arrow, here I have more options. If I scroll down, you can see we have something called as number here. I'll expand this, and under category I'll select custom. Now here we'll give a format code which is a bit different. So this is actually a kind of a formula. So I'll write if my revenue value is greater than, let's say, 9,99,000. Let me make sure there are 6 nines here. So 1, 2, 3, 4, 5 and 6. Okay, we are good to go. I'll close the bracket. I'll give a hash, give 2 commas. So if the revenue is greater than 9,99,000, I'll put it in the format of millions. So within double quotes I'll write M. I'll give a semicolon followed by another hash, and if the value is less than the desired number, it should be 0 million. Let me click on add. Alright, you can see how nicely we have formatted our data, and you see here we have added the new format which is in millions. Alright, now if you want, you can go ahead and adjust the boxes. Let me move this a bit up. I'll delete this. Now if you notice this line chart, you can make a few conclusions. For example, if you see here in 2010, the total revenue generated was nearly 175 million. Now this came down to 150 million in 2011. Then the revenue constantly grew from 2011 till 2014. It reached 195 million. And after 2014, it again came down to 180 million, and the revenue dropped significantly between 2016 and 2017. In 2017, the revenue was just 96 million. Now before moving ahead to my next chart, let me just rename this sheet. So I'll write it as revenue by year. Alright. Now let's analyze the revenue generated each year in different regions. So for this, we'll create another pivot table. Let me close this. I'll click on any cell, go to insert and select pivot table. I'll just click OK so that my pivot table is placed on a new sheet. Alright. Now this time we want the revenue by each year and region. So first of all, let's drag region to columns. Then let's drag the order year column under rows, and then I'll select total revenue onto values. So here you can see we have the pivot table ready. So for 2010, you can see in Asia, this was the revenue generated. Similarly, if you see for 2013, this was the total revenue generated in Europe, and we have for other years as well. Now let's create a line chart based on this pivot table. So I'll select any cell in the pivot table. I'll go to insert and I'll click on recommended charts. From this list, I'll select my line chart and click on OK. There you go. So we have our next pivot chart ready. So on the right, you see the different regions that are present in different colors. Let me just expand it so that you can see all the regions we have. So in total, we have 7 regions, and each of the regions have been represented in different colors. So if you notice this graph, for the sub-Saharan African region in 2012, sub-Saharan Africa made the highest amount of sales. Now from the sample data you can also tell that the revenue for North America has been significantly low compared to other regions. Similarly, if you see for Europe, this was the revenue trend between 2010 and 2017. So if you see here in 2011, the sales were at this level, then it significantly dropped in 2012, then in 2013 there was a huge spike, and then again came down in 2015, and so on. So you can make your own conclusions by looking at these line charts. Now let's format this chart. So first of all, let's delete the field buttons present on the chart, and we'll also delete the legend. Alright, now let me just reduce the size of the chart. Next, we'll add a chart title. So we'll give the title as revenue by year and region. Okay. You can also format the y-axis in terms of millions. So I'll right click on this axis and I'll select format axis. I'll scroll down and here we have the number drop down. Let me scroll again. Under category I'll select custom and we'll use this format that we created for our previous chart. There you go. You can see our axis labels have been changed in terms of millions now. So let's close this and let me save it. Now you can reduce the font size or increase the font size. Let me just show you. Suppose you want to increase the font size of the chart title, so you just select it and from here you can either reduce or you can increase. You can see now it's 12. If you want, you can make it 16. Similarly, you can also edit the axis labels also. By selecting the chart title, you can also move it to left or right, or you can place it in the center as well. For the time being, let me just keep it to the left. Alright. Now we'll see the revenue and total cost by each region, and we'll create a combo chart for this. So let me show you how to do it. I'll go to my data sheet. I have my cell selected. I'll go to insert and click on pivot table. Let me just click on OK. Alright. So for this, I'll select my region onto rows, and then I'll have two columns under values. The first one is going to be total revenue, and the next column will be the total cost column. Alright. So here we have the pivot table ready. Now based on this pivot table, let's create our pivot chart. So I'll go to recommended charts, and if you see below at the bottom we have combo chart. So this is the preview of the combo chart. Alright. Now let me just click on OK. There you go. So we have a nice combo chart ready here. Now the way to look at it is, the bars represent the total revenue, which is this column. Now the line represents the total cost. So let me go ahead and edit this chart a bit. So first of all, let's delete the field buttons. Alright. And let's also remove the legend from here. Next, we'll add data labels. So I'll click on data labels here. Okay. So these are the data labels for the bars or the revenue column. Now let's format the data labels in terms of millions. So I'll click on this arrow, go to more options. If I scroll down, I have number. From here I'll select custom and I'll choose my type, that is in millions. Alright, so you can see we have formatted our data. Next thing, we'll add a chart title. So here I'll write as revenue by region. It's actually revenue and total cost by region. Before moving ahead, let me rename the sheets as well. I'll write revenue and total cost. Similarly, sheet 3 also I'm going to rename it as revenue by year and region. So this makes your sheet more readable. Alright, now moving ahead, next we are interested to get the revenue generated by order priority, and for this we are going to create a pie chart. So let's go to the data sheet and create our pivot table first. I click on OK. Now I'll select order priority under rows, and under values I'll select total revenue. So this is a very simple pivot table. So you have your order priority. So C is for critical, H is for high, L is for low, and M is for medium. Now based on this, let's create a pie chart. So I'll go to recommended charts, and here you have pie chart. I want to select this 3D type of pie chart, and I'll click on OK. Alright, so we have our pie chart ready. Let me just resize it, and from here I'll remove the field buttons, and I also don't need the legend, so I'll delete this as well. Alright, now let's give a chart title. So this is going to be revenue by order priority. Now let's add our data labels. I'll check this option. Okay, now let's again format this in terms of millions. So here I'll click on the last option, I'll go to numbers. Under category I'll select custom, and my type is going to be in terms of millions. There you go. Let me close this. I'll just move this to the center. Alright. Now if you want, you can change the color of the text as well. So let's have it in white color and see how it looks. Okay, so this looks pretty decent. Cool. Now moving to our next report. So this time we are going to find the total revenue by countries. So we have multiple countries present in our data set. We want to visualize the revenue generated in each country. So for this we are going to create a horizontal bar chart. So let me show you how to do it. But before moving ahead, let me just rename this sheet. So I'll write revenue by, I'll just put OP, which stands for order priority. Alright, now let's create our horizontal bar chart. I'll go to insert, click on pivot table and select OK. So I want my revenue based on different countries, so I'll select country and put it under rows, and then I'll choose total revenue and place it under values. So here you have the different country names. We have Afghanistan, there's Albania. Let me scroll down. You have Bangladesh. There are a number of countries. You have Czech Republic, there's Estonia, France, Gabon. Similarly, if you scroll down, we have India, there's Jamaica, Italy, and all the way to the bottom if you go, we have New Zealand, there's Netherlands, Philippines, Portugal. We also have Singapore, lots and lots of countries. We have the UAE, United States of America, Zimbabwe, and others. Alright, let me go up. So based on this pivot table, let's create our pivot chart. So I'll go to insert and select recommended charts. From here I'm going to select the column chart. You can see the preview here, and let me click on OK. Alright, so here you can see the different country names at the bottom and the revenue for each of the countries. Let's go ahead and edit this chart. So first of all, I'll delete the field buttons. Okay, and let me also remove the legend. Here I'll write revenue by countries. This is going to be my chart title. Okay, let's format this chart a little more. So I'll click on this option and we'll select a new style. Let's say I'll select style 6. Okay, and let me now go under colors and we'll select the color of the bars. So let's choose this color. Okay, so you have a horizontal column chart ready, and at the bottom you can see the different country names and we have the revenue. Cool. Now let me go ahead and rename this sheet. So I'll write revenue by countries and hit enter. Okay, and finally we'll create another report which is going to be part of our revenue dashboard, and this is revenue by items. So we'll visualize our revenue for different items present in the table. So if you see this, we have cosmetics, vegetables, cereal, fruits, there's clothes, snacks, households and other products as well. So let's check the revenue for each of these items. So we'll continue the same drill. I'll create my pivot table on a new worksheet, and this time I'm going to drag item type under rows and we'll have the total revenue under values. So here on the left of the table you can see we have the different item names and then we have the total revenue. So let me just sort this total revenue from largest to smallest. So you can see here office supplies made the highest amount of revenue, followed by household, then cosmetics, and fruits made the lowest amount of revenue. I'll click on this, go to insert and select recommended charts. This time I'm going to create a bar chart. So this is how my bar chart is going to look like. I'll select OK. Alright, now let's format this chart a bit. I'll delete the field buttons and I'll delete the legend as well. And let's edit the chart title. So this is going to be revenue by items. Cool. We also want to change the color of the bars. So I've selected all the bars. I'll go to my home tab and here let's say I want to select green color. Alright, I've edited my chart a bit. Now let's make it 14 and I'll remove the bold. Okay, here if you want you can change the font also. Let's keep it in blue color. Alright, finally let's rename this sheet. So I'll write revenue by items. Cool. Finally, now it's time for us to merge all the charts that we have created to our dashboard. So let me show you how you can create the dashboard. I'll create a new sheet, and first thing I'm going to do is I'll click on the view tab and uncheck grid lines. So this will remove the grid lines present in the worksheet. Next, I'm going to insert an image. So we'll have a background image on our dashboard. So the way to do is I'll go to the Insert tab, and under Illustrations I have the option to select Pictures or Insert Pictures. So I'm going to insert picture present on the device, that is my computer. I'll go to Desktop, and here I have a folder called Excel Dashboard Files, and I'll select this dashboard background and hit Insert. So this is going to insert an image. Now let me just drag this image so it covers a fair enough portion. So I'll hit Shift and I'll drag it. Alright. So you can see I have successfully added a background image. If you want, you can still expand this background image a bit to the right. Cool. Now the next thing is going to be the title of the dashboard. So I'll click on Insert, and here I have the option to select a text box. So I'll click on a text box, and I'm going to place a text box in the middle, and I'm going to name this text box as Excel Revenue Dashboard. On sales. I'll centerline it. Let's do some more formatting. So I'll select this text box. On the top you can see shape format. Here I'm going to expand this shape fill, and I'll select no fill. So my text box is transparent now, and I'll also remove the outline. Alright. Now let me just double click on the title of my dashboard, and I'm going to select a font. You can select whichever font you want. Let me stick to Britannica Bold, and I'll increase the size to, let's say, 30. Alright, I'll just drag the text box. I'll make the text as white instead of black. Alright, so we have our title of the dashboard ready. Now if you want, you can also insert some icons to this dashboard. So I'll go to Insert, and I'll click on Illustrations again and select Pictures. I'm going to add this two pictures, which is of a store and a cart, to make it look visually appealing. So I'll place the icons here, and similarly let me just copy it, and I'll place the cart and the store to the right as well. Alright. Next, the idea is to bring in all the charts that we have created and place it on the dashboard. So let me copy each of the charts and place it on the dashboard. So I'll hit Ctrl V to paste it, and we'll resize this as well. Alright. Similarly, let me bring in all the other charts as well. Alright, so now you can see I have added all my charts and graphs to this dashboard. So you can see here we have our line charts, our column charts, the combo charts, the pie chart, and others. Now let me go ahead and format these charts a little more. So you can see this looks a bit cluttered. So let's adjust the labels. Let me bring this down. Similarly, I'll bring 190 million a little below. Alright, this looks fine now. One more thing we are going to do is we'll remove the white background from each of the charts and make it transparent. So let me show you how to do it. So I'll select this chart, then I'll right click and go to Format Chart area. Here on the right you see we have an option called No Fill. So if I select No Fill, you can see the white background is gone now. Similarly, let me also remove the grid lines. So I'll select the grid lines and hit delete. So I've also removed the grid lines from here. Now let's also remove the white outline that we have. So I'll select this chart, go to Format, and here I'll go to Shape Outline and I'll select No Outline. You see this? So we have our total revenue by year, which is a line chart, and this is completely transparent now. Now what I'm going to do is I'll place this chart over a box. So I'll go to Insert, and in Insert we have the option to create a shape. So I'll click on Illustrations, and here I'll choose a shape, and let me select a rectangle. So I'll just create a rectangle here. Alright, and now what I'll do is I'll select this and bring this to front. I'll right click and choose Bring to Front, and I'll place this shape below it. Alright, now the next thing is to edit the shape. So first I'll change the color of this box. So let me select this blue color, and let me increase the transparency. So I'll right click and go to Format Shape. Here I'll increase the transparency. Let's keep it to 25%, or let's say 20%. Alright, next thing, we'll just convert all the font to white color, including the axis labels, the chart title. We'll also convert all the axis labels to white color so it looks better. Now we'll just adjust our chart over here. Next thing, let's just remove the outline. So I'll go to Shape Outline and I'll select No Outline. You see, we have now formatted our chart. Let's just pull this a little up. Alright, now we'll add this blue background to all the other charts. So we'll first add the background, make it transparent, and then we'll convert the font text to white color to make it more readable and visible. So for the time being, I'll just pause the video and come back again. Alright, so now you can see on your screens we have nicely formatted our dashboard. So I've added a few logos for each of the charts. You can see the logos here. So for revenue by countries, we have a globe. Then if you see here, this is kind of a map or a location. Similarly, we have all formatted the color of the bars. Then we have also formatted the labels in terms of millions. If you look on the y-axis, even the revenue for year and region are all formatted in terms of millions. If you want this, you can also format the total year by revenue in terms of millions. So the way to do is, you can select this graph, right click and go to Format Axis. Here if I scroll down, you have numbers, and under category I'll select custom. Then I'll select my type as this format, which is in millions, and you see here we have successfully formatted our y-axis labels. Alright, so the next thing is to add slicers and timelines to our dashboard. Now slicers are used to format your data based on a particular column. Suppose if you want to see revenue by certain items, you can add item as a slicer and you can view the entire dashboard. Similarly, for timelines you can add date columns. So if you want to see what was the amount of sales or revenue generated on a particular year or a particular month, you can do that using a timeline. So I'll select one of the charts, and then either you can go to the Insert tab, and here you can see under Filters we have Slices and Timeline, or if you go to the Pivot Chart Analyze tab, here also you have Insert Slicer and Timeline option. So I'll select Insert Slicer here first. Now it's giving me the list of fields present in the dataset. So I'll select country, region, and let's say we want to know by item type and sales channel. So these are going to be my 4 slicers. I'll click on OK. You can see it here. We have our 4 slicers here, and these are the list of values. Under region we have Asia, this Europe, North America, and others. Similarly, we have the different country names for country slicers, and then for item type also we have all the items that were present in our dataset. Now moving ahead, we need to connect all the slicers to a dashboard. So what I'll do is I'll right click on this option and I'll go to report connections. Okay, so under report connections you have all the pivot tables that we created. You currently see only one of the pivot table is selected, so we need to select all the pivot tables. So let me check all the pivot tables present in this workbook and click on OK. Alright, now that we have connected one of our slicers, we'll now connect the other remaining slicers. So I'll right click on this, go to report connections, and I'll check all the pivot tables present in this worksheet. Click on OK. Similarly, let's do it for the country slicer. I'll go to report connections and let me select all the pivot tables. And finally, we have the item type. So I'll right click, go to report connections, and then I'll select all my pivot tables. And let's hit OK. Alright, now let me just organize this a bit. So I'll place my pivot tables to the right. I'll just reduce the size. Let me scroll down. Now I'll add my region slicer here. Similarly, I'll add my final slicer, that is sales channel. Now in our next dashboard, which is going to be the profit dashboard, I'll show you how to add a timeline. Alright, now I have arranged all my slicers. So let's say you want to find the revenue that was generated for an item type, let's say beverages. So you can just select beverages here, and all your charts show the respective revenues. So you have the total revenue by year for beverages only. Similarly, here you can see the revenue by year and region only for beverages item type. If I scroll down, now this chart represents the revenue that was generated in each of the countries only for item type beverages. Let me just uncheck it. Alright, let's say you want to see the revenue generated for a country like India. So I have selected India here, and now you can see my graph has changed only for country India. You can see here it is showing only for India now. Now similarly, you can also filter your revenues based on the different regions. Let's say you want to know the revenue generated based on sales channel. So we have 2 sales channels, that is offline and online. Suppose you want to know the revenue generated offline. So I'll just select offline. You can see the values have changed. So these were the revenues generated for each of the items only for offline. If you see here, now these were all the offline sales for the different regions. So this is our entire Excel revenue dashboard on sales. We created multiple charts and graphs. Then we applied different formatting. We added different icons. Then we formatted the labels also. Next, we added slicers, and finally we saw how we could filter our data based on these slicers. Likewise, now we are going to create a profit dashboard based on the same data. So before moving ahead, let me rename this sheet as revenue dashboard. I'll write REV dashboard. Okay. Now we'll move to our data sheet and start creating our pivot tables and pivot charts for the profit dashboard. Alright, so let me go ahead and create my first pivot table. So I'll create a new worksheet. This time I'm going to create a line chart to visualize the profit for each year. So I'll drag my total profit column to values and my order year to rows. So here you can see we have our pivot table ready. Now you can sort this data to get an idea as to which year had the highest profit and which year had the lowest profit. So from this pivot table you can see, since I've sorted this data in descending order, so 2014 had the maximum amount of profit and 2017 had the least amount of profit. I'll just do Ctrl Z to undo it. Alright, now based on this pivot table, let me go ahead and create my pivot chart. So I'll go to recommended charts and click on a line chart. So this is the preview of the chart. I'll click on OK. Let me close this. Similarly, we are going to edit this chart now. So first I'll hide all the field buttons present on the chart, and I'll rename the chart title as Total Profit by Year. Next, I'm going to remove the legend, so I'll delete this. Let's do some more formatting. So I'll go to Style, and this time I'm going to select my style type. Okay, and if you want, you can choose the colors as well. For the time being, let's have this yellow color. Next, let me add the data labels. So again, if you see here, this is not formatted properly. So let's go ahead and format the data labels. So I'll click on number and I'll select custom here, and the type I'm going to select is in millions, and I'll click on close. So here you can see we have our line chart ready, which shows total profit by year. Let's rename this sheet as profit by year. Alright, now let's move back to our data sheet again. Next, we are going to show the total profit by countries. For this, I'm going to create a map. So let me first create my pivot table. So I'll go to insert and I'll click on pivot table. Let me click on OK. Since I want the country names, so I'll select country under rows, and then I have my total profit under values. The next thing I'm going to do is I'll just rename the row labels as countries, and then I'm going to delete the grand total, which you can see at the bottom. So here we have the grand total. Let me just delete the grand total. So I'm going to select this pivot table, go to the design tab. Here we have subtotals and grand totals. I'll switch off the grand total. Let me just verify it again. I'll scroll down. You see the grand total has gone now. Alright, now we want to create a map out of this. The way to do is I'm going to select my data, copy it, I'll go on top and I'll paste it here. Using this data, I can create my field map now. So I'll go to insert here we have the option to create a filled map. There you go. You can see we have our map ready. I can expand this. Now, as you can see, our map has a color scale which comes from light gray color to dark blue color. So the countries that are in gray, or you can say light blue, have the lowest amount of profit, while the regions or the countries that have been shaded in dark color or dark blue color have highest amount of profit. I will go ahead and delete this scale. Okay. Next, we need to connect this map to the original data source. So what I'll do is I'll right click on this map and I'll go to select data. Here, instead of the previous range, I'll give my new range now. So my new range will be my original pivot table that I had created. I'll go on top and click on OK. So we have our map ready now. Now if you want, you can change the color of the shade. So I'll just go to colors and let's say we'll keep green color. So the countries that are shaded in dark green have the highest amount of profit, while those which are highlighted in light green color are the countries that made least amount of profit. Okay, now moving on. Next, we want to create a pivot table that will show us the profit by year and sales channel. So for this we are going to create another line chart. So I'll go to insert and click on pivot table. So I'll select new worksheet. Here, since I want to know the profit by year, first of all I'll drag my order year column to rows, and then I'll choose my total profit column under values. Next, I'm going to select my sales channel under columns. There you go. So we have our pivot table here. Now based on this pivot table, let me create my pivot chart. So I'll go to recommended charts and I'm going to create a line chart. I close this. You see here, based on this chart, you can tell the profit generated with online sales were actually lower than that of offline. So here the blue line represents offline profit and the orange line represents online profit. If you mark clearly, in year 2012 the online profit was actually higher than the offline profit. So let me go ahead and edit this chart a bit. So we'll delete the field buttons. I'll also delete the legend for now. Let me go ahead and add a chart title. So I'll write profit by year and sales channel. Okay, so this is my second report. Before moving ahead, let me just rename this sheet. So I'll write profit by countries. Similarly, let me rename this sheet as profit by year and let's say SC for sales channel. Okay. Moving ahead, now I want to create a pie chart based on a pivot table that will show the profit by sales channel only. So this is going to be a simple pie chart. So I'll first go to insert, click on pivot table and click on OK. So I'll drag my sales channel under rows and then we'll have the total profit column under values. So this is my simple pivot table. Now let's create our pivot chart, which is going to be a pie chart. Let me explore the other types of pie charts we have. Okay, so I'm going to select a donut chart here. I'll click on OK. Let's edit this chart. I'll remove the field buttons. Let me now remove the legend as well. I'll just resize it. And this is going to be profit by sales channel. Okay. Let's also add data labels. and here again I'm going to format this label. I'll select the category as custom and my type will be in millions. Okay, let me just move this to the left and this to the right. Okay, let's also delete the lines. Cool. Now let me just rename this sheet. So I'll write profit by, let's say SC, which stands for sales channel. Cool. Finally, I'm going to create a report that will show the revenue and profit by items. So I'll go ahead and create my pivot table first. This time I'll choose my total profit under values, and we'll also have the revenue column. So I'll put my revenue at the top. Then I'm going to select item type under rows. So here is my pivot table. Based on this pivot table, let me now create a combo chart. So you can see the preview of the chart. The blue bars represent the total revenue and the orange line represents the total profit. I'll click on OK. Let me close this. First, let's remove the field buttons. Let's also remove the legend here. Then we'll add a chart title. I'll name it as revenue and profit by items. Okay. If you want, you can also go ahead and change the color of the bars. So let me just select one of these colors. Okay. Alright. So we have our 5 reports ready that we are going to use for our profit dashboard. Next, let's create a new sheet and we'll get started with building our dashboard. So I'll click on a new sheet. Let me just rename this as profit dashboard. Alright. We'll continue with the previous drill. So first of all, let's go to the view tab and remove the grid lines. Now we'll insert a background image like we did for our revenue dashboard. So I'll go to insert. Under illustrations, I'll click on pictures and select this device. I'm going to have the same background. I'll click on insert. Alright, so you can see we have a picture of a company, or you can say an organization. Let's just drag this a bit to the right. We'll adjust the size also. Alright. Now let's copy the title of my profit dashboard. So here you can see I have brought my revenue dashboard, and I'll copy the title and the logos that we used for the revenue dashboard. I'll paste it on my new dashboard. Let's just align it in the center. Alright, the next step, let me now go ahead and edit the title. So this is actually going to be Excel profit dashboard instead of revenue. Now we'll copy each of the charts that we just created. For example, the revenue and profit by items, then we had profit by sales channel. All this we are going to copy one by one and put it on the profit dashboard. So let me just copy a few now. I'll paste it here, and later on we can make the adjustment. I'll copy this as well. Similarly, I'll bring the other 3 charts onto my sales dashboard. Okay, so here on my profit dashboard I have added all the charts and have aligned and reshaped it so that it looks good. I have also made some formatting. For example, I have reduced the size of the chart title Now let me go ahead and show you a few more formatting that we also did for the revenue dashboard. First, let's remove the white background from all the charts. So I'll select the first chart, I'll right click and I'll click on Format Chart Area. Here under Fill, I'll select No Fill. Next, I'm going to remove the grid lines, so I'll just delete it. Let me close this. Now we also have a outline, so I'll go to Design, actually Format, and I'll remove the outline. Next, I'm going to add a blue box at the back, like how we did for the revenue dashboard. So let me select a blue box from here and I'm going to paste it here. Okay, now let me just select the chart and I'll bring this to front and I'll move this to the back. Next, I'm going to change the font color all to white so that it's clearly visible and it's more readable. I'll do it for the x-axis as well. Okay, so here I have my first chart ready. The same I'm going to do for the rest of the charts. Okay, so now you can see here I have formatted all my charts. I've also added a blue background. You see here I have also formatted the Y labels in terms of millions, which is actually the profit. Similarly here I have added the data labels. This is for revenue. Some of the charts also have the data legends. So here you can see the blue color represents offline and the red represents online. Similarly here you have the legends. I've also formatted the map as well. Okay, now the next thing is to make this dashboard more interactive. So we'll add our slicers as well as timeline. First, let me show you how to add a timeline. So I'll select one of the charts and I'll go to Insert. Under Insert, I have the option to create a timeline. So I'll just click on Timelines. So timeline is actually based on date columns. So since in our dataset we only have two date columns, one is order date and one is ship date. So Excel has only shown us two columns. So I'm going to create my timeline based on order date. So I'll select my order date column and I'll click on OK. You can see here this is called a timeline. I can expand this. Now this timeline is based on months now. If I scroll this timeline, you can see here I have my order year 2010 and I have all the 12 months. Similarly we have for 2011, then we have for 2012 all the way till 2017. Now you can filter this in terms of years, quarters, months or days. Let me just select year now. So I have years from 2010 till 2017. Let me just squeeze this and I'll place it somewhere here on the right. Now let me go ahead and create a few slicers for my profit dashboard. So I have selected one of the charts. Under Insert, I'll click on Slicer. You can see it gives me the list of columns from which I want to create slicers. So I'll create a region. Let me also select country. Let's say I want the representative's name or the customer's name and I'll click on OK. So here I have created three slicers. Let me first resize it and I'll place it on the right. Similarly, I'll place the country column also. Then we have the region slicer. I'll resize this and I'll bring it here. Okay. The next thing we need to do is I have to connect all the slicers and the timeline to the pivot tables for the profit dashboard. So I'm going to click on the multiple select option and go to report connections. Here I'm going to select all the pivot tables that are related to profit. So here I have selected 4 and I need one more, which is pivot table number 10. I click on OK. Similarly, let's create or connect my region filter to all the pivot tables. So I right click, go to report connections. Here I'll choose all my pivot tables which are based on profit. I'll click on OK. Let's do it for the country slicer as well. I click on OK, and similarly I'll connect my timeline as well. I'll go to report connections and I'll select all the pivot tables related to profit. Then I'll click on OK. Let me now go ahead and create another slicer based on sales channel. So I'm selecting one of the pivot charts. I'll go to insert, click on slicer, and I'll select sales channel and hit OK. So I have my sales channel slicer. Now let me connect it to all the respective pivot tables that are based on profit. Click on OK. Now let me just bring it here. Alright. The next thing I want to show is how are we going to use the timeline first. So you see we have all the years here from 2010 till 2017. Now suppose you want to know the profit that was generated in the year 2012. So I'll just click on this range, and now you can see our charts only show information for 2012. So this dot represents there was 51 million profit in the year 2012. Similarly, you can see here the profit by sales channel for 2012. From the map you can see the different countries and the profit each of these countries made in 2012. If I scroll down, you can see the revenue and profit by items. Now if I select another year, let's say 2013, I can just drag this to the right, and now you can see our profit by year and sales channel for offline and online. You can see the map or the line chart for total profit by year. So in 2012 it was 51 million, and then it went up to 54 million in 2013. Similarly, our map has also changed. Now this is a sort of an information that we have. You can click on this and check the information that Excel has prompted. Alright, so this is how you can use a timeline. Now as I said, we checked by years. You can also see it for months and quarters as well. Let me just uncheck it. I'll send it back to the place where it was, and I'll reduce the size. Okay. Now suppose you want to check the profit made by different representatives. You can select them one by one. Let's say Adam Churchill. This is the profit generated by Adam Churchill. Similarly, you can select multiple persons as well. Now suppose you want to see the profit by different countries, so you can use the country slicer. Let me just bring this to the middle, and let's expand our chart a bit. Okay, so here you have the profit by different countries chart. I'll just bring this to the front so that you can see it clearly. Okay, now here suppose you want to see the profit generated in, let's say, United Kingdom. You can select United Kingdom. So this is the map of United Kingdom, and it tells you the total profit that was generated in United Kingdom, and below you can see the revenue and profit for all the items that was sold in United Kingdom. So you had beverages, clothes, household, office supplies. So you can see clearly office supplies item made the highest amount of profit in United Kingdom. Now you can also select multiple countries. Let's say I want to know for France as well. So my map will change accordingly. So now I have United Kingdom and France selected, and the other charts present in my dashboard change accordingly. Now I have my country selected as India. You can see the map of India here, and these were the respective profit values. Now one thing to note here is this is actually not millions, that should be in K, that is thousands, so please mark this as 1000 and not in millions. Even for this is actually K and not million. Alright, so we have successfully created our second dashboard, that is on profit. Let me just resize this a bit and we'll place it where it was earlier. Cool. So we saw how to create different pivot tables and pivot charts, and then we formatted our pivot charts based on our requirement. We saw how to edit the colors. Now let me show you one more thing. You can also change the look and feel of the dashboard by going to the page layout tab. Under page layout you have themes, so here you can select different themes. Currently we are with the office theme. Now let me just select another theme, let's say Facet. You see the colors have changed and it looks really beautiful. Similarly, let me try out another theme, let's say organic. You see our chart has changed. Let me just delete this. Okay, so now once you change the theme, the text also change a bit. You can see the slicers are in a different font. Let me explore one more theme. Let's say this time I'm going to choose depth, and this is more of a green type of color. You can play around and select whatever theme suits the best. Alright. Now let me just move back to my revenue dashboard and see how it looks. There you go. So since we changed our theme, even our revenue dashboard is also impacted. So this is how it looks now. You can always go ahead and play with different themes, colors, fonts and effects. Alright, so in this demo we saw how to create a revenue dashboard. So we created line charts, this combo chart, pie chart, horizontal and vertical bar charts, and then we learned how to add slicers and connect it to different pivot tables, and we filtered our data to see revenue as well as profit by items, by countries, by different regions, sales channel. We learned how to create a map and lots more.
Let's quickly see some more examples of doing data analysis using Excel, and for that we can use some inbuilt add-ins which can be added to our Excel sheet. So for example, if you would want to do a descriptive analytics or descriptive analysis on your data, say for example getting your descriptive statistics such as your mean, median, mode and so on, so we can do that and we can use Excel for it. So for example, you can, if you are given some data, say I have temperature, price of ice cream, units sold, and I would want to have descriptive statistics on this, what I can do is I can click on File, and here in File you can click on Options, and within Options click on Add-ins. Now within Add-ins you have Excel Add-ins which is selected here, so click on say Go for example, and that shows what add-ins are available and you can choose which ones are you interested in. So for example, I have chosen Analysis Tool Pack and Solver Add-in and click on OK. Now that basically should add more options to your Excel. So if you click on Data, so here you see Data Analysis and Solver, and this is what we would want to use to get our descriptive statistics for these three columns. So for example, let's say temperature, or you can even give the names later once you get your descriptive statistics. So for example, let's go for data analysis And here it says, what are you interested in? There is a two-factor with replication. You have correlation, covariance, descriptive statistics. You have histogram. So let's click on descriptive statistics. Click on OK. Now this one basically asks your input range. So while your cursor is blinking here, also it is said grouped by. So let's give it a range. So for example, I will say temperature. Now if I do this and I have selected the heading, just look at that. And now you need an output range. So let's just select this, and then you can have your cursor blinking in here. Let's select, say, fields here, and this is where I would want the output. Now it also said what options do you want. So it has output range. We can then select summary statistics, confidence level. So I will say summary statistics is what I'm interested in. Say OK. And this says input range contains non-numeric data. Now why is that? Because we chose temperature, the heading also. So click on OK, and here we will alter the range. So this one is, our range should be only the values, numeric values on which we would want the descriptive statistics. We have output range already selected. We have summary statistics. And now you can click on OK. And that basically gives your descriptive statistics for temperature. So here I could basically given a value for this. So I can say temperature, and that's my descriptive statistics for temperature. Might be I can just do some formatting, and that's it. So that gives me descriptive statistics for the values here. Now similarly, we can do it for price of ice cream. So what we need is, we need to basically go for data analysis, descriptive statistics, say OK. Now you need to give a range. So here I will change my range to these values. Output range is already selected. Now we are interested in summary statistics. Click on OK. And this says output range will overwrite existing data. Press OK to overwrite data in range. I will say cancel. No, that's not what we want to do. We need to give a new range. So let's select our new range, which is here, and now click on OK. So now we get the values, which is for your price of ice cream. So again, we can basically select this and say price of ice cream, and we got our descriptive statistics for price of ice cream. And like we did earlier, I can select this. I can basically do a merge and center, and that gives me descriptive statistics for price of ice cream. So we could also basically change this. Now I can go into data, and I can go into data analysis, descriptive statistics. So we know that we had selected this B2 to B8, and this one, which is H6 to H19, we would want to shift it, might be 2 columns up. So might be I can just say H5, and I can manually change it to H17, and let's say OK. And we will basically get this, and I can get rid of this. So I can have it in the same range. So similarly, so this one will have to be renamed, and I can basically say price of ice cream, and that's basically my descriptive statistics for my price of ice cream. And similarly, we can do it for the third column, which is units sold. So we would want to have this. Now let's see, we can click on data, we can click on data analysis, descriptive statistics. So we need to give the range correctly. So this time our range changes to units sold. Now we can also say labels in first row, okay, if we were selecting the heading. So let's do it in this way. So in my range, let me empty this. I can basically select this, which we know has non-numeric data in the first row. Say for example, I'll say labels in first row. I'm interested in summary statistics, and this range will now have to be changed from H to basically something like J. So let's say J, and let's select these values. So that should take care of things. And now you see you have your units sold. You did not have to manually rename it, and you have basically got the descriptive statistics. So this is how you can simply perform analysis using data analysis here. You can basically get your descriptive statistics for your columns, and then you can do whatever needed formatting you need to basically make your data look in a good way. Now let's look at one more example of data analysis where we may want to look at the frequency of values or frequency of values occurring in a range of values. So for example, if you have been given temperatures, you have been given some bins where you would want to identify how many values fall into the range of 0 to 20, 20 to 30, 30 to 40, 40 to 50, and the easiest way to do that would be creating histogram. Now histogram is usually used for data analysis where you would want to look at different variables or say features. For example, temperature is one such feature. There might be one more variable or feature such as sale of ice cream, and you would want to see if the increase or decrease in temperature affects the increase or decrease in sale of ice cream. Might be sale of ice cream is a response based on temperature. So it depends. So sometimes you may want to find a relationship between two variables, whether they are positively or negatively related, or you would want to do different kind of analysis. And in certain cases we may want to first do analysis on one single variable, look at the frequency of values, might be also look at the defects, and for which we can use something like Pareto chart. So we can go for histogram, and that basically gives us the frequency of values. Now how do we do that? So we have already added the add-in, which is data analysis earlier. So we can just use the same thing again. Here we would want to create a histogram. So let's say okay. Now I have already selected input range. So if you see here, my input range is temperature, which is also with the headings, and I have bin range, which is basically the range of values. So for example, I can select this, and that's my bin range. I am selecting or the option labels because I'm using the first row which has the heading such as temperature and bins. Now we need to give an output range. So for example, let's say I would want my data here, and that becomes my output range. So you can have a sorted histogram or basically a Pareto chart. So if that's what you're interested in, looking at the frequencies for your different ranges. And here I'm also selecting chart output because I would want to have a visual histogram which gives us the frequency. And it's as simple as this. Just click on OK, and now you get your bins. So it basically tells you frequency of values, which is basically 20, but that does not mean it is only talking about the values 20. It is basically talking as a range of 0 to 20. So we have 0 to 20, that is 2. So we can basically say there is 120 here, with the 20 being the maximum value, and then there is one more 20. So that's your 0 to 20. Then you have 20 to 30, which shows 3 values. So might be in that case I can say 26 is one thing. Then I can say 30, that's the second one. And then basically I can look at 22. So basically this one does not select 20 as the lower range, but it basically selects 30 as the higher range. So I do see 20 to 30, there are 3 entries. Similarly, we can see values for 40 and 50. And since we have selected Pareto or sorted histogram, that shows in a descending order what is the highest frequency of values within a particular range. So that shows me highest frequency is 5, and then you have 3 and 3 and then 2. So this is how we can create a histogram and we can perform analysis on a single variable. Now, as discussed earlier, as I said, sometimes we may be interested in finding out the correlation between different variables, such as, say, here we have temperature, price of ice cream, and units sold, and we may want to find out the correlation between one variable to another variable, or we would want to find out the relationship between variables. Are they linearly related? Are they positively related, negatively related, and so on? And for that, we can use the correlation of your data analysis add-in. So for example, you want to find out correlation of temperature and units sold. And what we can do is we can find out that using a formula. So for example, if I search for something like correlation, and let's search. So there is a function called correlation which we can use, and we can use this to calculate the correlation of temperature and units sold. So for example, let's select this, and that's the function. So it says give me an first array and a second array. So we are interested in finding out correlation of temperature and units sold. So let's select the range of values for temperature, and then I'm interested in finding out the correlation of temperature in units sold. So let's select this, and that basically gives me a range of values. It gives me the correlation value, which is 0.2859. Say OK, and that's your value. So similarly, we can do it for temperature and price ice cream. So let's go for correlation. So that's the function we are interested in. You need to give a range of values. So here we are interested in temperature and price of ice cream. So let's select temperature. And then the second array or list of values is price of ice cream. Let's select that. Let's close our bracket. And here we have the correlation value of temperature and the price of ice cream. Similarly, you may be interested in finding out temperature and units sold, like what we have done earlier. So we can do the same thing based on function. So this is same as correlation of temperature and units sold. So I can get rid of this one. Now, how do I do it using the data analysis add-in? So for that, what we need is we need to go into data. We need to go click on data analysis, and here you have the option called correlation. Let's select this. Now that basically needs an input range. So we need the range. Now I might be interested in finding out the correlation between temperature and price of ice cream and units sold. So I've selected all the columns here. We will say group by columns. Obviously we need to select labels in first row, because that is basically taking care of the first row as heading. Now output range, you can just give one simple cell, and that's where your data will start from, or you can give a new workbook. So click on OK, and that basically gives your correlation of your different variables and what are the values. And we can check these values based on the values what we have here. So we have basically temperature and price of ice cream, and that basically shows me 0.96149. You have temperature and units sold, so you have 0.2859. Now you can also look at units sold and say, for example, price of ice cream. You can look at these particular values. So if I would be interested in finding out what is the relationship between these variables, I can easily find using correlation. So I could be basically writing in a formula here and selecting what are the cells. So here we were selecting A2 and C. Here we were selecting A and B. Now might be I'm interested in price of ice cream and units sold, and if that's what I'm interested in, then I will give a range of B2 to B8, C2 to C8, and similarly you can get your analysis or correlation values. So it's very simple in Excel, and you can use either the data analysis tab and get your correlation, or you can use formulas and do that. Now, one more important part of data analysis is doing your sampling. Now, sampling could be periodic sampling or random sampling. So sometimes you may want to look at a variable and you may want to get some values based on periodic data. That means might be I'm interested in range of values. I'm interested in seeing a sample of values for a particular period, which could be basically a range of values, or you could just do a random sampling. So for example, if I go for periodic sampling, so out of these values which I see here, might be I want to see, say, periodic sampling, that is a frequency of 2 values, how many times we have these values occurring here. Or I would go for random sampling. So basically randomly I would want to pick up, say, 3 temperature values. Now how do I do it? So for example, here I have 7 values. Now if I go for periodic sampling, the sample or periodic sample value which I need to give has to be lesser than the total input values. So for example, we can do this. Let's go in here and let's go for data analysis. So we can go for sampling here, click on OK, and that needs a range of values. So we will select A2 to A8. Now I could have selected all the values for this one, temperature, and in that case I can give labels, which is going to take care of the first row. Now here we can go for number of samples which we are interested in, or giving a period. So let's go for period and say, for example, I have 7 values. So what if I select 5? So for example, if I say 5, that means I could just get 1 value. So basically when I'm saying 5 out of 7, so that's just giving me out of 5, I want 1 value. So I can then just give an output range. So here I can basically select this cell. I'll say OK. And now you see it just shows me 1 value. So out of the first range, that is, I've said 5, it has given me the 5th value. That's your periodic sampling. So for example, we want more values. So let's reduce this period to might be 2, which basically gives me every second value. So I can basically say, for example, 2 and say OK, and then say OK. So that shows me 26, then you have 35, then you have 40, and then, well, this one does not have any more values. So that's your periodic sampling. Now if you go for random sampling, that's basically randomly picking up values, and you can choose how many values you want. So go for data analysis, go for sampling. I'll go for number of samples, how many you want. So for example, out of 7 values, randomly I want 3 values, and I can just give this, say OK, and then we will do a cancel because we need to change the range. So let's select this and say OK, and that gives me random 3 values from this values of temperature. So we can use Excel to do a simple sampling, and we can choose whether we would want to go for P.
Hello everyone, and welcome to this interesting video tutorial by Simplilearn. Today we are going to perform 2 hands-on projects on COVID data analysis using Python and Tableau. This is going to be a really interesting and fun session where I'll be asking you a few generic quiz questions related to coronavirus. Please make sure to answer them in the comment section of the video. We'll be happy to hear from you. COVID or coronavirus is an ongoing global pandemic of coronavirus disease that emerged in 2019 and was first identified in Wuhan, China. It is defined as an illness caused by a novel coronavirus called Severe Acute Respiratory Syndrome Coronavirus 2, commonly known as SARS-CoV-2. On March 11, 2020, the WHO declared COVID-19 a global health emergency. The virus has so far infected over 22 crore people and killed more than 4.5 million innocents. In India, there have been over 3.3 crore confirmed cases and nearly 4,41,000 deaths have been reported so far. This data is according to official figures released by the Union Ministry of Health and Family Welfare. As the world tries to cope up with this deadly virus, We request all our viewers and their family members to follow all the necessary precautions to avoid getting infected. Quiz time. Now let's see our first quiz in this project. What does corona in coronavirus mean? Here are the options. Is it A. beer, B. respiratory, is it C. crown, or is it D. sun? This is a very generic question. I'm sure a lot of you may already know, some of you may not. Please let us know your answers in the comment section of the video. We'll be glad to hear from you. Now in this video, we will use 3 different COVID-19 datasets and perform data analysis using Python and Tableau. The project will give you hands-on experience working on real-world datasets and how you can use the different Python libraries to analyze and visualize data and draw conclusions. You will learn how to create different plots in Tableau and then make a dashboard from the visuals. The project will give you an idea about the impact of coronavirus globally in terms of confirmed cases, deaths reported, the number of recoveries, as well as active cases. We will also see how India has been affected since the pandemic started and dive into the different states and union territories to learn more about the COVID-19 influence and the vaccination status. First, let me show you the 2 datasets that we'll be using. So for our first project using Python, we'll be using the first 2 datasets, COVID-19 India and COVID vaccine statewise. Let me open the 2 datasets. Okay, so this is the first dataset. You can see here we have the date, we have the time, then we have the different state names. If I scroll down, you can see we have Kerala, Tamil Nadu, Delhi, Haryana, Rajasthan, Ladakh, Punjab, Telangana and other states. Then we have something called as confirmed Indian national. So actually this 2 datasets, confirmed Indian national and confirmed foreign national, we won't be using. So in the demo itself, we'll be dropping these 2 columns. What we are concerned about are the last 3 columns, the cured cases or the recoveries, the number of deaths reported, and then we have the total number of confirmed cases. Let me just sort the B column, that is the date column, so that you have an idea about the recent data we have. I'll continue with the current selection and sort it. You can see here, this is till 11th of August 2021. So this data was collected from Kaggle. It has some discrepancies that we will see in the demo. The data is available for free. We will provide the link to the datasets in the description of the video, so please go ahead and download them. The visualizations and results that you will see in the demo are based on the datasets that we'll be using. We haven't pre-processed the data to remove outliers or any missing values. Now before I jump into the demo, let me show you the second dataset that we are going to use. Okay, so COVID vaccine state-wise is my second dataset. Let me open it. There you go. So this is the second dataset that we'll be using in the Python project. You can see we have a column called updated on, then we have the state. Again, you can see here there are a few discrepancies here. It has taken the country name and not the state name. Below you can see there are the different state names, and you can also see we have information about the total doses administered. We have the sessions, sites, first dose administered, then we have the second dose, then we have information about male and female doses. You can see here the different vaccines administered, Covaxin and Covishield. You have Sputnik V, and here are the different age groups as well. And finally, if you see, we have male individuals vaccinated, the total number of female individuals vaccinated for a particular day. We have information about transgender individuals vaccinated, and finally we have the total individuals vaccinated each day. Alright, before we jump into the hands-on part, let's have a look at the second quiz in this project. So here is the second quiz question. Which is the first country to start COVID vaccination for toddlers? Is it A. Japan, B. Israel, C. Portugal, or is it D. Cuba? This is a very recent development that took place. If you watch daily news updates on coronavirus, you'll be definitely able to answer the question. Please give it a try and put your answers in the comment section of the video. It is really important for our viewers to know the right answer. Alright, so now let's begin with our demo. So I am on my Jupyter notebook. So the first project we are going to use Python Jupyter notebook. I'll just rename this notebook as COVID Data Analysis Project. I click on rename. Alright, so first and foremost, we need to import all the necessary libraries that we are going to use. So first I'm importing pandas as PD. This is for data manipulation. Then we have numpy as NP. Numpy is used for numerical computation. Then we are importing matplotlib, seaborn and plotly. These three libraries will be used for plotting our data and creating interesting visualizations. Finally, I'm also importing my datetime function. Alright, so I'll hit Shift Enter to run the first cell. Now it's time to load our first data set, which is related to the COVID-19 cases in India for the different states and union territories. So I'll create a variable called COVID_df. df is for data frame. I'll use my pandas library and then give the read_CSV function, since our data sets are CSV files, and inside double quotes I'll pass in the location where my data sets are present. So I'll just copy this location, I'll paste it here. We'll change the backslash to /, and after that I'm going to give my file name followed by the extension of the file. I'll say COVID-19 India.csv. Let's go ahead and run it. Alright, now to see the first few rows of the data frame, I'm going to use the head function. I'll say head, and within brackets, let's say I'll pass in 10, which means I want to see the first 10 rows of data. If I run it, there you go. Here you can see from 0 till 9. So we have 10 rows of information, and these are the different column names. You have S number, date, time, state or union territory. Then you have confirmed Indian national, confirmed foreign national, cured cases, deaths reported, and the confirmed cases. Alright, now moving ahead, let's use the info function to get some idea about a data set. If I run it, you can see here it gives us the total number of columns. We have 9 columns. The total number of entries or the rows, we have 18,110 rows of information starting from 0 till 18,109. You see here the different types of variables or column names that we have. Then it has information about the memory usage as well. And this side you can see the data types. Cool. Now we'll use another very important function, which is to get some idea about statistical analysis, the basic statistics about your data set. For that I'll be using the describe function. Okay, so if you can see here, the describe function is for numerical columns only, and you have the measures such as count, the mean, standard deviation, maximum, minimum, the 25th percentile, 50th percentile, and the 75th percentile value. Okay, now let's move ahead and import the second data set, which is related to vaccination. So I'll create a variable called vaccine_df. I'll write pd.read_csv function, which is present in pandas library. I'll move to the top and I'll copy the file location and we'll change the name of the file. Copy this and let me paste it here. and instead of COVID underscore 19 underscore India, I'm going to say COVID underscore vaccine underscore state-wise. Okay, so this is the dataset that we saw, COVID underscore vaccine underscore state-wise. Alright, let me run it. Cool. And let's display the first 7 rows of information from this data frame. I'll be using the head function, and inside the function I'll pass in 7. There you go. So here you can see we have from 0 till 6. There are total 24 columns. A lot of them have null values, you can see here. Alright. Now, from the first data set, which is the COVID underscore DF data frame, we'll be dropping a few unnecessary columns such as the time column, confirmed Indian national and confirmed foreign national, as well as the S number. We don't need these columns, so it's better to learn how to drop the columns for our analysis. So I'll say COVID underscore DF dot, I'll use the drop function, and within square brackets I'll pass in the column names. The first is S number. I'll give a comma. Within double quotes I'll say the next column is time. My third column that I want to drop is confirmed Indian national. Give another comma. Within double quotes I'll say confirmed foreign national. Outside the square brackets I'll give another comma and pass in my next argument, that is in place equal to, I'll say true. I'll give another comma and say axis equal to 1. Let's run it. Okay, it has thrown an error. Let's debug the error. Says confirmed Indian. Okay, it should be Indian national and not Indian nation. I'll just mention it as national. We'll run it again. Okay, now we have removed these 4 columns. Let me show you the dataset now. There you go. So we have only the date column, state or union territory, cured, deaths and confirmed. Now let's see how you can change the format of the date column. For that you have the function called toDateTime. I'll say COVID underscore DF. I'll pass in my column name, that is date. I'll say equal to PD dot. I'll use the pandas function, that is to underscore date time. I'll say COVID underscore DF, which is my data frame name. Pass in my variable, which is date. Give a comma, and I'll use my argument, that is format equal to, I'll say percentage %y, give a dash, say percentage %m, give another dash and say percentage %d. Let's run it, and I'll print the head of the data frame. Cool. Now moving ahead, now we will see how to find the total number of active cases. So active cases nothing but the total number of confirmed cases minus the sum of cured cases plus deaths reported. So let's find the active cases. I'll give a comment. Okay, I'll first write my data frame name, that is COVID underscore DF. Within square brackets I'll give my new column, which is active underscore cases. I'll say equal to COVID_df, and my first column would be the confirmed cases column minus, I'll say COVID_df, then I'll pass in my cured column plus, I'll again say COVID_df and add my deaths column. This time let's print the last 5 rows from the new data frame that we have created. Okay, let's run it. Okay, it has thrown an error. Let's debug it. Says data frame object has no attribute tails. This should be tail. There you go. You can see here we have added a new column called active cases, which is the confirmed cases minus the sum of cured and deaths reported column. Now we will learn how to create a pivot table using the pandas library. So in this table we'll be summing all the confirmed deaths and cured cases for each of the states and union territories. So we'll be using the pivot_table function for this. I'll create a variable called statewise and say pd dot. I'll use the pivot_table function. I'll pass in my data frame, that is COVID_df, and then I'll give my values parameter. Inside the square brackets I'll pass in my columns confirmed deaths, and then we'll have the cured column. I'll give a comma, and next argument would be index, which is going to be my state slash the union territory column. Let me bring this to the next line so it is more readable. I'll say union territory. I will give a comma now and pass in my last argument, which is agg function, that means aggregate function, and this function would be max. Alright, let's run it. Okay, now I'm going to find out the recovery rate. So recovery rate is basically the total number of cured cases divided by the total number of confirmed cases into 100. So I'll say statewise, and within square brackets I'll pass in my variable that I want to create, which is recovery rate. This will be equal to the cured cases multiplied by 100 by the total number of confirmed cases. Within square brackets I'll give my column as confirmed. Let's run this. Okay, I'll just copy this column, paste it here. So this time we are going to find out the mortality rate. So mortality rate is nothing but the total number of deaths divided by the total number of confirmed cases into 100. So I'm just going to replace the names. Here I'll say mortality. Alright, and then instead of cured I'll say my deaths column into 100 divided by the confirmed cases. Let's run it. Okay, now we are going to sort the values based on the confirmed cases column, and we'll sort it in descending order. So let me show you how to do it. I'll say statewise equal to, I'll use the function sort underscore values. So I'll pass in my variable statewise dot and use the sort underscore values function. I'll say by, I want to sort it by my confirmed cases column. Give a comma and I'll say ascending equal to false. Let's run it. Now we are going to plot our pivot table using a nice visual. So for that I'm going to use my background underscore gradient function, and inside that function we'll pass in our CMap parameter. I'll show you how to do it. I'll say style dot background underscore gradient, and inside this we'll pass in a parameter called CMap. So CMap stands for color maps. This is present inside the matplotlib library. So here you can see there's a nice documentation on choosing color maps in matplotlib. This is provided by matplotlib.org. If I scroll down, you can see there are a number of CMaps that you can use. Purples, blues, you have something called reds. There are other things like magma, you have summer, autumn, spring, winter, cool, all these. You can use whichever color map that you want, and here you can see the different shades or the gradients. Okay, so I am going to use my color map as cube helix. Let me run it and show you the pivot table. There you go. Here you can see we have our pivot table ready. Now, as I said in the beginning, there are a few discrepancies in the data set. So here you can see there's one called Maharashtra, and there's also Maharashtra triple star. This you can ignore. Even if I scroll down, you have Madhya Pradesh followed by 3 asterisks. You can ignore this value as well. Even for Bihar we have. So these have been duplicated, and here you can see the different state names and union territories. Then on the top you have the confirmed cases, cured cases, the deaths reported, and the new columns that we created. These are calculated columns, recovery rate and mortality rate, and we have ordered it in descending order of confirmed cases. So far our data says that Maharashtra has the highest number of cases, followed by Kerala, Karnataka, Tamil Nadu, Andhra Pradesh and Uttar Pradesh. So these are the top 5 states which have the highest number of confirmed cases. Even if you see, the mortality rate is also high for Maharashtra, and if I scroll down, the mortality rate is also high for Uttarakhand. If you see here, if I scroll further, you have Punjab, the mortality rate is also high. Alright, so this was our first visual that we created in the COVID data analysis project. Now moving ahead, we'll see the top 10 states based on the number of active cases. So we'll start. I'll give a comment, top 10 active cases states. Okay, so we are going to explore another very important pandas function in this, which is known as group by. So I'll first pass in my data frame, which is COVID_df dot followed by the group by function. I'm going to group my data based on state/union territory column. Then I'll say dot max, which is to find the maximum value from the states that have the highest active cases. So I have passed in my active cases column, and we're also going to group it based on the date column. After that, we are going to sort the values. So I'll use my function that is sort underscore values. I'll say sort by my column that is active cases. Let me bring this to the next line. Underscore cases. I'll give a comma and say ascending equal to false, say dot, and then reset my index. For that I'll use reset underscore index function. Okay, let's check if everything is fine. I have missed a square bracket here. Let me give another square bracket here. Okay, and all this we are going to store in our variable called top underscore 10 underscore active underscore cases. Okay, now let me go ahead and run this cell. Okay, there is a syntax error here. Now let's run it. Okay, now I'll create another variable called fig. Here we'll pass in the plt, which is for matplotlib library, and we'll give the figure size using the fig size argument. It's equal to, and within a tuple and passing the size, let's say 16,9. We'll run it. Okay, and let's give a title to our plot. So here we are going to create a bar plot. So using plt.title, we'll pass in the title, let's say top 10 states with most active cases in India. I'll give a comma and pass in the size of my title, let's say 25. Okay, you can see we are slowly being able to create our graph. The most important thing is to pass in the x-axis and the y-axis. I'll say ax, which is for axis. To pass in the axis, I'm going to use the bar plot function that is present inside the Seaborn library. I'll say sns.barplot. I'll say data equal to my variable, which is top underscore 10 underscore states. This is actually active states. Alright, and now I'm going to use the iloc function and take the first 10 states. So I'm using a colon and then giving 10 as my value. ILOC is for index location. I'll give a comma and say my y-axis to be active cases. Give another comma and say my x-axis to be state / union territory. Give another comma. We are going to pass in the line width to 2. I'll say line width equal to 2, and we'll give an edge color. Let's say the edge color is red. Okay, so I have my axis defined now. Let's run it. There's an error here. It says top 10 active states not found. Let's go to the stop and see the exact. Okay, so this is top 10 active cases. Let me change it to cases here. Now run it. Okay, the x-axis also has a mistake. This should be state/union territory. Now let me run it. There you go. We have our plot created, but as you can see here, the labels of the different states and union territories are overlapping. So for that, let me first pass in the x labels. I'll say plt.x label, and my x label would be states. Then I'll say plt.y label. My y label will have the total active cases. And finally, I'll write plt.show. Before I run it, let's collate all the lines of code that we have written for our top 10 states for most active cases in India into one cell. So what I'll do is I'll just copy this and we'll keep adding in this cell itself. Okay, I'll go to the top. Next, we'll copy my figure size and we'll paste it here. Next, let's take the title and put it here. Give a space, and we are going to copy this cell and I'll paste it here. Alright, now it's time to run it. There you go. You see it here. We have a nice bar plot ready. On the top you can see the title, top 10 states with most active cases, and you see the edges are in red color for all the bars. On the x-axis you have the different state names: Maharashtra, Karnataka, Kerala. You also have Andhra Pradesh, Gujarat, West Bengal and Chhattisgarh. So as you can see, Maharashtra has the highest number of active cases based on our data, followed by Karnataka, Kerala and Tamil Nadu at 2nd, 3rd and 4th place respectively, and in the 9th place we have West Bengal, in the 10th place we have Chhattisgarh. On the y-axis you can see the total active cases, which are in lakhs. Okay, now moving ahead, now we'll see the top 10 states based on the total number of deaths reported. So I'll give a comment: top states with highest deaths. Okay, so I'll first create my variable saying top 10 underscore deaths. This will be very similar to what we did here, just that we need to change a few column names. So instead of active cases we'll be using deaths. Okay, so I'll start with my data frame, that is COVID_df, followed by using the group by function, and I want to group my data based on the state/union territory column. Then I'll choose the max function, and within double square brackets I'll pass in my column names deaths and date. Let's make it consistent. I'll be using single quotes. Okay, I'll say dot, I'm going to sort my result, therefore I'm using the sort underscore values function. I want to sort it by deaths column. I'll give another comma and say ascending equal to false, which means I want to order my result in descending order. Then I'll say dot reset underscore index. Okay. After that, I'll give my figure size. I'll say plt dot figure, and within brackets I'll pass in my argument, which is fig size equal to, using a tuple, I'll say 18 comma let's say 5. Now let's give a title. For that I'll use the title function which is present in the matplotlib library. I'll say top 10 states with most deaths, and let's give a size to the title 25. Now it's time for us to give the access labels. I'll just scroll down. Okay, so I'll say AX equal to, again this will be a bar plot, so I'm using my Seaborn library followed by the bar plot function. My data will be top underscore 10 underscore deaths, which is this variable. I'll give my index location ILOC. I'm going to choose 12 states. The reason being, there are some discrepancies in the data. I'll show you once I plot this result. So in the y-axis we'll have deaths column. In the x-axis we'll take state slash union territory. Okay, I'll give another comma and say line width equal to 2, and we'll give an edge color to our bars like we did here. So I'll say edge color equal to, let's say, black. Okay, now finally we'll give the x label, the y label. So I'll say plt dot x label. X label would be states. My y label will be total death cases. Then I'll write plt dot show. Now let's run it. There you go. You can see here we have a nice bar plot. On the top we have the title, top 10 states with most deaths. Now what I specifically wanted you to see was these discrepancies in the data. You can see here Maharashtra is repeated twice, even in our data that we collected from Kaggle. Karnataka spelling has an error. You can see here we have a few rows of information where Karnataka is spelled as K-A-R-A-N instead of K-A-R-N-A. Alright, so to remove these two results, or to ignore these two results, I had given my index location till 12. So we have Maharashtra, Karnataka, Tamil Nadu, Delhi, then Uttar Pradesh, West Bengal, Kerala, Punjab, Andhra Pradesh and Chhattisgarh with the states that have the most number of deaths reported. Okay, now we'll create a line plot to see the growth or the trend of active cases for top 5 states with most number of confirmed cases. So the states are Maharashtra, Karnataka, Kerala, Tamil Nadu and Uttar Pradesh. I can show you. So these are the states with highest number of active cases. Okay.
Hello everyone. Welcome to today's video tutorial by Simplilearn. In this video, we are going to perform a really interesting data analysis using Python on the Spotify music streaming service platform dataset. I'll also be asking you a few questions related to Spotify during our discussion. Please make sure to answer them in the comment section of the video. So now let's get started. Spotify is a Swedish audio streaming and media services provider founded in April 2006. It is the world's largest music streaming service provider
and has over 381 million monthly active users, which also includes 172 million paid subscribers. The total number of downloads on the Spotify app in the Android store exceeded 1 billion in May 2021. So millions of people listen to music all day. Even I am hooked to music. As an analyst, what's better than exploring and quantifying data about music and drawing valuable insights? Before I move ahead, I have a quiz question for you people. The name Spotify comes from a combination of two words. So which are those two words? Please let us know your thoughts in the comment section below. I would like to repeat the question again. The name Spotify comes from a combination of two words. So what are those two words? We would love to hear from you. So please put your answers in the comment section below. Now let's use Python libraries and functions to analyze and visualize our dataset. First, I'll show you the two datasets that we'll be using. So here is the first dataset that we'll be using for our demo, and then I have my second dataset called Spotify features, which is essentially about the genres of the different soundtracks. Now these datasets have been downloaded from kaggle.com. Now the links to the datasets have been provided in the description box. Please go ahead and download them. Now let me just go ahead and brief you about the columns that are present in our first dataset, which is about tracks. We have our column A, which is ID. This is the unique ID for each of the songs. Then we have the name column, which is essentially the name of the song. Then we have a column for popularity. So the popularity ranges from 0 to 100. Then we have duration in milliseconds. This is the duration of the track in milliseconds. Next, we have a column called explicit. Now we are not bothered about this column because we are not going to use it in our analysis. Then we have artist. So the name of the artist who has composed or sung the song. Then we have ID of the artist. Then we have a column for release date, which is basically the date on which the song was released. Then we have a column for danceability. So this describes how suitable a track is for dancing based on a combination of musical elements such as tempo, rhythm stability, beat, strength, and overall regularity. The value ranges between 0 and 1. Next, we have a column for energy. So the energy is a measure between 0.0 to 1.0 and represents a perceptual measure of intensity and activity. Typically, the energetic tracks feel fast, loud, and noisy. Higher the value, the more energetic is the song. Then we have a column for key. So key is the pitch, notes or scale of song that forms the basis of a song. There are 12 keys ranging from 0 to 11. Moving ahead, we have loudness. So the overall loudness of the track in decibels, it ranges from -60 to 0 decibels. Then we have mode. So songs can be classified as major and minor. 1.0 represents major, or 1 represents major, and 0 represents minor. Next, we have speechiness. So speechiness recognizes the presence of spoken words in a track. More exclusive speech like the recording, example talk show, audiobook, or poetry, the closer to 1.0 the attribute value. Then we have a column for acousticness. So a confidence measure of 0 to 1 of whether the track is acoustic or not. So 1.0 represents high confidence the track is acoustic. Then we have other information about instrumentalness. Then we also have a column for liveness. So liveness detects the presence of an audience in the recording. Then we have a column for valence. So valence is a measure between 0.0 to 1.0 and describes the musical positiveness conveyed by a track or a song. And finally, we have the columns for tempo and time signature. Now, even in the second dataset, we have almost the same columns, just that we have an additional column that is about the genre of the songs present in the dataset. Cool. Now let's head over to our Jupyter notebook and we'll start with our analysis. Okay, so one more thing to remember. Our data has information from 1922 onwards. So all the songs from 1922 till 2021. Cool. Okay, so I'm on my Jupyter notebook. So you can see I have a few cells that have already been filled up. So we'll start with our analysis. First of all, let's go ahead and import the necessary libraries. So I'm importing NumPy, Pandas, Matplotlib and Seaborn for my analysis and visualization. I'll hit Shift Enter to import the libraries. Alright. And in the next cell, I'm going to load my dataset using the pandas read_csv function. I have my location already put here. Let me show you the location where the data files or the data sets are located. So this is my location under Chrome downloads. I have a folder called Spotify datasets. Okay, so let's import and check the first 5 rows in the dataset. So for that I've used the head function. There you go. So here you can see I have my first 5 rows of information from the dataset, and on the top you can see the different columns. You have ID, name, popularity, artist, then we have the release date, danceability, energy, key, loudness, liveliness or liveness, balance, tempo and other information. Cool. Now let's check for null values in the dataset. I'll just give a comment as null values. Every time when you download a dataset from an open repository, there are chances that the dataset would contain null values, so it's better to check them beforehand. So I'm going to use the isNull function present in the pandas library. PD I'm using because I had imported pandas as PD. So pd.isNull. Then I'm going to use the variable name df_tracks because I imported my dataset and stored it in the variable df_tracks. So I have my data frame under df_tracks variable, and then I'll use the sum function to check the total number of null values present in the dataset for each of the columns. If I run it, there you go. So here you can see my name column has 71 missing values or null values, and we don't have any null values for the rest of the columns. Okay. Now let's use the info method that will give us the total number of rows and columns in the dataset, and we'll also check the data types and the memory usage. So I'll say my data frame name, that is df_tracks.info. If I run it, you can see here. Now if you mark, there are total 5,86,601 names or the names of the songs present in the dataset, while the rest all have 5,86,672. So clearly there are total 71 song names or soundtracks missing from our dataset. And below you can see the data types. We have float, integer and object, and then you can see the memory usage. Cool. Now before I move ahead with our next analysis, I have another question for you. Which artist or musician has the most number of followers on Spotify? I repeat, which artist or musician has the most number of followers on Spotify? Please put your answers in the comment section below. We would be happy to hear from you. Now let's move ahead and do our first major analysis in this demo. We are going to find the 10 least popular songs present in the Spotify dataset. So I'll create a variable called sorted_df that will be equal to my data frame name, that is df_tracks dot. I'm going to use the sort_values function and say my column name is popularity. So I'm going to sort the values based on the popularity and then say ascending equal to true, since I want only the least popular songs. And then I'm going to say head of 10, which means I want the top 10 least popular songs. Now let's go ahead and print sorted_df. If I run it, you can see we have the list of 10 least popular songs on Spotify. You can see that popularity is 0, and you can see the names of the songs. Some of them are songs which are not in English language, and you can see the artist names as well. Cool. Now moving ahead, let's see some descriptive statistics for the numerical variables that are present in our column. So I'll say df_tracks dot describe, which is the function to get some descriptive statistics, and I'm going to use the transpose function after that. If I run it, there you go. So we have the statistics about count, mean, standard deviation, minimum value, 25th percentile, 50th percentile, 75th percentile, and the maximum value for these columns like popularity, duration in milliseconds. Then we have energy, key, loudness, mode. Cool. Now if you see this popularity column, the minimum value is 0 and the maximum value is 100, and you can see the 50th percentile is 27, which is essentially the median. You have the standard deviation as 18.37. Then similarly you can check for the other features as well. Cool. Now we'll see the 10 most popular songs which are greater than 90. So we are going to check for the top 10 songs with popularity greater than 90. Let me show you how to do it. So in this cell, I am going to create a new variable called most popular, and I'll say df_tracks dot. This time I'm going to use the query function that is part of pandas library again. I'll use the column that is popularity, and we'll set the condition popularity should be greater than 90. I'll give a comma and say in place equal to false, because I don't want to change my original data frame. And then I'll say sort_values, and I'm going to sort it based on popularity in descending order. So I'll say ascending equal to false, and then let's take only the top 10 popular songs. So I'll say most popular, use square brackets, and we'll then pass the slicing operator and say :10. Now if I run this, there you go. So here you can see the 10 most popular songs that is present in our Spotify dataset. So first we have Peaches by Justin Bieber, Daniel Caesar and Gibbon. Then we also have a song name called Driver's License, Astronaut in the Ocean, Save Your Tears. We also have The Business, Streets, and Heartbreak Anniversary. So these are the most popular songs that are present in our dataset based on their popularity. You can see Peaches has the highest popularity with 100. Alright, now moving to the next cell. So here we are going to set the index to be release date column in the main data frame. So I am setting my index using the set_index function. I have passed in my column name as release date, and I'm saying in place equal to true, which means I want to change it in my original data frame, and then I'm changing the value to date time format, and let's print the head of the dataset. So you can see here we have successfully changed our index. Now here you can see instead of 0, 1, 2, 3 we have the release date column, and the rest of the columns are intact. Cool. Now let's move ahead. So suppose you want to check the artist at the 18th row in our dataset. You can use the index location method for that. let me show you how to filter only specific rows of information from the dataset. I'll use my data frame df_tracks, and using double square brackets, I'll say my column name, which is artists, and I'll use the index location method and say, let's say I want to check the artist who is present in the 18th row in my dataset. So I'll use iloc18. If I run it, the artist's name is Victor Boucher. Cool. Now let's move ahead. We are going to convert the duration in milliseconds to just seconds. So if you see our dataset, we have a column called duration in milliseconds. So all our songs are present in milliseconds. Let's convert them into just seconds. So for that, I'm using the lambda function and dividing the values in milliseconds by 1000 so that they get converted into just seconds. I have used in place equal to true, so I want to change it in my original data frame. Let's run it and do the necessary changes. Alright, now we'll print the head of the dataset just to check the duration column. So I'll say df_tracks dot duration dot head. If I run it, there you go. So you can see the values have now been changed to just seconds. Cool. I have the final quiz question for you. Who has the most monthly listeners on Spotify? Please put your answers in the comment section below. We'd be glad to hear from you. Now coming to the next cell. So here we are going to create our first visualization that is going to be a correlation map. We are going to drop 3 unwanted columns, and those are key, mode and explicit, and then we are going to apply Pearson correlation method. Now I have set my figure size to 14,6, and then we are using the Seaborn heat map function to create our correlation map. I have put the variable that is correlation_df. You can see above we had created this, and then I'm setting annotation equal to true. So this will write the data value in each cell. I have set fmt equal to .1g. So this is a string formatting code to use when adding annotations. Then I have set my vmin and vmax. So these are the values to anchor the color map. Otherwise they are inferred from the data and other keyword arguments. CMap here stands for color map. You can just search for SNS CMap. You will get the documentation. So you can choose whichever color palette or the color map you want. Here I have used Inferno, and I have set my line widths and line color. Finally, I am giving a title to my correlation map, and I have set the Xtick labels. Let's go ahead and run this to get our first visualization. If I scroll down, there you go. We have got a nice correlation map. So here on the right side you can see the scale. It ranges from -1 to +1. -1 means the variables have least or negative correlation, while the values which are above 0.0 means that the variables have a positive correlation. Now here you can see there are values like -0.7 for energy and acousticness, which means if the energy is high, the acousticness is really low. Again, for loudness and say speechiness, if the song is loud, the speechiness is low, so there is negative correlation. But if you see for energy and loudness, there is a really high correlation between these two variables. You can see the value is 0.8. So if the song is loud, this implies the song has really high energy, and vice versa. Now if you see for a few other variables, there is negative correlation between acousticness and danceability. There is negative correlation again between valence and acousticness. Similarly, there is positive correlation between energy and valence, which is 0.4, and even for danceability and valence, that is positive correlation, which is 0.5. Cool. So from the correlation heat map, you can note that acousticness appears to have a strong negative correlation with energy. So if you see for acousticness and energy, there is a strong negative correlation, and there is a moderately strong positive relation between loudness and popularity. So if you see for popularity and loudness, the color is orange, which means it lies in this positive region. And there is also a moderately strong positive relation between danceability and valence. So if you check for danceability and valence here, there is a moderately strong positive correlation. Alright, now let's move ahead. We are going to sample our data and take just 0.4% of the total data, and we'll create 2 regression plots using this data. So let me first sample my data. So I'll create a sample data frame using my original data frame, which is df_tracks, and say sample. I'm going to use the int function and say 0.004 multiplied by the length of my original data frame, which is df_tracks. Alright, now let's run this and we'll print the length of my sample data frame. If I run it, you can see 0.4% of my total data set is 2346 rows. Cool. Now we are going to create a regression plot between loudness and energy. Now in our correlation map, we saw there was a positive correlation between loudness and energy, which was 0.8. Let's plot it in the form of a regression line. So I'll use plt.figure. I'll set my figure size equal to, let's say, 10,6. I'll say SNS dot regression plot. So I'm using the function called regplot, and I'll use my data as sample_df, give a comma, and say in my y-axis I'll have my column loudness, and in the x-axis we'll have energy. I'll give a color to my data variable. Let's say the color is C. Then I'll set my title to loudness versus energy. Let's say correlation. Alright. Let's make sure everything is fine. Now we'll run and see our result. There you go. So you can see here clearly there is a very high positive correlation between loudness and energy. On the y-axis we have loudness, and on the x-axis we have energy, and you can see all the data points or the songs are in one direction. So if the energy increases, the loudness of the song also increases, and similarly if the loudness of the song decreases, your energy of the song or the track also decreases. So there is a very high positive correlation, and you can see the regression line here. It has gone and is increasing gradually. Cool. Now similarly, I'll just copy this code
and we are going to see another regression plot, this time for two different features. Let's say we have popularity in the y-axis, so I'll say popularity, and then in the x-axis we have, let's say, acousticness. I'll change the color to, let's say, B, which stands for blue, and will set the title to popularity versus I'll have acousticness correlation. Just scroll down and we'll run it to see the result. There you go. So I have the different points for the songs, and here you can see the regression line is downwards, which means if the acousticness of the song increases, the popularity decreases, and similarly if the popularity increases, acousticness decreases. You can see the downward trend of the regression line. Alright, now in the next cell we are going to create a new column called year from our release date column, and I have changed this to date time format. Let me just run it. Cool. Now after that we are going to create a distribution plot to visualize the total number of songs in each year since 1922 that is available on the Spotify streaming app. So I have used my Seaborn library and dist plot function. Now one thing to remember, you need to update your Seaborn library to this version if you haven't done it. So use this command pip install --user Seaborn and the version. So here in the distribution plot we are going to plot a histogram. So I have used kind equal to hist, which stands for histogram. Let's run and see the result. Okay, so here you can see I have my distribution plot. So the plot tells us that the number of songs for each year in the dataset according to their release date have increased in the recent years since music became more accessible to people globally with technological advancements. So earlier you can see there were very few songs available in the 1920s. Later on the number of songs increased rapidly, and now you can see we have a lot more songs available for people to listen. Cool. Now we are going to see the duration of songs over the years. For that again we are going to create a bar plot. So I'll first create a variable called total duration equal to df underscore tracks dot, I'll use the duration column that we created with seconds, and then I'm going to set my figure dimensions. So I'll use figure underscore dims for dimensions equal to 18,7. After that I'll have my figure axis defined. So I'll use the matplotlib subplots function, and I'll set the figure size equal to my figure dimensions, and then I'll say figure equal to sns dot, I'll use the bar plot function and say my x-axis to be years, my y-axis will be total duration or total underscore dr that we created here. I'll set my axis equal to ax, and then I'll set error width equal to
false. Let's set the title for my plot as title equal to year versus duration, and finally I'll say plt.xtext. I'll rotate it by, let's say, 90 degrees. Alright, let me just recheck once if everything is fine, and then we'll go ahead and run it. I have my axis, error width, title. Okay, let me just run it. We'll see the result in a moment. If I scroll down, you can see we have the bar plot for the different years and the duration of the songs in seconds in the y-axis. So earlier in the 1920s, you can see the duration of the songs were less, and later it increased around late 1930s, and this remained consistent until 2010, where the duration was high. But after 2010, you can see the duration of the songs have started decreasing. Now in the next cell, I'm going to create a line plot to analyze the average duration of the songs over the years. It is going to be similar to our bar plot, just that now we are going to visualize it in terms of a line. So I have my code ready. You can see here I've used my Seaborn library and the line plot function. In the x-axis I have years, and in the y-axis I have total duration. I've set my title to year versus duration, and I'm rotating my x labels by 60 degrees. Let's run it and we'll see the output. There you go. Now if I scroll down, you can see we have a nice line plot, and on the x-axis you have the years, and on the y-axis we have the duration. We can see that the songs from 1920s to 1960s have comparatively shorter duration, since most of the songs tended to be more singing based rather than instrument based. After 1960s, you can see the duration of the songs started increasing until, I would say, 2010, and in the present day the duration of the songs have started declining, since the attention span of the average listener is also declining. Alright, now let's move to our second data analysis project, which is based on genres of the songs. So I am importing my dataset using the pandas read_csv function. I have given my location, and here I have my dataset name followed by the extension of the type. So this is a CSV dataset. Let's go ahead and run it. Okay, now let's print the first 5 rows of the dataset. I have stored my dataset in a data frame called df_genre. I'll use the head function to get the first 5 rows of information. I'll hit Shift Enter to run it. There you go. You can see here I have my genre column, artist name, track ID, popularity, acousticness, duration in milliseconds again, and we have the rest of the other columns that we saw in our first dataset. Just one thing to note, here key is present in terms of C, D, E, C minor, F minor, and not in terms of numbers between 0 to 11. Now we'll see the duration of the songs for different genres. For that, I'm going to create a bar plot. So I'll start with setting the title for my plot as duration of the songs in different genres. I'll use the Seaborn library, and I'll set my
color palette to, let's say, rocket. I'll give a comma and say as CMap equal to true. This would be color palette. Now I'll say SNS dot bar plot. In the y-axis I'll have genre, and in the x-axis I'll have my duration column, which is in milliseconds, so duration underscore ms, and then I pass my data frame using the data argument. So I'll say data equal to df dot genre. Next we'll set the x labels, so I'll say plt dot x label. Let's say my x label is duration in milliseconds, and then I'll say plt dot y label as genres. Now let's go ahead and run this. There you go. So here you can see we have the different genres on the y-axis, and on the x-axis you have the duration in milliseconds. And if you see the graph for classical genre and for songs that belong to world genre, the duration of the songs are more compared to other genres. Now if you check for children's music genre, the duration is less or the least. Cool. And finally we'll move to our last demo, where we'll see the top 5 genres by popularity. So I'll say SNS dot set underscore style. I'll set my style to dark grid, which will be my background, and then I'll say plt dot figure. I'll set my figure size to 10,5. Then I'll create a variable called famous, since I want to take only the most popular songs based on the genre. So I have created a variable called famous, and I'll pass my data frame name, that is df underscore genre, and I'll sort the values based on my popularity column. So I'll say popularity, and I want to sort it in descending order, so I'll say ascending equal to false, and I'll take the first 10 values. I'll tell you the reason why I'm taking the first 10 values and not 5. Then I'll say SNS dot bar plot, and in the y-axis I'll have genre, in the x-axis we'll have popularity, and I'll give a comma, and using the data argument I'll say my data to be famous, which is this variable that we created, and then I'll set my title as top 5 genres by popularity. Alright, now the reason why I took head of 10 is because there are a few genres which are repetitive. So if you see this, we have children's music appearing twice, so hence we have taken 10 instead of 5. Let me just go ahead and run it. There you go.
So here if I scroll down, you can see I have my top 5 genres based on the popularity. So we have dance, pop, rap, hip hop and reggaeton. So these are the 5 genres which are most popular based on the data that we have collected from Spotify. Alright. Hi everyone. Welcome to this really interesting video on data analysis of the 2021 World Happiness Report using Python. So today we will perform some exploratory data analysis using Python libraries to analyze, visualize and draw insights from 2021 World Happiness data. Before I begin, make sure to subscribe to the Simplilearn channel and hit the bell icon to never miss an update. First, let's understand what the World Happiness Report 2021 is all about. The International Happiness Day is celebrated every year since 2013 on 20th of March to emphasize the importance of happiness in the daily lives of people. So the United Nations Sustainable Development Solutions Network published the World Happiness Report on 19th of March 2021 that ranks the world's 149 countries on how happy the citizens perceive themselves to be based on various indicators. The happiness study ranks the countries on the basis of questions from the Gallup World Poll. The results are then equated with other factors such as GDP, life expectancy, generosity, etc. This year it focused on the effects of the COVID-19 pandemic and how people all over the world have managed to survive and prosper. So using this 2021 data, we will answer critical questions such as the top 10 most corrupt countries. We will plot a graph to understand how the happiness score is related to the freedom of making life choices. We'll look at the life expectancy of 10 happiest and 10 least happy nations. So these are a few examples, but we will explore more about the data in detail in our demo session. Let's get started. So first I'll show you the data set we'll be using in this demo. So this data has been collected from Kaggle. Let me show you that. So this is the CSV dataset that we have downloaded from Kaggle.com. So you can see here World Happiness Report 2021, and we will share the dataset link in the description of the video. You can click on the link to download the dataset. Now we have information about 149 countries. You can see it here. Count is 149. Let me go to the top and I'll run through the columns that are there in this dataset. So the first column is the country name. So we have 149 different countries, and then we have something called as regional indicator. We can call this as just the region. So you can see we have different regions. I've applied a filter. We have Central and Eastern Europe. Then we have Commonwealth of Independent States. So these include countries such as Russia. Then we have East Asia, Latin America and Caribbean. We also have South Asia, Southeast Asia, Sub-Saharan Africa, Western Europe and other regions. I'll just cancel this. And then we have the happiness score column that has been sorted in descending order. So we have Finland, Denmark and Switzerland, who are the top 3 happiest nations. Now if I scroll down, we have countries like Rwanda, Zimbabwe and Afghanistan, which are the least 3 happy countries. Now there are a few columns that we won't be using in our analysis, so we will learn how to exclude those columns and keep only the relevant ones. So columns such as standard error of ladder score, then we have upper whiskers and lower whisker column. So we are going to ignore these columns. We are only concerned about the GDP column, which is this one. Then we have the social support or the social status column. Then we have the health life expectancy, freedom to make life choices, generosity and perceptions of corruption. And there are a few other columns you can see to the right, and these columns are not of our interest, so we are going to ignore them. Now let's head over to our Jupyter notebook and we'll start by importing all the necessary libraries for analysis and data visualization. Okay, so I'm on my Jupyter notebook. So first step, I'll just rename this notebook to, let's say, happiness report data analysis. I'll click on rename. Alright, now we'll start by importing our libraries. So first library I'm going to import is numpy as np. Then I have import pandas as pd. Then I'll import two data visualization libraries, seaborn and matplotlib. So I'll say import seaborn as sns, and then import matplotlib dot pyplot, which is the module name, as plt, and I'll say percentage matplotlib inline. Okay, now let me just go ahead and run this. Alright. Well, now let's set the parameters that control the general style of the plots. The style parameters control properties like the color of the background and whether a grid is enabled by default or not. So for that, I'll say sns dot set underscore style. I'll give it as dark grid. Next, I'll say plt dot rc params, which stands for runtime configuration parameters. I'm going to set my font size to, let's say, 15. Then I'll say plt dot rc params. Now I'm going to set the figure size, so I'll say figure dot fig size. Let's say 10,7. Next, I'll just copy this, paste it here. Now we are going to set the face color, so I'll say figure dot face color. I want to set it to peach color, so I'm going to pass in my RGB values for peach. I'm going to set it in terms of hex code. So for peach, the value is FF E 5B and 4. Now let me run it. Okay. Now it's time to load our data set. So for that, I'll create a variable called data, and I'll use the pandas library followed by the read underscore CSV function, because our data set that we saw is a CSV data set, which is this one. Now inside the parenthesis, I'll pass in the location of my data file. So I have my data here, World Happiness Report 2021. I'll just copy this location and will paste it here, and make sure the location is within quotes, and you need to change it to either / or double \. So here I'm using double \. So let me just include one more \, and then I'm going to pass in the file name, which is world happiness report 2021 .csv, which is the extension of the file. Now let me run it. Alright, now to display the first 5 rows of information, you can use the head function. So I'm writing data, which is my variable that holds the data frame. So data.head, there you go. You can see here we have printed the first 5 rows from the dataset. You have the country name, regional indicator, happiness score. Then we have information about the GDP, life expectancy, generosity. Then we have corruption data and These are some of the columns that we are not bothered about, so we are going to drop these columns from our analysis. Now we are going to do that, so I'll create a variable called data columns which are of our interest. So I am going to take only specific columns. I need the country name, so I have taken country name. Make sure the column names are within single quotes, so I have my country name. Next I want the second column, which is regional indicator. I'll give a comma. We also need the happiness score. Next I need the logged GDP per capita data, so I'll take that column. I'll say logged GDP per capita, give a comma. My next column would be social support, give a comma here. My next column would be health life expectancy, so I'll write health life expectancy. Let's give another comma, and we'll take the next column as well, which is freedom to make life choices. So I'll write that column name, freedom to make life choices. And finally we'll take the next two columns, that is generosity and perceptions of corruption. So within single quotes I'll say generosity, give a comma, and we're going to include the final column which is of our interest, that is perceptions of corruption. Let me have a recheck to ensure that I have put the column names correctly, otherwise it will throw an error. Now let me go ahead and run this cell. I'll hit Shift Enter. Alright, so we have successfully taken the columns that we'll be using for an analysis. Now I'm going to say data equal to data. I'll pass in my new variable, that is data underscore columns, and I'm going to copy all the data. So I'll say dot copy. Let's run it. Okay, this should be data underscore columns. Alright, now let's rename all these columns. We'll make it more simpler and easy to understand. So I'll say, let's say my new variable is happy underscore df, which stands for data frame, equal to, I'll say data dot, we'll use the rename function, and using a dictionary we will rename our columns. So I have used a curly bracket. I'm going to pass in my first column, which is country name. I'll just paste it here. Then I'm going to give a colon, and again within single quotes I'll say country underscore name. So this is going to be my new column name. I'll give a comma. We'll take the next column, which is regional indicator. I'll paste it here, give a colon, and the new column would be small r regional underscore indicator. Now similarly we'll do this for all the remaining columns in the dataset. Okay, now I have renamed all my columns. You can see it here. Let's run it. Now we are going to display the head of the dataset again. So I'll say happy underscore df dot head. There you go. So we have only those columns that are of our interest. So I have the country name, regional indicator, happiness score, GDP, social support, life expectancy, freedom to make life choices. Then I have generosity and perceptions of corruption. Cool. Now we are going to check whether any of the columns have any null values. So for that I'll say happy underscore df dot, I'm going to use the isNull function. I'll give another dot and we are going to find the sum for each of the columns. You can see from the data we do not have any null values in any of the columns in the data set. It is all 0. Okay, now let's get started with our first visualization. That is, we'll create a plot between happiness score and the GDP for different regions. So for that I'll give a comment as plot between happiness and GDP. I'll just scroll down. Cool. First I'm going to set the RC parameters. So I'll say plt dot RC params. Within square brackets I'm going to give my figure size. So I'll say figure dot fig size equal to, let's say my figure size is 15,7. I'll set the title, that is plt dot title of my plot, to, let's say, plot between happiness score and GDP. Next I'm going to say SNS dot, let's create a scatter plot. So I'll say SNS dot scatter plot. I'm going to define my x-axis and the y-axis for the plot. Let's say in the x-axis we have my data frame happy underscore df dot, this should be an underscore. I'll say a column name as happiness underscore score, give a comma, and in the y-axis we'll have my data frame name, that is happy underscore df dot, we'll have the GDP column, that is logged underscore GDP underscore per underscore capita. Let's give a comma and we'll pass in hue for the color. Let's say for hue I'm going to use the regional column or the regional indicator column. So I'll say happy underscore df dot regional underscore indicator. And then I'm going to give the size of the dots as, let's say, 200. Then I'll give a semicolon. Come to the next line. I'll say plt dot, let me just scroll down. Now we are going to define the legend. So I'll say plt dot legend, and in legend we'll have the location. Let's say I want to put the legend at upper left corner. So I'll say LOC, which is for location, equal to upper left, give a comma, and then say font size of my legend, let's say be 10. Make sure this is within quotes. Then I'm going to pass my x-axis labels and the y-axis labels. So I'll say plt.x label. Let's say the x label is happiness score and my y label is GDP per capita. So I'll say plt.y label, within single quotes I'll say GDP per capita. There's an error here, there should be plot. Alright, so I have written my code to create a scatter plot. Let's run it and see the result. There is some error here. Okay, this should be regional indicator and not indicatory. There's a spelling mistake. Let's run it again. Alright, so here you can see we have a nice scatter plot. On the top you can see we have the title of the plot, that is plot between happiness score and GDP. On the x-axis we have the happiness score from 0 to 8 and above, and on the y-axis you have the GDP per capita. And if you see here, in this region we have countries from Western Europe which have the highest happiness score, and the GDP per capita is also the highest. Around this region you can see here, which is for green, and in the legend you can see green is for Sub-Saharan Africa. So all these countries have low happiness score, and even the GDP per capita is also low. And if you see the countries for Latin America and Caribbean, you see a lot of the values lie here. So they are all within the range of 5.5 to 7 in happiness score, and even the GDP per capita is more than 9 for most of them. Now even the happiness score is high for the countries that lie in the North America and ANZ region, and even their GDP per capita is also the highest. I can name a few countries such as Australia, New Zealand, we have Canada and United States of America, which belong to the North America and ANZ region. Cool. Now there is one country which you see here. This seems to be like an outlier, which means that this is the country which has the lowest happiness score, and even the GDP per capita is also low, but it is not the lowest, because you can see here there are a few countries up here from the Sub-Saharan Africa which have the lowest GDP per capita, but the happiness score is higher than this value or this country. So we can assume that this country is Afghanistan, which has the lowest happiness score as per the 2021 happiness report data. Cool. Now we'll plot a pie plot to understand the GDP by region. So by this we can know which region has the highest percentage contribution to the world's GDP as per our data. So for that I'll create a variable GDP underscore region equal to, we'll use our data frame, that is happy underscore df dot, I'm going to use the group by function, and after that I'm going to use my column, that is region. So we have named the column as regional underscore indicator, so I'm going to group it by this region column, and I'm going to sum the values of GDP. So I'm going to use the logged underscore GDP underscore per capita column, and after that I'm going to use the sum function, and let me just print GDP underscore region. You can see it here, we have the sum of all the countries for different regions and their GDP all total. Now this data we are going to plot it in the form of a pie plot. So I'll say GDP underscore region dot plot dot pie. We are going to plot it in terms of percentage, so I'm going to use a parameter called AutoPCT equal to, then I'm going to pass in my format. So I'll say percentage 1.1 f percentage, then I'll say plt dot title. Let's see, the title of my pie plot is going to be GDP by region, and I'll say plt. By label, 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 and I'll say plt. By label which is going to be blank. Let's run it. Okay, so here you can see we have the peach background at the back because we had assigned a peach face color. You can see it here. So for the first scatter plot also we had the peach color at the back, and now you can see we have Sub-Saharan Africa contributing 20.7% to the world's GDP. The reason being we have around 34 countries in the Sub-Saharan Africa, and we have the Western European countries contributing to 16.2% of the GDP. To check the least, we have North America and ANZ region because we only have 4 countries: America, Australia, Canada and New Zealand. So hence they are contributing only 3.1% to the world's GDP. Okay, now moving ahead, let's find the total number of countries in each region. So for this we are going to use the group by function that is part of the pandas library, and we'll count the total number of countries in each region. So I'll just give a comment as total countries. Alright, I'll just scroll down. So I'll create a variable called total_country. I'm going to use my data frame, that is happy_df dot. I'm going to use the group by function. I'll group the values based on the region column. So within single quotes I'll say regional_indicator, and then I'm going to find the total count of country names. So I'm using the column country_name, and after that I'll just use dot count. Now let's go ahead and print my variable, that is total_country. Alright, now let me hit shift enter. Okay, so here you can see. Alright, so for Sub-Saharan Africa there are total 36 countries and not 34 as I mentioned earlier. So hence you can see, because it has the highest number of countries, it is contributing the most to the world's GDP, that is 20.7%. Then we have the least number of countries in North America and ANZ, that is only 4. We have 6 countries in East Asia, and then we have 20 countries in Latin America and Caribbean, 12 countries in Commonwealth of Independent States, then we have 17 countries in Central and Eastern Europe. Cool. Now I'm going to show you how to create a correlation map so that we can see the relationship that exists between each of the variables that are present in our dataset. I'll just run through the code and we'll see the output. Okay, so here I have my code written for the correlation map that I want to create. So first of all, I'm going to compute the correlation matrix. So I have used the CORR function, which stands for correlation, and the method I'm going to use is Pearson method. Now here I have a Wikipedia page opened for Pearson correlation coefficient. So this is a nice article where you can understand what the Pearson correlation is all about. And then I'm going to set up the matplotlib figures. So I have used the subplots function and I have given the figure size as 10,5, and after that we are going to draw the heat map with the mask. So I'm using the heat map function present in the Seaborn library, and then I have passed in my variable, that is COR, which essentially stands for correlation. And then I have used mask, which is a Boolean array, or it can be a data frame, and it is an optional parameter. If it is passed, the data will not be shown in cells where the mask is true, and the cells with missing values are automatically masked. After that, I have used the CMap parameter, which stands for color map, so you can customize the colors in your heat map. And I'm going to create a heat map which is in square shape, so I have said square equal to true, and the axis I am going to pass it as AX, which I have defined here. So this is the matplotlib axis and it is optional. So axis in which you want to draw the plot, otherwise you can use the current active axis. Now let me just go ahead and run this and we'll see the heat map. There you go. So if I scroll down, here we have the correlation matrix, and since I had given my C map as blue, and here you can see it is mostly blue, and we have the scale here. Now I'll tell you how to read this correlation matrix. So wherever the cells are in blue or dark blue color, this means that the variables have very high correlation, and all these cells where you see light blue color or grayish and white color, this indicates that the variables have very low correlation. For example, there is very low or almost negative correlation between happiness score and perceptions of corruption. So obviously if the citizens of a country feel that there is a lot of corruption in the country, their happiness score would obviously be less or low. And if you see, there is also low correlation between happiness score and generosity. There is again low correlation between health life expectancy and perceptions of corruption. And if you see these places, there is really high correlation between the happiness score and GDP per capita. Again, for social support also there is very high correlation. Now if you see, even for social support and healthy life expectancy, there is very high correlation, but there is low correlation between making life choices and generosity, and there is negative correlation between corruption and freedom of making life choices. You can see it is almost white color, which means it falls around this region, so negative correlation. Similarly, for logged GDP per capita and corruption, there is negative correlation. Alright. Okay, now we are going to visualize a bar plot that will tell us the corruption in different regions. So I'll just give a comment, corruption in regions. Let me just scroll down. Okay, so I'll create a variable called corruption, which will be equal to my data frame, that is happy_df. Now first of all, I'm going to use the group by function to group all my regions. So I'll say regional_indicator, which is my column name present in the data set. And after this, I'm going to find the average of the corruption, that is perceptions of corruption. So I'm going to pass in my variable name, that is perceptions of corruption, and I'm going to use the mean function to find the average corruption in each of these regions. Now let me just go ahead and print my variable, that is corruption. If I run it, you can see here I have the values for the different regions, and from here you can see that Central and Eastern Europe has the highest perceptions of corruption as per the questions answered in the poll. And if you see the table, we have Western Europe and the North America region with the least perceptions of corruption. Now we are going to visualize this using a bar plot now. So first of all, I'll set my parameters by giving the figure size. I'll say fig size. It's rather figure.fig size. I'll just add figure here. Okay, and now let's say I'll assign it as 12,8. Now I'll give a title to my plot. So I'll say plt.title and my title of the plot is going to be Perception of Corruption in Various Regions. Alright, then I'm going to define my X label. So I'll say X label will be regions, and we'll set the font size of the X label to, let's say, 13, or let it be 15. Then we are going to set the Y label. In Y label I'll have corruption index as the label name. Again we are going to set the font size to 15. Now I'm going to use X ticks parameter. Since I want to rotate the axis labels in the x-axis by 30 degrees, so I'll say rotation equal to 30, and I'll say HA, which stands for horizontal alignment, equal to right. Make sure this right should be within single quotes. And finally I'll say PLT dot bar, because I'm going to plot a bar graph. I'll say corruption dot index, comma, and then I'll say corruption dot perceptions of corruption, which is my column name. Alright, so I have my code ready for the bar plot. Now let me just go ahead and print the bar plot. Make sure everything is correct. I'll just hit Shift Enter. Okay, there is one mistake here. It says, okay, this should be X ticks and not X tick. Let me run it again. There you go. So if I scroll down, on the top you have the title, which is Perception of Corruption in Various Regions. On the x-axis you have the regions label. On the y-axis you have the corruption index. And if you see this, as per our table that we created, we have least corruption in North America and ANZ region. Then we have the next least corruption in Western Europe, but we have the highest corruption in Central and Eastern Europe as per their citizens' perception. Similarly, we have the second and third highest corruption in Latin America and Caribbean as well as South Asia. Cool. Now moving ahead, I'm going to show you how you can find the life expectancy of the top 10 happiest countries and bottom 10 happy countries. So for that I'm going to run you through the code and we'll see the visualization side by side. Okay, so I have my code written in these two cells. So first I'm going to find out the top 10 happiest countries, and then I'm going to find the bottom 10 happiest countries. So for that I'm using the head function and I have passed in 10 since I want the top 10 country names, and to get the bottom 10 countries as per their happiness score I am using the tail function. So let me just run it. So we have saved the result in two variables, top underscore 10 and bottom underscore 10, and to create the bar plots we are using two different codes. So here you can see I have set my figure size and axis, and then I have my X label as country name. After that I am setting my title of the bar plot to top 10 happiest countries life expectancy. I've used my X tick labels and I am rotating it by 45 degrees, and I have my horizontal alignment as right. You can see it here. We have used the bar plot function. I have the x-axis as country name and y-axis as healthy life expectancy column, and I have set my axis. Then I am using the X labels and Y labels as country name and life expectancy. And similarly, I have my bar plot for the bottom 10 least happy countries life expectancy. Let's just run it and we'll see the result. There you go. Now if I scroll down, you can see we have two different bar plots. The first one is for the 10 happiest countries, and then we have the bottom 10 least happy countries. So if you see, on an average, the top 10 happiest countries life expectancy is above 70 years. So if you are from one of these countries, you are expected to live for more than 70 years. Now if you check the bottom 10 least happy countries, you see here Lesotho has less than 50 life expectancy age, and most of them are less than 60 years. So if you are from one of the top 10 happiest countries, you are expected to live 10 years more than these countries that lie in the bottom 10 region. Cool. Now moving ahead. Alright, so now we are going to see the plot between freedom to make life choices and the happiness score. For this I am going to use a scatter plot. So I'll first define my figure size. So I'll say plt dot rcparams, which stands for parameters. I'm going to pass in my figure size. So I'll say figure dot fig size equal to, let's say 15,7. Then using the Seaborn library and the scatterplot function, we'll pass in the x-axis. Let's say the x-axis is my data frame name happy_df, and I'll have the freedom to make life choices in the x-axis. So the column name is freedom_to_make_life and choices. I'll give a comma and we'll pass in the y-axis. Again I'm going to use my data frame name dot, and I'll have the happiness score. I'm also going to pass in a hue parameter to differentiate the different regions. So I'll say df dot regional_indicator, and I'll give the size of the dots or the bubbles as, let's say, 200. Now I'll say plt dot legend. I'll place the legend at upper left corner, so I'm giving the location, which is LOC equal to upper left, and font size, let it be 12. I'll say plt dot x label as freedom to make life choices, and my y label would be happiness score. Alright, now we have the code written for the scatter plot that I want to create. Let me just run it. There you go. So here we have the legend for the different regions, and we have the different colors for each of these regions, and you can see here I have on the x-axis freedom to make life choices, and on the y-axis we have the happiness score. So you can see it very clearly. For the countries that lie in the Western Europe region, the blue dots, the freedom to make life choices is more, and so is the happiness score. Then if you see the values in the green region, which is for Middle East and North Africa, the freedom to make life choices is lower, and hence the happiness score is also low. And for all these countries that are part of the sub-Saharan Africa, some of them have decent score for freedom to make life choices, but the happiness score is low again. Now if you focus on the pink dots, which is for the Southeast Asian countries, the happiness score is comparatively lower, but the freedom to make life choices is more than 0.8. Cool. And again we have one data point which is lying at the bottom. We can assume this is Afghanistan. So in Afghanistan the freedom to make life choices is very low, and even the happiness score is really low. Cool. Now moving to our next analysis, we are going to see the top 10 most corrupt countries. So first I am going to sort the perceptions of corruption column and find out the top 10 countries in the list. So for that I'm going to create a variable called country. I'll have my data frame name, that is happy_df dot sort_values by, I'm going to sort by column that is perceptions of corruption dot head, and I want to find the top 10 most corrupt countries as per the poll. And then I'm going to pass in the figure size. So I'll say plt dot rc params, and then I'm going to set the figure size. So I'll say figure dot fig size. Make sure there is no spelling mistake. Let's say the figure size is 12,6. I'll pass in the title. So I'll say plt dot title. Let's say the title of my plot is going to be countries with most perception of corruption. After that I'll say plt dot x label. In the x label I'll have country, and I'll set the font size to 13. Then I'll say plt dot y label. In y label I'll have the corruption index. Next I'll pass in the font size for the y label. Again it is going to be 13. Now I'll say plt dot x ticks. I'm going to rotate it by 30, and I'll say horizontal alignment equal to right, and then I'll have my bar function or the bar plot function. So I'll say plt dot bar. I'm going to pass in country dot country underscore name, and then we'll have my variable country dot the column name, that is perceptions of corruption. Alright, now if I run it, you can see here, so these are the countries with the least perceptions of corruption. So Singapore has the lowest corruption index, and then we have Rwanda, Denmark, Finland. Now if you want to see the countries with the highest perceptions of corruption, you need to change this head to tail of 10. since we are sorting it in ascending order, so we would want to know the bottom 10 countries. If I run it, there you go. So these are the countries with the most perception of corruption. You have Slovakia, Lesotho, Kosovo, there's Ukraine, Afghanistan, Bulgaria, Romania and Croatia. All of these countries have a corruption index of more than 0.85. Cool. Now coming to the final section of this interesting video on happiness report data analysis for 2021, I want to visualize a scatter plot that will tell us how the corruption varies in terms of happiness score. So I'll just say a comment as corruption versus happiness. Okay. So first of all, I'll set my figure size. So I'll say plt.rc params. Within single quotes, I'll give the figure size as 15,7. Then I'm going to use the scatterplot function that is part of the Seaborn library. In the x-axis, I'll have my column that is corruption, or rather we'll have the happiness score in the x-axis. So I'll say happy underscore df dot column name that is happiness score. Let me give a comma, and in the y-axis we'll have the corruption column. So I'll say happy underscore df dot perceptions of corruption. And then in hue we'll have the region that is regional underscore indicator. So I'll say happy underscore df dot regional indicator. And I'm going to give the size of the dots. So I'll say s equal to 200. Then I'm going to say plt dot legend. I'm going to put it at lower left corner this time. So I'm giving my location as lower left, and the font size of the legend I want is 14. After that, I'll just say plt dot x label as corruption and plt dot y label as happiness score. Now this should rather be the opposite, since in the x-axis we have taken happiness score. So we'll put the happiness score label in x and I'll have corruption in y. Alright, so I have my scatterplot code ready. Let me just run it. There you go. So here you can see on the lower left I have the different regions, and on the x-axis I have the happiness score. On the y-axis I have the corruption index. Now you can see the general trend as per the scatter plot, that the countries with greater happiness score have lower corruption index. So you can see these countries which are from the Western European regions have highest happiness score, and their corruption is also really low. So all these blue countries, you can name a few: Finland, we have Sweden, we have Belgium, France, Netherlands lying in these regions. We also have a few countries from North America and ANZ, which are essentially Australia. Then we also have Canada, US and New Zealand. Okay, now if you focus on these green region, this region, now these are the countries from the sub-Saharan Africa, and most of the countries from these regions have a very low or less than 5 happiness score, but the corruption is also really high. You can see here they have almost more than 0.7 in the corruption index. Now you also have a country here which is from the Southeast Asia. We would like to give you a task. It would be really great if you can tell us in the comment section which country is this. It has more than 6 happiness score, but the corruption index is really low, which is less than 0.2. Now if you consider Middle East and North African regions, the darker green countries, here also if you see the happiness score is less than 5 and the corruption index is also high. Now there are a few countries, the Commonwealth of Independent States, for example countries such as Uzbekistan, then you also have Kazakhstan, we have Russia, Armenia belonging to these gray color dots. You also have Georgia and Ukraine as part of Commonwealth of Independent States. So here you see the corruption is below 0.6 for these countries and the happiness score is more than 5. Alright, so with that we have come to the end of this demo session on World Happiness Report 2021 data analysis using Python. Hello everyone, welcome to this exciting video on Olympics dataset analysis using Python by Simplilearn. This is going to be a very interesting and interactive session where I'll give you a brief about the history of Olympics and throw some light into the recently held Tokyo Olympics. But we'll focus more on using Olympics dataset that is available on Kaggle and perform some exploratory data analysis. You will understand how to use different functions in Python to analyze and extract meaningful information. During the course of our discussion, I'll be asking you a few general questions related to the Olympics. Try to answer them in the comment section of the video. So let's begin. The Olympics is one of the biggest sporting events on the planet. It is held every 4 years. The first modern Olympics took place in Athens, Greece in 1896. As per National Geographic, the original Olympics took place in 776 BC. So they began as part of an ancient Greek festival which celebrated Zeus, the Greek god of sky and weather. The rings in the Olympics logo represent the 5 continents: Europe, Africa, Asia, the Americas and Oceania. From 1924 to 1992, the Winter and the Summer Olympics took place in the same year, but now they alternate every 2 years. Before I move on, here is an interesting question for you. Only 2 people have ever won gold medals at both the Summer and the Winter Olympics. Who are those 2 people? Please share your answers in the comment section of the video. We would like to know from you. The Summer Olympics in Tokyo began on the 23rd of July and recently concluded on the 8th of August. We got to witness some thriller matches that went down to the wire, some amazing victories, and sadly there were a lot of heartbreaks as well. Winning and losing are part and parcel of any game. Fans across the world were really happy to see this global event happen this year following last year's postponement due to the coronavirus pandemic. With our Olympic fever high, let's take this opportunity to work around a project to perform exploratory data analysis using Python to analyze and visualize past Olympics data and answer specific questions. In this video, we will be using specific Python libraries such as NumPy, Pandas, Matplotlib and Seaborn to make sense of our data and extract meaningful information. We are going to visualize our results with different charts and graphs. Before I show you the dataset that we are going to use for our analysis, I have another general question for you. Which is the first Olympics where all the participating countries sent female athletes? I repeat, which is the first Olympics where all the participating countries sent female athletes? Put the year and the city name where the Olympics was held in the comment section of the video. We'll be more than happy to hear from you. Now, let me go ahead and show you the datasets that we'll be using in this video. So here you can see I have my Olympics dataset folder that has 2 datasets. These are CSV files. One is called the athlete_events and the other one is called NOC_regions. So we'll be using these 2 datasets. These datasets can be downloaded from Kaggle. We will post the dataset links in the description of the video. Please go ahead and download them. These datasets have been directly taken from the internet. Now I'll show you the datasets. So this is my first dataset. You can see on the top athlete_events. So I have around 15 columns. You can see the count here, and there are nearly 2,71,116 rows of information. So this is a huge dataset that we are going to use. The other dataset we are going to use in this demo is called NOC_regions. Now here one thing to note is NOC stands for National Olympic Committee. This is a 3-letter code that is given by the Olympic Committee. We have the region names. So AFG is for Afghanistan. You have ALB for Albania, ALG for Algeria. We have also a column called notes. You find some notes about the region. For example, here Antigua is actually Antigua and Barbuda. Alright, let's move to the first dataset that I showed you. This is our primary dataset for our demo. So these datasets have been directly taken from the internet and were not validated. So the results that you will see in the demo is purely based on the data that we have collected. So the file athlete_events.csv contains nearly 2,71,116 rows of information, and there are 15 columns. So each row corresponds to an individual athlete competing in an individual Olympic event. So here ID is actually a unique number for each athlete. Then we have the name, which is basically the athlete's name. We have the sex or the gender, which is male or F for female. Then we have the age of the athlete, which is in terms of integers. We have the height in centimeters of the athletes. Then we have the weight in kilograms. We have the team name. These are the country names. You have China, Denmark, Netherlands. There are around 200 country names. Then we have the NOC. As I said, NOC is a 3-letter code that stands for National Olympic Committee. We have the games. This games contains the year and the season. You can see here 1992 summer. You also have the Winter Olympic information. Alright. Then we have a specific year column to tell you in which year this event had occurred. Now the year column is also an integer column. We have the season, so whether it was Summer Olympics or Winter Olympics. Then we have the city name. This is the host city. Then we have the sport name. You can see here we have basketball, judo, football, tug of war, speed skating. There are so many. Then we have another column called event, which is the complete event name. As you can see, the sport name is basketball, but the event name is basketball, men's basketball, to be very specific. Again, for speed skating, you have different categories like women's 1000 meters, 500 meters. Alright. Now the final column is the medal column. So it has the information about the athlete, whether the athlete had won a medal, be it gold, silver, bronze, and NA means the athlete did not win any medals. So we'll use these two datasets. Now let's get started with the demo. We'll be using Jupyter Notebook for our analysis. So I'll take you to my Jupyter Notebook right away. I've opened it on Chrome. So this is my Jupyter Notebook that we are going to use. You can see here Olympics dataset analysis. I have already have a few cells that have been filled with some piece of code, and you can see there are some comments written as well. We are going to use this dataset. So let's get started. First and foremost, we'll import the datasets. So we are going to use NumPy, Pandas, Matplotlib, and Seaborn. Let me hit Shift Enter to import all the libraries. Alright. Now the next thing is to load the datasets using Pandas read_CSV function. So I'll create a variable called athletes. I'll say equal to pd dot. I'll use the read_CSV function, and inside this function we'll give the location of the files. So I'll copy this location and here I'll paste. Make sure this is within quotations, and these are all /. I'll give another /, and after that I'll give the file name, that is athlete underscore events dot csv. I'll close the quotation. Let's run it. Okay. Similarly, we will load the second data set. I'll create another variable called regions, so it will have my data frame. I'll use the same function pd.read underscore csv. I'll just copy this file path till here. We'll paste it, and I'll give my second file name, which is noc underscore regions dot csv. You can verify here. The first one is athlete underscore events, the second one is noc underscore regions. Okay, I'll close the quotation and we'll run it again. Okay, there seems to be some error. I think this is regions. Cool. Now moving ahead, let's see the first few rows of both the datasets. I'll use the head function for that. I'll say athletes dot head. So this will print the first 5 rows from my dataset athletes. You can see here from 0 to 4 you have 5 rows of information: the ID, name, sex or the gender, age, height, weight. If I go to the right, you have games, year, season, sport, event and medal. Now let's see the second dataset that we imported or loaded. I'll say regions dot head. It says regions is not defined. Let me cross check it. Okay, I have taken it as region. Let's make it regions. Cool. Now let's run it. There you go. So these are the first 5 rows from our second dataset. You have NOC, region and some notes. Alright. Now the next step is to combine both the datasets. So we'll join the data frames using the pandas merge function. Let me show you how to do it. So this is going to be a horizontal join. I'll create a variable called athletes underscore df. Then I'll use my first variable, which is athletes. I'll say dot merge, which is my function name. I'm going to merge the regions data frame. I'll use the how parameter. In how, I'll give my value as I want to do a left join, and my common column in both the datasets is actually NOC. So I'm going to use the NOC column as my common column to merge both the datasets. Now let's go ahead and print the merged data frame. I'll say athletes underscore df dot head. Let's run it. There you go. So if you see clearly, if I move to the right, you can see here we have added 2 more columns that were present in the second dataset, which was regions. So we have regions and notes added to my first dataset, that is athletes underscore events. Cool. Now one thing to note here is, see, the column names are not consistent. If you see here, the rest of the columns start with a capital letter, but if you see the last 2 columns that we just added now start with a lowercase letter. So we'll use the rename function to make the column names consistent. But before that, let's see the shape of the data frame. So I'll print the shape of the data frame to know the total number of rows and columns. I'll say athletes. If I hit tab, you will see it will give me the prompt, I'll select athletes underscore df. I'll use the shape attribute. Let's run it and see the result. You can see here it gives me the total number of rows, so 2,71,116 rows, and earlier we had 15 columns in the first data set, and now that we have added 2 more columns, so the total number of columns becomes 17 now. Cool. So now it's time to make the column names consistent. So I'll show you how to do it. I'll say athletes underscore df dot, I'll use the rename function, and then I'll say columns equal to, I'll use curly braces, my first column, that is region, I want to change it to region, but the R should be capital now or uppercase. I'll give a comma and then say my second column, this should be region actually. My second column, that is notes, I want to change the first letter to uppercase, so I'll say capital N, the rest all remains same. I'll give a comma here and say in place equal to true. So it will change the column names and will reflect in this athletes underscore df data frame. Let's run it. Now to verify, you can again use the head function. I'll run this again. Let me scroll down and move to the right. You can see the difference. There you go. So we have successfully renamed the last 2 columns, region and notes. Alright. Now moving ahead. Now I'll show you how you can use the info method to print information about a data frame, including the index data type, the column data types, non-null values, and memory usage. So for that you just need to use the info function. So I'll write athletes underscore df dot info. Let's run it. There you go. So here we have the data columns. You can see total 17 columns. You have 2,71,116 rows or entries. Then you have the different column names, and it says non-null and the data type of the column. Below you can see some information about the memory usage. Alright. Next, the describe method is used for calculating statistical information such as mean, standard deviation, the percentiles of the numerical values of the data frame, and much more. It analyzes both numeric and object series and also the data frame column sets of mixed data types. So let me show you how using the describe function you can display some statistical summary. I'll just write describe and give parenthesis. Let's run it. Okay, if I scroll down, you can see here by default the describe function will only give information about numerical columns. So here you can see we have the total count, the mean of each of these columns, you have the standard deviation, the minimum and maximum value, and then we have the 25th percentile, the 50th percentile, and the 75th percentile value of the columns ID, age, height, weight, and year. Alright. Now one thing to notice here is, if you see the year column, the minimum year is 1896. So this is when Olympics started, and until recently the Rio Olympics that was held in 2016. Alright. Now moving ahead. Now let's check if there are any null values present in the columns of the data set. So first I am going to create a variable called nan values, give equal to, I'll say athletes underscore df, and the function to check is, I'll say is na. I'll create another variable called nan underscore columns, and here I'll use the any function. I'll say nan underscore this variable, which is underscore values dot, I'll say any, and I'll print my nan columns variable. So this will display the result in terms of Boolean values. So if there are any null or nan or missing values in any of the columns, it will say true, otherwise it will say false. Let's display the result. There you go. So if you mark here clearly, so there are nearly 6 columns where we have missing values. You have age, height, weight, medal, region and notes columns that have missing values, so hence it has given us true. The rest of the columns do not have any nan or missing values, hence they are false. Alright, let me scroll down. Now let's see the total number of null values for the above 6 columns. So I'll say athletes underscore df dot, I'll use the function is null, and again I'll use the sum function. Okay, this should be is null. If I run it, you can see it here. So our age column has 9474 rows where we have null values. Then we have some null values for the height column as well, for the weight column. So these are the total number of rows where we don't have any information regarding age, height, weight or region. Notes, this medal is self-explanatory because a lot of the athletes who participate in Olympics don't win any medals, so for them the value is NA. Now before I move ahead, I have a question for you people. So the question is, I want you to print the column names containing null values or missing values in the form of a list. So please answer this question and put it in the comment section of the video. We would be happy to know your approach. So the question, I'll repeat it again. I want you people to print the column names containing null values or missing values in the form of a list. So basically on the top we saw there were 6 columns that had null values. I want you to print these 6 columns in the form of a list. Alright, now moving ahead. Now let's see the data for specific countries. Let's say you want to see the athletes who have participated in the Olympic Games from the beginning for India. For that, you can filter your result using a function called query. So let me show you how to do it. I'll say athletes underscore df dot, we'll use the query function, and then I'll say team, which is my column name, should be equal to, and the value I'll give is India. Now let's display the first 5 rows of information or the details for the athletes who are from India. If I run this, okay, there is some error here. Okay, so we need to make sure this entire expression or the condition should be within single quote. I'll just delete this single quote from here and we'll add it in the end. Now let's run it. There you go. So here you can see we have the top 5 rows of the athletes who are from India. You can see here the region is India, you can see the NOC is India, the team is India, and let me go to the left. You can see the name of the athlete, the sex, age. So for age you have some missing values, you have the weight, team, year and everything. Alright, similarly you can also check for Japan. Let me just copy the above code, I'll paste it here, and instead of India I'll say Japan. I'll run it. There you go. So if you see here, you can see all the details are for the athletes who are from Japan. Alright. Now moving ahead. Now I want to know the top 10 countries who have participated since the inception of Olympics in 1896. So for that, I'll create a variable called top_10_ countries. I'll say equal to, I'll use my data frame, that is athletes_df. I'll say dot team. Then I'll use the function value_counts. I'm going to sort my count in ascending order. Just mark the way in which I'm writing the functions. Any error in terms of syntax or the flow will throw you an error. I want to display the top 10 countries. Now let's go ahead and print it. I'll say top_10_ countries. Alright, let me run it. Okay, it has given us an error. Let's debug it. Okay, so this should be value counts and not count. Let's run it again. Another error. Okay, so this should be short_values and not value. Let's run it again. There you go. So here you can see the top 10 countries participating in Olympics since 1896. You have United States, then we have France. So these are the number of participants who have taken part since 1896. So the most number of participants have come from US, then we have France, Great Britain, Italy, Germany, Canada, Japan, Sweden. We also have Australia and Hungary. I'll scroll down. Now we are going to convert this table that we got, or the output that we got, in the form of a graph. So I'm trying to create a bar plot to plot the top 10 countries who have participated in Olympics. So here I'm using the figure function to give the figure size. So these are the dimensions 12,6. Now I'll tell you what this PLT_x means. Just wait for a while. I have given a title to my plot saying overall participation by country, and then using the Seaborn library and the bar plot function, I am plotting the x and the y axis. So my x axis has top. I should make this top 10 countries because above we used top_10_ countries. Similarly for y axis, I'll make it top_10_ countries, and then I'm using a color palette called set2. Let's run it. There you go. So if I scroll down, you can see here we have a nice bar plot. This is a vertical bar plot, and here you can see the bars which represent the different country names. First we have United States, which has the highest participation since the beginning of the Olympics. Then we have France, Great Britain, Italy, Germany, Canada, and we have the rest of the countries. Cool. Now moving ahead, the next visualization we are going to see is the age distribution of the athletes. So for this, we are going to create a histogram. I'll be using the matplotlib library specifically for this visualization. So I'll say plt.figure. We'll give the figure size using the argument fig size equal to, and this will be a tuple actually. My size is going to be 12,6. I'll say plt dot title. Now you can give any title that you want. I'll say age distribution of the athletes. Then we'll also give the x labels. I'll say plt dot x label. This will have age. Then we'll say plt dot y label, and this will have the label as number of participants. Next, I'm going to use the hist function, so I'll say plt.hist, and I'll pass in my data frame, that is athletes underscore df dot age, which is my column name, comma, I'm going to pass in the bins. For that I'm going to use the np.arange function, so np is for numpy, and inside this I'll say 10, 80, 2. So my bins will start from the value 10 and go until 80 with a size of 2, comma, I'll give another parameter that is going to specify the color of the bins. I want my color to be orange, and then I'll use the edge color to separate the bins. I'll say edge color, this is the parameter or the argument name, and the color I want is white. Let's give a semicolon here, and this should be edge color. There's a spelling mistake here. Now let's run it and we'll see the output. So there you go. So this is a nice histogram that shows the distribution of the age of the athletes. You can see the title age distribution of the athletes. On the y-axis you have the number of participants. On the x-axis we have the age values ranging from 10 to 80 with a size of 2. And if you see this, we have most number of athletes who have an age between 20 to 30. You can see here. So early 20s we have maximum number of athletes participating in the Olympics. We also have a few athletes who are beyond 40 years of age. You can see here we have a few athletes even closer to 60 also, and similarly we have a few athletes who are under 18 years of age. Alright, now you can see here the bins we had taken orange color, so all the bars are represented in orange color, and the edge you can see here we have the white color. Alright, now moving ahead. Now in the initial slides of the video we discussed the Summer and Winter Olympic Games. Let's look at the different sporting events that are part of the Summer and Winter Olympic Games. Just to give you a heads up, the Winter Olympic Games are held once every 4 years for sports practiced on snow and ice. So here I have my variable name winter underscore sports, so I'm extracting for season equal to winter, and I am going to display only the unique values. Now let me run this cell. Okay, so you can see here these are the different winter sports that are held during the Winter Olympics. Now similarly, let's see for Summer Olympics. So what I'm going to do here is I'll just copy this cell of code and we'll edit the variables. I'll say summer underscore sports, athletes underscore df remains the same. Here season we'll change it to summer, dot sport dot unique remains the same, and here I'll say summer underscore sports. This should be small. Now let's run it. There you go. So here you can see we have more number of Olympic sports that are held during the Summer Olympics compared to Winter Olympics. So these are the sports that are played on snow and ice, and these are the sports that are played during summer. Moving ahead, now it's time to analyze the total number of male and female participants who have taken part in different games since 1896 till 2016 Rio Olympics. Alright, so I'll say gender underscore counts, which is my variable name. I'll use my data frame, that is athletes underscore df dot my variable name, that is sex, dot value underscore counts, and then we are going to print gender underscore counts. Let's run this. There you go. So since the inception of Olympics, we have more number of male participants than female participants. Now here in this current cell, you can see we are trying to plot a pie chart for male and female athletes. So I have given my figure size, then I have my title as gender distribution. I'm using the matplotlib library and the pie function. I'm using the variable gender counts that we used here. Then I'm giving my labels as gender underscore counts dot index. Now I'm using this auto PCT. The auto PCT parameter enables you to display the percent value using Python string formatting. So this is my string formatting that I have used, and I'm initialized my start angle for the pie chart as 150 degrees, and I'm also giving shadow to my pie chart. So I have written shadow equal to true. Let's run it. Alright, so you can see here this is my pie chart that shows you the distribution of the male and female participation. So for male it is 72.5%, for female so far it is 27.5% as per the dataset that we have. Now you can change this start angle to, let's say, 180 degree, and it will change the pie chart to this direction. Cool. Now moving ahead, this time we are going to find the total number of medals that the athletes have won. So I'll use my data frame athletes underscore df dot, and then my column, that is medal, I'll say dot value underscore counts. Let's run it. There you go. So you can see the gold medals, the bronze medals and the silver medals are very much similar to each other. The numbers are pretty much the same. Alright, now it's time to focus on the total female athletes who have taken part in each Olympics. So I'll create a variable called female underscore participants. I'll say equal to, and then use my data frame name, that is athletes underscore df. Using square brackets, I'll say athletes underscore df dot the gender should be equal to female, and I'll use ampersand. I'll say, just copy this, paste it here. I'll say dot season equal to, we'll check for Summer Olympics, and I want to extract only the gender column. So here it is sex, comma, my year column, which is year. Okay, and then I'll say female underscore participants equal to, I'll just copy this, paste it here, and then I'll use the group by function. Say group by, which is part of the pandas library. I'll say year, and then I want to find the count. I'll reset the index, say reset underscore index is a function, and finally we are going to print female underscore participants, and let's say the head. Alright, so what we are trying to do is, I'm trying to filter my data only for the female athletes for Summer Olympics, and here I am printing the participation based on each year, so I'm finding out the count. So here we need to add one more square bracket. Alright, now we'll run it and see the result. There you go. So you can see here from 1900, 1904, all these years you can see the female participation. Let me change it to tail so that we have the recent data of the Olympics. You can see it here. For the Beijing Olympics, 5,816 women athletes participated. In 2012 London Olympics, we had 5,815 Olympics. Similarly, for the 2016 Rio Olympics, we had more participation than the London Olympics. So 6,223 women athletes had participated. Alright. Now here, this is another way in which you can filter your data for female athletes. So I'm using two parameters. My gender should be equal to female and season is Summer Olympics. Let me just run it. I have stored it in a variable called Women Olympics. Now here I am trying to find a count plot, or I am trying to create a count plot using my Seaborn SNS library. I have set my style to dark grid. Then my figure size I have given as 20,10. My count plot will have the x-axis as year. The data is Women Olympics, and palette I am using as spectral, and then I have given a title Women Participation. Let's run and see the output. There you go. If I scroll down, you can see on the top I have the title for my count plot, which says Women Participation, and on the y-axis I have the count, and at the bottom you can see the different year values from 1900 till 2016, and 2016 had the highest number of female participation. Cool. Let me scroll down. So in this cell of code we are trying to plot a line graph. Let me run it and show you the output. So this line graph shows the trend, which says plot for female athletes over time. So here you can see the line graph. So gradually the women participation has increased in Olympics since its inception. There was a slight decrease here. This is around 1950s, and again you can see here there's a decrease with the women participation in 1980, but since then, since 1980, there has been continuous increase in the participation of female athlete numbers. Cool. Now coming to the next section of our analysis. Now we are going to filter the data to see the details of the athletes who have won gold medals. So I'll create a variable called gold medals. It's equal to, I'll use my data frame as athletes underscore df, and within parenthesis I'll use my data frame name, which is athletes underscore df dot, I'll use the condition medal equal to, and my value would be gold. Next, I'm going to say gold medals dot head. Let's run it. There you go. So here we have the top 5 rows of the athletes who have won a gold medal. You can see all the records have medal as gold. Now we are going to use this subset of the data and perform some more analysis. So here I want to take only the values that are different from NaN. So I'm going to use is finite function, and inside that I have set gold medals age. Let me just run it. Cool. Now I want to see the athletes who have secured a gold medal beyond the age of 60 years, which is very rare. So we'll see the total number of athletes with more than 60 years of age having won a gold medal. So here I'm going to say gold medals. I'll use my column as ID, and then I'll use my variable gold medals, and then I'll say age should be greater than 60, and then I'll close my square bracket and say count. Okay, let me just verify if everything's fine. Yeah, I'll run it and we'll see the result. So there are total 6 athletes who have won a gold medal having age more than 60 years. Cool. Now let me check for which sport these 6 gold medals have come. So I'll say sporting underscore event. This is going to be my variable name, equal to, I'll use the same variable name, gold medals. I'll going to choose my sport column, and then I'll give my condition age greater than 60. Now let's go ahead and we'll print the variable sporting event. If I run this, you can see it here. So for art competitions, even for archery and shooting, and this one called rook, we have had gold medals from athletes who had an age more than 60 years. Now we are going to plot this result or the table that we achieved on the top. So I'll say plt dot figure. I'll give my figure size equal to, let's say 10,5. Then I'll say plt dot, we'll use the tight layout, say tight underscore layout. Then I'm going to use the Seaborn library and create a count plot for my variable sporting underscore event. Then I'll say plt dot title. I'll give the title as gold medals for athletes over 60 years of age. Let's run it, and if I scroll down, you can see here we have a nice count plot. I have my title gold medals for athletes over 60 years, and since for archery we had 3 players who secured a gold medal having an age more than 60 years. You can see here archery is 3, art competition 1, rook is 1, and shooting we had 1 medal. Alright, now we'll see the total gold medals from each country. So for that I'll say gold medals dot, we'll use the region column, and followed by that I'll use the value underscore counts function, and I'll reset the index with name equal to, I'll provide the medal column. Then we are going to print the head for the top 5 countries. Let me run it. You can see it here. So USA has secured the most number of gold medals. Then we have Russia, Germany, UK, and then we have Italy. Cool. Now in this cell I am going to create a plot to visualize the table that I got above. So I've used my labels, my titles. I'm using the cat plot function that is present in the Seaborn library. I have my x-axis, my y-axis, the data which is total gold medals. Let me just verify. Okay, and we'll run it. If I scroll down, you can see this is a different palette that I had used, which is a rocket, and you can see USA has got the most number of gold medals. Then we have Russia, Germany, UK, Italy and France. Now we also have included France here, which was not present in this table. The reason being I have used head as 6. So it will give me the top 6 countries. Alright. Now we will analyze and look at the data for the most recent Olympic event that is present in our dataset. I'm talking about the 2016 Rio Summer Olympics. So first of all, I'll create a variable called max year, which will be equal to my data frame name athletes underscore df, my column name year, and I'll use the max function. Then let's go ahead and print my max year. I'll just show you the output. You can see here my max year present in the dataset is 2016, the Rio Olympics. Next, we will create another variable called team underscore names that will be equal to my data frame name athletes underscore df. Within square brackets, I'll give parenthesis and then say athletes underscore df dot year should be equal to my output, that is max year, which is actually 2016, and then I'll say ampersand. I'll just copy this, we'll paste it here. This time I'll use the medal column and say equal to gold. I'll say dot team. Then I'll say team underscore names dot value underscore counts dot head, and will display the top 10 countries. Let me run this. There you go. So in Rio Olympics, United States secured the most number of gold medals. Now the reason this is 137 is we have also counted the team events, for example basketball. Similarly, Great Britain had 64 gold medals in total, Russia 50, we have Brazil 34, Argentina 21, France 20 and Japan 17. Alright. Now using the above result, we are going to create a bar plot. I'll just change this team underscore list to team underscore names. Similarly here also I'll make the corrections as team underscore names. Cool. Now we'll run it, and you can see here we have a nice horizontal bar plot. So we have United States at the top, Great Britain, Russia, Germany, China, Brazil. So here I am displaying the top 20 nations since I have used head as 20. So these are the top 20 nations who secured the most number of gold medals in the Rio Olympics. Alright. Now in the final section of this video, we will create a scatter plot to visualize the height and weight of male and female athletes who have won a medal. Now it can be a gold medal, a silver medal or a bronze medal. But before that, we need to filter the data only for athletes who have won a medal. Now if you had noticed here, our medals column also had a few null values, so we are not going to consider those null values here. we are only going to consider for the athletes who have won a medal. So for that, I'll create a variable called not_null_medals equal to, I'll say athletes_df, then I'll give my, let's make it df, I'll give my condition. Let me just copy this, I'll paste it here, and then I'll give my condition height and use the not null function, and then I'll say ampersand, create another parenthesis, I'll say athletes_df. This time we'll consider the weight column. Again, I'll use the function as not null, and I'll close the parenthesis. Okay, I had missed one S here. Cool. Let me just run it now. Alright. Now we are going to create our final plot. I'll say plt.figure. I'll give my figure size equal to, I'll say 12,10. I'll say axis equal to SNS dot. We'll be creating a scatter plot to plot the height and weight of the athletes who have won a medal. I'll say scatter plot. In my x-axis I'll have height, comma, in my y-axis I'll have weight, comma, my data should be not_null_medals. So this is what we created here, not_null_medals, comma, I'll use hue equal to my sex column. Cool. Finally, I'll say plt dot, I'll give a title to my plot saying height versus weight of Olympic medalists. Cool. Now let's see our scatter plot. This might take some time to give the result because there are so many athletes present in a dataset who have won a medal, and also we are filtering in terms of hue, which is for male and female. There you go. So if I scroll down, you can see here we have a nice scatter plot. On the top we have the title of the plot saying height versus weight of Olympic medalists. You can see our age as the hue. So blue points are for the male athletes and orange points are for the female athletes. And on the y-axis we have the weight in terms of kilograms, and you have the height in terms of centimeters. Cool. So that brings us to the end of this demo session on Olympics dataset analysis. So we used two datasets to carry out this exploratory data analysis, and we created some visualizations to analyze and visualize the data. Alright.
Hello and welcome to Data Analytics Interview Questions. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. Today we're going to jump into some common questions you might see on NumPy arrays and Pandas data frames in the Python, along with some Excel, Tableau, and SQL. Let's start with our first question. What is the difference between data mining and data profiling? It's real important to note that data mining is a process of finding relevant information which has not been found before. It is a way in which raw data is turned into valuable information. You can think of this as anything from the sales stats and from their SQL server all the way to web scraping and Census Bureau information. Where the heck do you mine it from? Where do you get all this data and information? Then we look at data profiling. Is usually done to assess a data set for its uniqueness, consistency, and logic. It cannot identify incorrect or inaccurate data values. So if somebody has a statistical analysis on one side and they're doing you might the wrong data to then program your data setup. So you got to be aware that when you're talking about data mining, you need to look at the integrity of what you're bringing in, where it's coming from. Data profiling is looking at it and saying, hey, how is this going to work? What's the logic? What's the consistency? Is it related to what I'm working with? Define the term data wrangling and data analytics. Data wrangling is a process of cleaning, structuring, and enriching the raw data into a desired usable format for better decision making. And you can see a nice chart here with our Discover It. We structure the data how we want it. We clean it up, get rid of all those null values. We enrich it, so we might take and reformat some of the settings. Instead of having 5 different terms for height of somebody, in American, English, or whatever, we clean some of that up, and we might do a calculation and bring some of them together. And validate. I was just talking about that in the last one. You need to validate your data. Make sure you have a solid data source. And then, of course, it goes into the analysis. Very important to notice here in data wrangling, 80% of data analytics is usually in this whole part of wrangling the data, getting it to fit correctly. And don't confuse that with data cooking, which is actually when you're going into neural networks, cooking the data so it's all between 0 and 1 values. What are common problems that data analysts encounter during analysis? Handling duplicate and missing values, collecting the meaningful right data the right time, making data secure and dealing with compliance issues, handling data purging and storage problems. Again, we're talking about data wrangling here. 80% of most jobs are in wrangling that data and getting it in the right format and making sure it's good data to use. Number 4, what are the various steps involved in any analytics project? Understand the problem. We might spend 80% doing wrangling, but you better be ready to understand the problem, because if you can't, you're going to spend all your time in the wrong direction. This is probably the most important part of the process. Everything after it falls in, and then you can come back to it. 2, data collection, data cleaning. Number 3, 4, data exploration analysis, and 5, interpret the results. Number 5 is a close second for being the most important. If you can't interpret what you bring to the table to your clients, you're in trouble. So when this question comes up, you probably want to focus on those 2, noting that the rest of it does, 80% of the work is in 2, 3, and 4, while 1 and 5 are the most important parts. Which technical tools have you used for analysis and presentation purposes? Being a data analyst, you are expected to have knowledge of the below tools for analysis and presentation purposes. There's a wide variety out there. SQL Server, MySQL, you have your Excel, your SPSS, which is the IBM platform, Tableau, Python. You have all these different tools in here. Now, certainly a lot of jobs are going to be narrowed in on just a few of these tools. Like, you're not going to have a Microsoft SQL Server and MySQL Server, but you better understand how to do basic SQL polls, and also understanding Excel and how the different formats for column and how to get those set up. Number 6, what are the best practices for data cleaning? This is really important to remember to go through this in detail. These always come up because 80% of most data analysis is in cleaning the data up. Make a data cleaning plan by understanding where the common errors take place and keep communications open. Identify and remove duplicates before working with the data. This will lead to an effective data analysis process. Focus on the accuracy of the data, maintain the value types of data, provide mandatory constraints, and set cross-field validation. Standardize the data at the point of entry so that it is less chaotic, and you will be able to ensure that all the information is standardized, leading to fewer errors on entry. Number 7, how can you handle missing values in a data set? Listwise deletion. In listwise deletion method, entire record is excluded from analysis if any single value is missing. Sometimes we're talking about records. Remember, this could be a single line in a database. So if you have your SQL comes back and you have 15 different columns, every one of those that has a missing value, you might just drop it just to make it easy because you already have enough data to do the processing. Average imputation. Use the average value of the responses from the other participants to fill in the missing value. This is really useful, and they'll ask you why these are useful, I guarantee it. If you have a whole group of data that's collected and it doesn't have that information in it, at that point you might average it in there. Regression substitution. You can use multiple regression analysis to estimate a missing value. That kind of goes with the average imputation input. Regression model means you're just going to actually generate a prediction as to what you think that value should be for those people based on the ones you do have. Multiple imputation. So when we talk about multiple inputs, it creates plausible values based on the correlations for the missing data, and then average the simulated data sets by incorporating random errors in your predictions. What do you understand by the term normal distribution? And the second you hear the word normal distribution, should be thinking a bell curve like we see here. Normal distribution is a type of continuous probability distribution that is symmetric about the mean, and in the graph, normal distribution will appear as a bell curve. The mean, median, and mode are equal. That's a quick way to know if you have normal distribution, is you can compute mean, median, and mode. All of them are located at the center of the distribution. 68% of the data lies within one standard deviation of the mean. 95% of the data falls within 2 standard deviations of the mean. 99.7% of the data lies within 3 standard deviations of the mean. What is time series analysis? Time series analysis is a statistical method that deals with ordered sequence of values of a variable of equally spaced time intervals. Time series data on a COVID-19 cases. And you can see we're looking at by days, so our space is of days, and each day goes by. If we take and graph it, you can see a time series graph always looks really nice if you have like 2 different, in this case we have the United States going over there. I'd have to look at the other setup in there, but they picked a couple different countries. And it's time sensitive. With the next result is based on what the last one was. COVID's an excellent example of this. Anytime you do any word analytics where you're figuring out what someone's saying, what they said before makes a huge difference as to what they're going to say next. Another form of time series analysis. 10. How is joining different from blending in Tableau? So now we're going to jump into the Tableau package. Data joining. Data joining can only be done when the data comes from the same source. Combining 2 tables from the same database or 2 or more worksheets from the same Excel file. All the combined tables or sheets contains common set of dimensions and measures. Data blending. Data blending is used when the data is from 2 or more different sources. Combining the Oracle table with the SQL server, or 2 sheets from Excel, or combining Excel sheet and Oracle table. In data blending, each data source contains its own set of dimensions and measures. How is overfitting different from underfitting? Always a good one. Overfitting. Probably the biggest danger in data analytics today is overfitting. Model trains from the data too well using the training set. The performance drops significantly over the test set. Happens when the model learns the noise and random fluctuations in the training data set in detail. And again, the performance drops way below what the test set has. The model neither trains the data well nor can generalize to new data. Performs poorly both on train and the test set. Happens when there is less data to build and an accurate model, and also when we try to build a linear model with a nonlinear data. In Microsoft Excel, a numeric value can be treated as a text value if it proceeds with an apostrophe. Definitely not an exclamation. If you're used to programming in Python, you'll look for that hash code, and not an amber sign. And we can see here, if you enter the value 10 into a field, but you put the apostrophe in front of it, it will read that as a text, not as a number. What is the difference between count, count A, count blank, and count if in Excel? We can see here when we run in just count, D1 through D23, we get 19. And you'll notice that there is 19 numbers coming down here. And so it doesn't count the cost of each, which is the top bracket, and it doesn't count the blank spaces either with the straight count. When you do a count A, you'll get the answer is 20. So now when you do count A, it counts all of them, even the title cost of each. When you do count blank, we'll get 3. Why? There's 3 blank fields. And finally, the count if. If we do count if of E1 to E23 is greater than 10, there's 11 values in there. Basic counting of whatever's in your column, pretty solid on the table there. Explain how VLOOKUP works in Excel. VLOOKUP is used when you need to find things in a table or arrange by row. The syntax has 4 different parts to it. We have our lookup value, that's a value you want to look up. We have our table array, the range where the lookup value is located, column index number, the column number and range that contains the return value, and the range lookup. Specify true if you want an approximate match or false if you want an exact match of the return value. So here we see VLOOKUP F3 A2 to C8 2, 0 for prints. Now they don't show the F3. F3 is the actual cell that prints is in. That's what we're looking at is F3. So there's your prints. He pulls in from F3. A2 to C8 is the data we're looking into. And then number 2 is a column in that data. So in this case we're looking for age. And we count name as 1, age as 2. Keep in mind this is Excel versus a lot of your Python and programming languages where you start at 0. In Excel, we always look at the cells as 1, 2, 3. So 2 represents the age. 0 is false for having an exact matchup versus 1. We don't actually need to worry about that too much in this. 0 or 1 would work with this example. And you can see with the Angela lookup, again, her name would be in the F column number 4. That's what the F4 stands for, is where they pulled Angela from. And then you have A1 to C8, and then we're looking at number 3. So number 3 is height, name being 1, age 2, and then height 3. And you'll see here it pulls in her height, 5.8. So we're going to jump over to SQL. How do you subset or filter data in SQL? To subset or filter data in SQL, we use where and having clause. And you can see we have a nice table on the left where we have the title, the director, the year, the duration. We want to filter the table for movies that were directed by Brad Bird. Why? Just because we want to know what Brad Bird did. So we're going to do select star. You should know that the star refers to all. In this case, what are we going to return? We're going to return all title, director, year, and duration. That's what we mean by all. From movies, movies being our table, where director equals Brad Bird. And you can see he comes back and he did The Incredible and Ratatouille. To subset or filter data SQL, we can also use the where and having clause. So we're going to take a closer look at the different ways we can filter here. Filter the table for directors whose movies have an average duration greater than 115 minutes. So there's a lot of really cool things into this SQL query, and these SQL queries can get pretty crazy. Select director, sum duration as total duration, average duration as average duration from movies, group by director having average duration greater than 115. So again, what are we going to return? We're going to return whatever we put in our select, which in this case is director. We're going to have total duration, and that's going to be the sum of the duration. We're going to have the average duration, average underscore duration, which is going to be the average duration on there. And then we, of course, go ahead and group by director. And we want to make sure we group them by anyone that has having an average duration greater than 115. These SQL queries are so important. I don't know how many times the SQL comes up, and there's so many different other languages, not just MySQL and not Microsoft SQL, but in addition to that, where the SQL language comes in, especially with Hadoop and other areas. So you really should know your basic SQL. Doesn't hurt to get that little cheat sheet and glance over it and double check some of the different features in SQL. What is the difference between where and having clause in SQL? Where clause works on row data. In where clause, the filter occurs before any groupings are made. Aggregate functions cannot be used. So the syntax is select your columns from table where what the condition is. Having clause works on aggregated data. Having is used to filter values from a group. Aggregate functions can be used, and the syntax is select column names from table where the condition is, grouped by, having a condition ordered by column names. What is the correct syntax for reshape function in NumPy? So we're going to jump to the NumPy array program, and what you come up with is you have, in this case it'd be numpy.reshape. A lot of times you do an import numpy as np, reshape, and then your array and the new shape. And you can see here as the actual example comes in, the reshape is A, and we're going to reshape it in 2, 5 setups, and you can see the printout in there that prints in 2 rows with 5 values in each one. What are the different ways to create a data frame in Pandas? Well, we can do it by initializing a list, so you can import your pandas as PD, very common. Data equals Tom 30, Jerry 20, Angela 35. We'll go ahead and create the data frame, and we'll say pd.dataframe is the data, columns equals name and age. So you can designate your columns. You can also designate index in there. You should always remember that the index, in this case, maybe you want the index instead of 1, 2 to be the date they signed up, or who knows, whatever. And you can see right there, it just generates a nice pandas data frame with Tom, Jerry, and Angela. Another way you can initialize a data frame is from dictionary. You can see here we have a dictionary where the date equals name, Tom, Jerry, Angela, Mary. Age is 20, 21, 19, 18. And if we do a df pd.dataframe on the data, you'll get the same kind of setup. You get your name, age, Tom, Jerry, Angela, and Mary. Write the Python code to create an employee's data frame from the emp.csv file and display the head and summary of it. To create a data frame in Python, you need to import the pandas library and use the read CSV function to load the CSV file. And here you can see we have import pandas as PD, employees, or the data frame employees, equals pd.readcsv, and then you have your path to that CSV file. There's a number of settings in the read CSV where you can tell it how many rows are the top index. You can set the columns in there. You can have skip rows. There's all kinds of things. You can also go in there and double check with your read CSV, but the most basic one is just to read a basic CSV. How will you select the department and age columns from an employee's data frame? So we have import pandas as PD. You can see we have created our data. We will go ahead and create our employees PD data frame on the left. And then on the right, to select department and age from the data frame, we just do employees, and then you put the brackets around it. Now, if you're just doing one column, you could do just department. But if you're doing multiple columns, you got to have those in a second set of brackets. So it's got to be a reference with a list within the reference. What is the criteria to say whether a developed data model is good or not? A good model should be intuitive, insightful, and self-explanatory. Follow the old saying, KISS, keep it simple. The model developed should be able to easily consumed by the clients for actionable and profitable results. So if they can't read it, what good is it? A good model should easily adapt to changes according to business requirements. We live in quite a dynamic world nowadays, so that's pretty self-evident. And if the data gets updated, the model should be able to scale accordingly to the new data. So you have a nice data pipeline going where when you get new data coming in, you don't have to go and rewrite the whole code. What is the significance of exploratory data analysis? Exploratory data analysis is an important step in any data analysis process. Exploratory data analysis, EDA, helps to understand the data better. It helps you obtain confidence in your data to a point where you're ready to engage a machine learning algorithm. It allows you to refine your selection of feature variables that will be used later for model building. You can discover hidden trends and insights from the data. How do you treat outliers in a data set? An outlier is a data point that is distant from other similar points. They may be due to variability in the measurement or may indicate experimental errors. One, you can drop the outlier records. Pretty straightforward. You can cap your outliers data so it doesn't go past a certain value. You can assign it a new value. You can also try a new transformation to see if those outliers come in if you transform it slightly differently. Explain descriptive, predictive, and prescriptive analytics. Descriptive provides insights into the past to answer what has happened. Uses data aggregation and data mining techniques. Examples: an ice cream company can analyze how much ice cream was sold, which flavors were sold, and whether more or less ice cream was sold than before. Predictive understands the future to the answer, what could happen. Uses statistical models and forecasting techniques. Example: predicts the sale of ice creams during the summer, spring, and rainy days. So this is always interesting because you have your descriptive, which comes in, and your businesses are always looking to know what happened. Hey, did we have good sales last quarter? What are we expecting next quarter in sales? And we have a huge jump when we do prescriptive. Suggest various courses of action to answer what should you do. Uses optimization and simulation algorithms to advise possible outcomes. Example: lower prices to increase sale of ice creams, produce more or less quantities of certain flavor of ice cream. And we can certainly, today's world with the COVID virus, because we had that on our earlier graph, you could see that as a descriptive. What's happened? How many people have been infected? How many people have died in an area? Predictive: where do we predict that to go? Do we see it going to get worse? Is it going to get better? What do we predict that we're going to need in hospital beds? And prescriptive: what can we change in our setup to have a better outcome? Maybe if we did more social distancing, if we tracked the virus. How do these different things directly affect the end, and can we create a better ending by changing some underlying criteria? What are the different types of sampling techniques used by data analysts? Sampling is a statistical method to select a subset of data from an entire data set, population, to estimate the characteristics of the whole population. One, we can do a simple random sampling, so we can just pick out 500 random people in the United States to sample them. They call it a population. In regular data, we also call that a population, just because that's where it came from, was mainly from doing census. Systematic sampling, cluster sampling, stratified sampling, and judgment or purposive sampling. Then we have our systematic sampling. That's where you're doing like using 1, 5, 10, 15, 20. Use a very systematic approach for pulling samples from the setup. Cluster sampling. That's where we look at it and we say, hey, some of these things just naturally group together. If you were talking about population, which is really a nice way of looking at this, cluster sampling would be maybe by zip code. We're going to do everybody's zip code and just naturally cluster it that way. Stratified sampling would be more looking for shared things the group has, like income. So if you're studying something on poverty, you might look at their naturally group people based on income to begin with, and then study those individuals in the income to find out what kind of traits they have. And then judgmental. That is where the researcher very carefully selects each member of their own group. So it's very much based on their personal knowledge. Jumping on to 26, what are the different types of hypothesis testing? Hypothesis testing is a procedure used by statisticians and scientists to accept or reject statistical hypothesis. We start with the hypothesis testing. We have null hypothesis and alternative hypothesis. On the null hypothesis, it states that there is no relation between the predictor and the outcome variables in the population. It is denoted by H0. Example: there is no association between patients, BMI, and diabetes. Alternative hypothesis, it states there is some relation between the predictor and outcome variables in the population. It is denoted by H1. Example, there could be an association between patients' BMI and diabetes. And that's the body mass index, if you didn't catch the BMI and you're not in medical. Describe univariate, bivariate, and multivariate analysis. A univariate analysis, it is the simplest form of data analysis where the data being analyzed contains only one variable. An example is studying the heights of players in the NBA. Because it's so simple, it can be described using central tendencies, dispersion, quartiles, bar charts, histograms, pie charts, frequency distribution tables. The bivariate analysis, it involves analysis of two variables to find causes, relationships, and correlations between the variables. Example, analyzing sale of ice creams based on the temperature outside. Bivariate analysis can be explained using correlation coefficients, linear regression, logistic regression, scatter plots, and box plots. And multivariate analysis, it involves analysis of three or more variables to understand the relationship of each variable with the other variables. Example, analyzing revenue based on expenditure. So if we have our TV ads, we have our newspaper ads, our social media ads, and our revenue, we can now compare all those together. The multivariate analysis can be performed using multiple regression, factor analysis, classification and regression trees, cluster analysis, principal component analysis, clustering bar chart, dual axis chart. What function would you use to get the current date and time in Excel? In Excel, you can use the today and now function to get the current date and time. And you can see down here with the two examples where just equals today or equals now. Using the SUMIFS function in Excel, find the total quantity sold by sales representatives whose names start with A and the cost of each item they have sold is greater than 10. And you can see here on the left we have our actual table, and then we want to go ahead and SUMIFS. So we want the E2 through E20, B2 through B20 greater than 10. And this basically is just saying, hey, we're going to take everything in the E column and we're going to sum it up, but only those objects where the D column is greater than 10. That's what that means there. Is the below query correct? If not, how will you rectify it? Select customer ID, year, order date as order year from order where order year is greater than or equal to 2016. And hopefully you caught it right there. It's in the devil's in the details. We can't not use the alias name while filtering data using the where clause. So the correct format is all the same except for where it says where the year order date is greater than or equal to 16 versus using the order year, which we assign under the select setup. How are union, intersect, and except used in SQL? The union operator is used to combine the results of two or more select statements. And you can see here we have select star from region 1. We're going to make a union with select star from region 2. And it basically takes both these SQL tables and combines them to form a full new table on there. So that's your union as we bring everything together. When we look at the intersect operator, it returns the common records that are the result of the two or more select statements. So you can see here we select star from region 1, intersect, select star from region 2, and we come up with only those records that are shared, that have the same data in them. And hopefully you jumped ahead to the except. The except operator returns the uncommon records that are the result of two or more select statements. So these are the two records, or the records that are not shared between the two databases. Using the product price table, write an SQL query to find the record with the fourth highest market price. So here we have a little bit of a brain teaser. They're always fun. And the first thing we want to do is we're going to go ahead and if you look at the script on the left, we really want the fourth one down. So we're going to select the top 4 from product price. But we're going to order it by market price descending. SP ordered by market price ascending. So what we do is we take the top 4 of the market price ascending, and that's going to give us the 4 greatest values. And then we're going to reverse that order and do descending. And we're going to take the top one of that, which is going to give us the lowest value, which will be the 4th greatest one in the list. From the product price table, find the total and average market price for each currency where the average market price is greater than 100 and currency is in the INR or the AUD. So INR or AUD, India Rupee or Australia dollar. You can see over here the SQL query. If you had trouble putting this together, you might actually do some of it in reverse. And you can see right here where the average market price is greater than 50. Remember, we use having, not where, at the end because it's part of the group. So group by currency, because we want those 2 currencies. And we want the currency India Rupee, the INR or the AUD. And as you keep going backwards, we're actually going to be selecting the currency, the sum of the market price as total price, and the average market price as average price. So there's our select. It's going to come from the product price, which is just our table over there, and then we have where our currency is in. And like I said, you can put it together however you want, but hopefully you got to the end there. So this question will test your knowledge in Tableau, exploring the different features of Tableau, and creating a suitable graph to solve a business problem. And of course, Tableau is very visual in its use, so it's very hard to test it without actually just getting your hands on. And if you can't visualize some of this and how to do it, then you should go back and refresh yourself. Using the sample superstore dataset, create a view to analyze the sales, profits, and quantities sold across different subcategories of items present under each category. So the first step is to go ahead and load the sample superstore dataset. So make sure you know how to load the sample, the superstore dataset. That's underneath either the connect button in the upper left or the Tableau icon up there, and be able to pull in the data set. And then once you've done that, you just drag the category and subcategory on rows and salaries onto columns. It will result in a horizontal bar chart. So in this one, we're just going to drag profit onto color and quantity onto label. Sort the sales axes in descending order of sum and sales within each subcategory. And if you're at home doing this, you'll see that chairs under furniture category had the highest sales and profit, while tables had the lowest profit. For office supplies, subcategory binders made the highest profit, even though storage had the highest sales. Under technology category, copiers made the highest profit, though it was the least amount of sales. Let's work to create a dual axis chart in Tableau to present sales and profits across different years using sample superstore dataset. Load the orders sheet from the sample superstore dataset. Drag the order data field from the dimensions onto columns and convert it into continuous month. Drag cells onto rows and profits to the right corner of the view until you see a light green rectangle. One of those things, if you haven't done this hands-on, you don't know what you're doing, you're going to run into a bind because you're going to be just kind of dropping it and wondering what happened. Synchronize the right axes by right-clicking on the profit axis. And then let's finalize it by going under the marks card, change some cells to bar and some profit to line, and adjust the size. And then we have a nice display that we can either print out or save and send off to the shareholders. Let's go ahead and do one more Tableau. Design a view in Tableau to show state-wise sales and profits using the sample superstore dataset. In here you go ahead and drag the country field onto the view section and expand it to see the states. Drag the states field onto size and profit onto color. Increase the size of the bubbles, add a border and a halo color. States like Washington, California, and New York have the highest sales and profits, while Texas, Pennsylvania, and Ohio have a good amount of sales but the least amount of profits. We'll go ahead and skip back to Python NumPy. Suppose there is an array number equals NP, or numpy if you're using numpy, depending on how you set it up, dot array, and we just have 1 to 9 broken up into 3 groups. Extract the value 8 using 2D indexing. So you can see on the left we have our import numpy as NP, number equals our NP array. If we print the number, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Since the value 8 is present in the second row and first column, we use the same index position and pass it to the array. And you just have number 2, 1, and you get 8. And remember, we're in Python, so you start at 0, not 1 like you do in Excel. Always gets me if I'm working between Excel and Python, where I just kind of flip, and usually it's the Excel that messes up because I do a lot more programming. Suppose there's an array that has values 0, 1, all the way up to 9. How will you display the following values from the array? 1, 3, 5, 7, 9. So first of all, we go ahead and create the array, np.arange of 10, which goes from 0 to 9, because there's 10 numbers in it, but we don't include the 10. We print it out. The first thing you want to do is, what's going on here with 1, 3, 5, 7, 9? Well, if we divide by 2, there's going to be a remainder equal to 1. And then from Python, remember that if you use the percentage sign, you get the remainder on there. So the remainder is 1. And then you have your numpy array, and then we just want to do a logical statement of all values that have a remainder of 1, and that generates our nice 1, 3, 5, 7, 9. There are 2 arrays, A and B. Stack the arrays A and B horizontally. Boy, these horizontal vertical questions will get you every time. And in NumPy, we go ahead and we've created 2 different arrays over here, A and B. The first one is your concatenate, np.concatenate A and B on axes equal 1. That is the same as hstack. And in the back end, they're still identical. They run the same. That's all hstack is, a concatenate axes equals 1. How can you add a column to a pandas data frame? Suppose there's an imp data frame that has information about few employees. Let's add address column to that data frame. And you can see on the left we have our basic data frame. You should know your data frames very well. Basically it looks like an Excel spreadsheet. As you come over here, it's really simple. You just do df of address equals the address once you've assigned values to the address. Using the below given data, create a pivot table to find the total cells made by each cells represented for each item. Display the cells as a percentage of the grand total. So we're back in Tableau. Select the entire table range, click on Insert tab, and choose Pivot Table. Select the table range and the worksheet where you want to place the pivot table. It will return a pivot table where you can analyze your data. Drag the cell total on the values in cells rep and item onto row labels. It will give the sum of the cells made by each representative for each item they have sold. And finally, right-click on Sum of Cell Total and expand Show Values as to select Percentage of Grand Total. Real important just to understand what a pivot table is. We're just pivoting it from rows and columns and switching this direction on there. And finally, we have our final pivot table, and you can see the values, roles, and sum of total cell. So we're going to go ahead and take a product table. This is off of an SQL, so we're going to do some SQL here. And we're going to use the product and sales order detail table. Find the products that have total units sold greater than 1.5 million. And here's our sales order detail table. So we have a product table and a sales order detail table, 2 separate tables in the database. And what we're going to do is put together the SQL query. We want to select PP name, sum, SOD, unit price as cells. And then we have our pp.product ID from production product as pp inner join, cells.sales order detail as SOD on pp product ID equals SOD.product ID, group by pp.name, pp.product ID having a sum of SOD.unit price greater than the 150 million there. That's a mouthful. And again, these SQL queries, they start looking really crazy until you just break them apart and do them step by step. And what we're looking for is the inner join and how did you do the group by. That's really what they know. How do you do this inner join? This comes up so much in SQL. How do you pull in the ID from one chart and the information from another chart and the sum totals on that chart? How do you write a stored procedure in SQL? Let's create a stored procedure to find the sum, the squares of the first n natural numbers. So here we have our formula, n times n plus 1 times 2n plus 1 over 6. And you can see from the command prompt or the setup you have, depending on what your login is, the command is create procedure square sum 1. Declare a variable at n of integer as begin, and then we're going to declare the sum of integer, set sum equals n times n plus 1 plus 2 times n plus 1 over 6. And then of course we can go ahead and print those out. Print first cast ampersand n, or our variable, as a variable character 20 natural numbers. Print the sum of the square is cast the at sum as variable character 40 end. And then we do the output, display the sum of the square for first 4 natural numbers. We have execute square sum 1, and then we're going to put in 4, and you can see here where it brings up the first 4 natural numbers. Sum of square is 30. Write a store procedure to find the total even number between two user-given numbers. A couple of things to note here. First, we go ahead and create our procedure. You have your two different variables, the n1, n2. And we go ahead and begin. We're going to declare our variable count as an integer. We're going to set count equal to 0. And then we have while n is less than n2. We're going to begin. And if n1 remainder 2 equals 0, so we're going to divide it by 2, even number, begin. We're going to set the count equal to count plus 1. We're going to print even number plus cast n as a variable character 10 for printing. Count is plus cast variable count as variable character 10 end. Else print odd number plus cast variable number 1 as variable character 10. And then we go ahead and set the increment our variable 1 up 1. So it'll go from n1 all the way to n2. And it'll print the total number of even numbers. And you can see here we went ahead and executed it. We're going to count the even numbers between 30 and 45. And you can just see it goes all the way down to 8. What is the difference between tree maps and heat maps in Tableau? Now, if you've worked in Python and other programmings, you should automatically know what a heat map is. But a tree map are used to display data in nested rectangles. You use dimensions to define the structure of the tree map and measure to define the size or color of individual rectangles. Tree maps are a relatively simple data visualization that can provide insight in a visually attractive format. And again, you can see the squares over here. This is our tree map over here with each block also has its information inside of its different blocks. A heat map helps to visualize measures against the dimensions with the help of colors and size to compare one or more dimensions and up to 2 measures. The layout is similar to a text table with variations in values encoded as colors. In heat map, you can quickly see a wide array of information. And in this one, you can see they use the colors to denote one thing and the size of the little square to denote something else. A lot of times you can even graph this into a 3-dimensional graph with other data so it pops out. But again, a heat map is the color and the size. Using the sample superstored dataset, display the top 5 and bottom 5 customers based on their profit. So you start by dragging the customer name field onto rows and profit on columns. Right-click on the customer name column to create a set. Give a name to the set and select Top Tab to choose top 5 customers by sum profit. Similarly, create a set for the bottom 5 customers by sum profit. Select both the sets, right-click to create a combined set. Give a name to the set and choose all members in both sets. And then you can drag top and bottom customer sets onto the filters and profit field onto color to get the desired results. As we get down to the end of our list, we're going to try to keep you on your toes. We're going to skip back to NumPy. how to print 4 random integers between 1 and 15 using NumPy. To generate random numbers using NumPy, we use the random integer function. And you can see here we did the import NumPy as np, random arrangement equals np.random integer 1 through 15 of 4. From the below data frame, going to jump again on you, now we're into pandas. How will you find the unique values for each column and subset the data for age less than 35 and height greater than 6? To find the unique values and the number of unique elements, use the unique and the InUnique function. You can see here we just did df height, so we're selecting just the height column, and we want to look for the unique. That returns an array, where InUnique, if we do that on the height or the age, will return just the number of unique values. And then we can do a subset the data for ages less than 35 and height greater than 6. So if we look over here, we have a new df. Remember, this is going to be taking slices of our original data frame. It doesn't actually change the data frame. So our new df equals the data frame, or df, the data frame where age is less than 35 and the height is greater than 6. And in case you're not using Tableau, which has a lot of its own different mapping programs in there, make sure you understand how to use the basics of Matplot library. Plot a sign graph using NumPy and Matplot library in Python. And the way we did this is we went ahead and generated an x. We know our y equals np.sign of x. If you print out x, you'll see a whole value here. Our Matplot library PyPlot as PLT. If you are working in Jupyter Notebook, make sure you understand the Matplot library inline, that little percentage sign Matplot library inline. That prints it on the page in the Jupyter Notebook. The newer version of Jupyter Notebook or Jupyter Labs automatically does that for you, but I usually put it in there just in case I end up on an older version. If you print y, you can see here we have our different y values and our different x values. You simply put in plt.plot xy and do a plot show. And before we go, let's get one more in. We're going to do a pandas using the below pandas data frame. Find the company with the highest average sales, derive the summary statistics for this sales column, and transpose these statistics. That's a mouthful, and just like any of these computer problems, break it apart. So first of all, we're looking for the highest average sales. So group the company column and use the mean function to find the average sales. And you can see here by company equals df.groupBy company. Once we've done that, using the describe function, we can now go ahead and look at the summary of statistics on here. Use the describe function to find the summary. So by company, those are groups. We're just going to describe them. And you could actually bundle those together if you wanted and just do them all in one line. So here we go, by company.describe. You can see we have a nice breakout. Always good to remember. Whether you're using any of the packages, whether it's Tableau or Pandas in Python, or even R or some other package, being able to quick look and describe your data is very important. And then we can go ahead and just do a basic apply a transpose function over the describe method to transpose the statistics. All we've done here is flip the index with the column names, but if you're following the numbers, a lot of times it's easier to follow across one line, or maybe you want to average out the count, or there's all kinds of different reasons to do that.
And with that, we have come to the end of this video tutorial on Data Analytics Full Course 2022 by Simplilearn. I hope it was really helpful and informative. Thank you and keep learning.